Hey everyone, my name is Brian, and we're going to learn Python 3. This video series is aimed at the complete beginner, so if you have zero programming experience, this is what you need to watch. Now, we're going to start off in this specific video with how to install, configure, and test Python 3. And I'm going to try to make a video a week, so definitely check back often as I'm going to update this series as fast as I can. Let's dive in. Okay, the first step is very simple. Check to see if Python's already installed. Now, you can and probably should use your operating system's documentation to figure out if it's installed, but a very quick way is simply bring open a command line. If you don't know how to open a command line, I highly suggest you go out to Google and learn how to open a command line. It's not super hard. And once you get to this point, type in something like this, Python 3. If you see this right here where it says Python and then some version, it's already installed and ready to go, and you can simply skip the next step. However, if you don't see this, if you get like command not found or unknown command, then you're going to have to follow the next step and actually install Python. Special note, a lot of documentation out there will say type the word Python. This is the older version of Python. This is Python 2. See, right here, ta-da, Python 2. We're going to be working with Python 3. Okay, assuming you ran a command line and tried Python 3 and got a big fat command not found or command unknown, you need to install it. Go out to python.org and then go to downloads. From here, you can either click all release or you can go into your specific operating system. We're going to go to all releases. It will try to auto detect what you're doing. However, you may need to pick your operating system. The vast majority of you are probably going to be on Windows, so I'm just going to click on Windows. Then click on Python 3 release, the latest one. Notice this is a Python 3, not a Python 2. And scroll all the way down. They've kind of got these jumbled up together. You notice how you've got, you guessed it, a tarball, something for Mac, and then stuff for Windows. Windows has the vast majority of the options, and this is why it gets a little bit confusing. Honestly, I'd go with this one, Windows x86-64 executable installer. That's going to be an offline installer. It's going to have everything you need to run, or at least it should. You're going to download that executable and run it. You may be prompted to run as administrator, and you may have to restart your computer when you're done. After you're done installing, you will definitely need to go back and double check. You should be able to open a command line and type Python 3. If you cannot get to this step, you may have to go to Google and look for your specific error message to figure out what's going on. Now that Python's installed and configured and we can bring up a command line and type Python 3, we need to test this thing out, make sure it's actually working the way we expect it to. First things first, I'm just going to drag this up like this to take up the rest of the screen, and we're in what's called the interactive shell or interactive mode. We are not going to be using this very much because, well, it's a bit cumbersome. If you make a spelling mistake, it's impossible to go back and fix it. So we're going to use an IDE, but right now we're just testing. I want you to do something like this. Say, x equals 5 times 3. Now we're going to type the word print, and then let's say x. Notice that's in brackets. We're going to cover all this later. Right now, we're just simply testing. You should see 15 on the screen. To be brutally honest, typing Python 3 and even seeing the version is really the true test that this is working. However, I wanted to show you there is an interactive mode if you want it. Again, though, it's really hard to go back and edit, configure, and you're going to make mistakes. So we're not going to use this at all. We're going to use an IDE, or an integrated development environment, which we're going to cover in the next step. When talking about integrated development environments, well, there are tons and tons of them. If you just go out to Google and type Python IDE, you're going to get, well, millions and millions of results because there's just literally thousands upon thousands of IDEs. To be brutally honest, you don't need anything fancy. You can use a simple text editor. Really what an IDE is a very fancy text editor with a lot of functionality built on top of it. You'll probably find a lot of documentation that says idle comes directly with Python. That's not really true anymore. You got to install it a little bit separately. And personally, I don't like it. I don't think it's the greatest. PyCharm is another good one. but we're going to be using something called Visual Studio Code. And I know a lot of folks really are not Microsoft fans. You're not forced to use this. It's what I'm going to use for this series. And without warning, I may change IDEs halfway through, just depending on what I feel like coding in, because Python makes it super easy to do that. The reason why I'm using Visual Studio Code is, well, it's very simple. It's very straightforward, and this is what it looks like. So all I'm going to do here is I'm going to just add a folder. I'm going to go into Python 3, close this out. Now I need to add in some extensions. And this is what I love about Visual Studio Code is you can extend this to work with just about any language. So I'm going to say Python. And you see there are tons, and I mean a lot. I could just scroll down forever and ever to like infinity and beyond kind of forever. I mean, there's tons of extensions, but it does a good job of putting the best ones right at the top. You can see this guy right here from Microsoft, 26 million views, 5-star rating. You just simply go, okay, do you actually need it? That's a good question, because you could go through and spend hours just installing all of these and not know what you really need. So we're going to take a short detour, go back here. This is simply the folder we opened. I'm going to say new file, and let's call this test.py. And it automatically recommends extensions for us. A Python file will end in .py. So it's detecting that extension and saying, hey, do you want to use the recommended extensions? I'm going to say, you know what? Why not? And it's going to automatically go out there and install them. And then it's going to say installed, and it's used globally. There we go. And we can even click this little gear icon and play around with it if we really felt like. Let's go back to our file, or we can use it up here. Depends on how you want to get there. Now, this is my only real criticism of Visual Studio Code, is it does tend to clutter the UI a little bit. So occasionally you'll see me closing things out. And I'm just going to, well, start using this bad boy. Okay, to wrap this video up, we're going to make what's called Hello World. This is kind of the obligatory first application you're going to make in any programming language. It's actually a rite of passage for programmers. And it is very simple. It's just printing out the words Hello World on the screen. And this is where we're going to hit some stumbling blocks if we're not fully configured. So what you should see before you is everything we've done so far. You should have your IDE, whatever you're using, even if it's just a simple text editor. And you should have a blank file called test.py. The name's not super important. And last but not least, you should see the Python interpreter. I have Python 3.6.9. You can actually switch to different ones if you wanted to. Just be aware that you can use different versions. I'm going to type the word print. And then we're going to give it some brackets. Anything in the brackets, it's going to try to print. Now with Python, you can use double quotes or single quotes. I have a habit of using double quotes, but it really doesn't matter which one you choose. And then type the words hello and world. Click save. Now you should have this little guy right here that says run Python file in a terminal. If not, you can go up here. You're going to have a few options. Start debugging and run without debugging. Immediately, if you're a newbie, you have no idea what this means. Debugging sounds really, really bad. So what does this really mean? Debugging is a special mode in programming where if you have bugs or errors in your code, it will walk you through them and help you fix them, or more to the point them out to you so that you can fix them. Often I'll run without debugging because it is a little bit faster. And you should see something like this on the screen. Hello world. All of this stuff looks really nasty, but really what's going on here is you have your installation path for Python 3, and then, you guessed it, everything that it's doing in the background. It's calling this launcher, and it's saying run this script. The end result is this. Now, because I'm not a huge fan of Hello World, because it's so overly simple, let's actually get rid of that. And we want to go back to what we did in the interactive shell, where we're going to say x equals 5 times 3. What we're doing is we're making a variable. And we're going to talk about variables in the next video, but what we want to do now is just simply print this out. Save this, and I'm going to go ahead and run. And you see, there's 15 right there. Welcome back. My name is Brian. We're going to continue our conversation about Python 3. Whatever IDE you're using, go ahead and make a new file and give it some type of name. I'm just going to name it Playground. Not really important what you name it. You just need some sort of file you can play around in. Remember, these videos assume you have no experience. So we're literally starting with a blank slate. The first thing you're going to learn is what is a variable. I'm going to write this out here. Well, a variable is simply something that will change. For example, if I declare a variable named x, I have to assign this some sort of value. Let's go ahead and try and print x out and see what happens here. Notice it's going to have some sort of error. It's going to say name error. Name x is not defined. What does that mean? Well, clearly we defined it. It's right here. Really what Python's trying to tell you is that it doesn't really have any sort of value. So I'm going to say 42. Now let's go ahead and rerun this. Notice how suddenly it says 42. So if you get a is not defined, really what you're saying is you have not set that value. You notice how this is a number, and this is what I mean by a variable is something that will change. I could have very easily said cats. Notice how cats is a string. A string is just a series of characters, but it's not a number is the point I'm driving home here. And if we run this, it works just fine. So under the hood, what you have going on here is Python knows, it's smart enough to know what type of information we're storing in this variable, and we can change it at a moment's notice. So, for example, we have x equals cats, and let's just grab this, good old copy and paste action, and we'll say x equals, I need some sort of number, why not? And the IDE is not happy with me. It's saying invalid token. I'm just going to get rid of that 0. Maybe that'll clear it out. Nope, will not. Let's go ahead. Oh, there it goes. Let's run this. You notice how it says cats, and then it's got a number. So we can take this same variable and change it. And Python is smart enough under the hood to know that x is a string and x is an integer. So what we're really diving into, and we're going to spend a lot of time talking about this, is data types. And when I say a lot of time, I'm going to have to break this into multiple videos because each data type, whether it's a string or a number, like an integer here, has different properties that you can access. So the short answer to what is a variable is just simply that it's something that will change. That's it. It's that simple. A lot of instructors are going to take like months and months and months to explain what a variable is and how it lives in memory and blah, blah, blah. But as a programmer, we don't care about any of that. We just want it to work. And this is computer programming 101. You declare some type of variable, you set the value, and that value has some sort of type. And with that type, you can now work with it. Interesting note here, if you're coming from another language or if you know a little bit about programming, Python, you do not have to declare the data type. For example, in other languages, you may have to say something like int x equals 3. So what we're really doing here is we're stating or telling the interpreter, this is the data type we're going to work with. We don't have to do that in Python. It's smart enough to figure it out on its own. Okay, let's take a little detour down to theory land. Now, what we're going to talk about is dynamic and strong typed. Python is both, and this is often confusing for people, especially coming from other languages. As you saw, we don't have to declare the data type. Python's smart enough to know. In other languages, you do have to declare, and that gets super confusing to people. So we're often asked this question: why is Python a dynamic language and also a strongly typed language? And what do those two things really, really mean? Dynamic means just that, it's dynamic. You don't have to declare a variable type, and you can change that at a moment's notice, as you saw right here. We went from a string to a variable, and it's smart enough to keep track of everything for us and no errors were thrown. Other languages, you're going to get a huge error because we're saying once you declare this as a data type, it can never be anything different. That gets kind of convoluted. Best answer here is Python is a strongly typed language as the interpreter keeps track of all variable types, meaning the interpreter, Python itself, is smart enough to know what you want it to do, but it is also guaranteeing under the hood that once you assign it, it's going to stay that variable type until you overwrite it or change it. Remember, a variable is something that will change. And with Python, that's very, very true because you can change it to a completely different data type. A lot of other languages, you simply can't do that. Welcome back, everybody. This is Brian. We're going to continue our journey with Python 3. Whatever IDE you're using, create a blank file. I've got mine named Python 3-3. At this point, the name's not important. Just have a blank file ready to go. We're going to cover 3 key things: comments, booleans, and comparisons. Let's dive right in. Okay, comments. You've actually seen them, but we haven't really talked about them. What is a comment? Without writing any code, go ahead and run your script. You see, it does absolutely nothing. We're going to hit the pound sign and just type something. This is a comment. So really, what does this do? Well, if we run our program, you'll see nothing's changed. It does absolutely nothing. A comment is just that. It's a comment on the code. It exists solely for you, the programmer, so you can keep some sort of notes. So for example, you can say, this is our 3rd video. And you notice how you can add in letters, numbers, whatever you want, and it's not going to throw any sort of error message when we run it. This is strictly for you. This is your note. Now, if you're coming from another programming language, you're probably hoping there's a multi-line comment, meaning if you have a few lines, like, hello world, I like cats. You notice how as I was typing, it tried to help me out, and it put what we call IntelliSense in there, which is code that's already pre-written for us. Well, we really didn't want that, so it just caused all sorts of errors. Now, if I were typing in a comment, I'd say, hello world, I like, and you notice how IntelliSense suddenly is not really popping up. I can force it pop up by hitting Control and space, but it doesn't really know what we're doing because we're in a comment. Multi-line comment would be like if you had, and I'm just going to grab some text here. This is not a comment, even though it says it is a comment, it's really not. If we try to run it, you see invalid syntax because it's trying to interpret this as code. Now we can put a pound sign in front of each one of these. For example, let's just go this one and this one, and this one, and it's going to get really dull if you got like 100 lines you need to do. So what a lot of Python developers will do is this. They'll just have triple quotes, and anything inside the triple quotes becomes a string. String's something we're going to really talk about in depth in another video. Just know that this is a data type. So we're not truly making a comment. We're making a string, but the string does absolutely nothing. So if we run that again, there's no error message. And let's clear that nasty error out just so you can see. You can run this all day long and there's no error message. But we have created a variable, believe it or not. So I do not favor this, and be a little careful. This might cause issues later, especially if you get into like doc strings and things like that, which we're going to cover later on in this series. So you may be asking, what is the functional purpose of a comment? Well, it exists solely for you, the developer, as a note. You can also enable and disable code using a comment. So for example, let's just say x equals 1. Print x. You can see it is now printing 1. We could change this to hello world, which we did in the previous video, and there's hello world. Now if we comment this out, this x technically no longer exists. And you see it's giving us a little red squiggly line. It's saying undefined variable. And if we try to run this, you guessed it, boom, name x undefined. So we can disable this code by commenting it out. We can re-enable it by simply deleting that pound sign. So let's cover our first real data type here. And this is very fundamental. It's called a Boolean. Some people just call it a bool for short. And it is a true or a false. Think of it like a light switch. Like physically look at the light switch in your room. It's either on or off, and that's really what this data type signifies. So let's make a few. I'm going to actually comment out this code. And let's make some. I'm going to say x equals true. Notice how it has a capital T, and IntelliSense is trying to help us out by saying, hey, it must be capital. And y equals false. Again, capital F. You may be tempted, if you're especially coming from another language, to give it a data type like this. If you do that, bad things are going to happen. It's not going to know what you're trying to do. We can actually try to run this, and you'll see what I mean. Boop. Invalid syntax. So it's not understanding what's going on. When we get rid of that, suddenly, magically, it works. Clear that error out so it doesn't confuse anybody. Ta-da! Again, these are case sensitive, so if I change that to a lowercase, you see how IntelliSense no longer has that as blue, and we're going to get a nasty little issue if we try to run this. Name true is not defined. Remember, when you see is not defined, that's the interpreter's way of saying, hey, I have no idea what you're trying to do here. Simply because it does not exist. So let's switch this back to a capital T, and life is good. So I'm going to just copy and paste some notes in here. Notice how you can put a comment on its own line or after. If you put it before, for example, if I move this right here, it turns everything after it on that line into a comment. So be very careful doing that. And these comments have absolutely zero impact on our code. For example, we can run this all day. There are no error messages. Go ahead and clear this out. Now that we have that, understand that we want to do some fundamental comparisons, which is what we're going to talk about next. Okay, let's talk about comparisons. First off, what is a comparison? Well, it's the building block towards programming logic. So comparison is the building block of logic, meaning we want some value, take that value and compare it to another value to see what we need to do with the programming logic here. For example, I'm just going to print out x and y. I'm going to do this a little bit differently. I'm going to put the letter F, which stands for formatting, and I'm going to say x equals brackets and then x. Looks a little confusing, but really all we're doing is saying print out x, but do it in a fancy manner. See? XX. Now I can change this to y, and it becomes very simple to understand what's going on. X is true, y is false. We're going to compare these two now. So the very first comparison we're going to do is equal. And it's actually pretty straightforward. So I'm just going to grab this. And let's say, equal. We're going to do our logic here. And we're going to say, you have to be a little careful when you're doing equals, because if you just do this, you're actually assigning. These are called operators. This is the assignment operator. We're now saying x equals y. We don't want to do that. We want to compare it. So we're going to say x is equal to y. We're simply comparing. Then let's say the opposite of that. I want the not equal. Notice it's an exclamation. Whenever you see the exclamation, think exact opposite of what you want. So we want, is this the opposite of equal or not equal? Let's go ahead and run this, see what happens here. You can see x is true, y is false. They are not equal to each other. And it is giving us a true when we test for inequality. It's actually pretty cool that we can do that. We know virtually nothing about programming at this point in this series, but we already have the foundations of computer logic, true and false, and we can test for those conditions. Let's take this a step further here. And what we're going to do is greater than and greater than or equal to. So I'm going to just grab one of these. And I'm going to say greater than. Very, very simple. We're going to say print out is x greater than y. Now I want to say greater than or equal to. Very similar syntax to the not equals to. We're saying greater than equal to. And let's do the exact opposite. Let's say less than. And let's flip these around. Let's go ahead and run this. And you can see, there we go. Greater than, true. Greater than or equal, true. Less than, false. Less than or equal, false. These admittedly won't make a lot of sense to you right now until we start talking about the numbers, which we're going to talk about in the next video. But for bools, know that equal and not equal are great, and these are the building blocks of logic. We can start doing flow control now, which would be things like if-then. For example, if you're hungry, go eat. Otherwise, go do something else. We're going to talk about all this in future videos, but really nail down the fundamentals here. What we're really talked about is comments. They are your buddies, they're your friends. Be kind of careful how you do those comments. And booleans. These are simply on or off, true or false. Remember, these have to be case sensitive. And we've covered some foundational comparisons. For example, we're saying equality, inequality, greater than or equal to, less than, and less than or equal to. Hello again, everyone. This is Brian. We're going to continue our journey into Python 3. This video, we're going to cover numbers, the number data type, specifically the int, the float, and the complex data types. And we're going to cover some basic numerical operations, for example, addition, subtraction, things like that. Whatever IDE you're using, go ahead and make a blank file. I've got mine titled python3-4.py. The name's not important at this point. You just need a blank file to start with. Last video, we talked about the bool. This video, we're going to talk about numbers. I know everybody loves numbers. So let's go ahead and start off with the integer type. And we're going to make a simple variable here. And I'm going to call this ival. And let's give it a value of 34. It really doesn't matter what value we give it, though. Say print. And we're just going to print something out here. So there we go. And let's call this ival equals. And we just want to print that value out just to see what this looks like. Save run. This is pretty basic. You pretty much guess what it's going to do. It's going to say the ival equals 34. Very, very simple. Not super hard to wrap your head around. Now we're going to take this, do the magic of copy and paste here, and we're going to make a float. Float sounds really good right about now, like a root beer float or something like that. But we're talking about numbers, not root beer floats, unfortunately. So we're going to make a floating point value, and it's going to be 3.14. Save run. On the surface, what we're doing looks very rudimentary, but under the hood, Python's doing all of this work for us. We don't have to worry about what's actually going on. So, for example, there's a fundamental difference between an integer and a floating point number. There's a lot of precision that happens in the background, and we don't have to even think about that. Python takes care of it for us. I'm going to import the sys module. And what this is going to do is allow us to work with other people's code. And we're going to talk about that in depth in another video, but just right now, take a huge leap of faith that we're using someone else's code. This is actually part of Python, but we have to import it. It's a little confusing. Again, we'll talk about it in depth in another video. Usually it's at the top of the file. We're just going to put it right here. But we want to be able to get some extra information. So I'm going to say sys.get float info. And let's go ahead and copy and paste some notes in here just so we can see what's going on. I'm gonna grab this and voila, put that right there. That is the official Python documents. If you want to go out and look at it and see exactly what's going on, we can run it and see under the hood. This is what Python's really keeping track of when it talks about floats. So we have the system float info. You have a max, which is a really, really, really large number. And you can also have a max EXP, and you can dive into all this stuff. Now, if you're into numbers and math, you probably know what all this is, but us mere mortals usually don't care. Basically, if you have a number that has a decimal point, you're going to use a float. Otherwise, you'll use an int. Now, we're going to talk about another one, and it's called complex, and it is, well, complex. Now, when I say complex, actually, Python makes it super simple to work with, but the data type itself under the hood, you guessed it, is not super simple. It is complex, and it looks something like this. A complex number is made up of two numbers, a real number and an imaginary number. Kind of sounds a little messed up, but let's take a look. So we're going to say cval equals, and let's say 3 plus 6j, giant leap of faith that I know what I'm doing there. What is that really going to do? Well, it's going to make that complex number. And let's grab the name here, cval, and let's print it out. Doesn't really look like we did a whole lot. It's just saying cval equals 3 plus 6j, exactly what I typed. Let's split this apart here. What we're going to do is show an alternate way of creating a complex value. And you can do this with float and int, but it really drives the point home with complex. So I'm going to say complex. And notice how it wants the float and the image. Let's go ahead and give them both. So I'm going to say 5, 3. And let's go ahead and I'm going to just, through the magic copy and paste here, grab this. Let's say cval is that. Now I want to print out the real. And we want to go ahead and grab this, copy, paste, and we want the second part of that number just so we can see what it is. Go ahead and save and run. So now you can see the complex number is made up of two parts, and that actually would probably be better if I made it the way it was supposed to be. There we go. Real and imaginary. Two different parts. That's what makes that a complex number. So the fundamental point we're driving home here is that numbers are very fundamental and simple data types, but they can get very complex very quickly. Python strips a lot of that complexity out. If you're coming from Python 2 or another language, you're going to note this seems overly simplistic, and it is by design. Python 3 pretty much revamped the number system and did away with a lot of the old headaches, so it's super simple. General rule of thumb, no decimal point, use an int. Decimal point, use a float. If you need something else, use complex. And there are others that we will cover in future videos, but this should get us going for now. Okay, let's talk about basic numerical operations. Now, don't worry, we're not going to get super complex. We're talking basics. Python can do some really complex stuff. For example, you can do calc, trig, advanced algebra, pretty much any type of math you can imagine. Python's actually used in scientific computations, and it can do things like artificial intelligence. We are starting at the basics, so we need to talk about the basics. I'm going to say x equals 3, which is an integer. Now, I'm going to print this out, and I'm going to just grab the old print function here, save us just a smidge of time. Nothing super fancy about that, but what we're going to do now is we're going to make another variable. Let's call it y, and we're going to say y is equal to x plus 3. So what have we really done here? We've done basic addition. Let's go ahead and grab this. And let's call this add, and this is going to be y. And that's going to be our fundamental pattern here, where we're going to do something, and then we're going to just display the results. And I'm going to say add. That way we know what we're doing. Save and run, and sure enough, add is equal to 6, because x is 3, and we're adding 3. 3 plus 3 is 6. Again, fundamentals. Now, we're going to start speeding this up, because I think you're probably smart enough to understand basic math, and we're just going to grab this and, you guessed it, start plowing through this. So if we can add, we can also subtract. Let's go ahead and say we want to minus 1. Run, and you can see 3 minus 1 is actually 2, so that works exactly the way you would expect it to. Let's go ahead and multiply. And we're going to say, this is something you really can't do very easily in other languages. Python makes it just beautifully simple. So we're going to say 6.846. Doesn't really matter what number we do, just as long as we have that. Now, if you look, x is an int. But what are we doing? We're multiplying it by a float. So what's going to happen under the hood here is Python's going to determine what the end value type actually is. Is it going to become an integer, or is it going to be a float? You notice how it's not really telling us when we hover over IntelliSense. And that's because the interpreter hasn't done the work yet, so it simply doesn't know. So let's call this multiply, and ta-da, the end result is 20.538. So that is a floating point number. Now we're going to do some division. Let's grab this. And we want to say x is going to be divided by 0.5. Again, it's doing all of that hard number crunching in the background. What it's actually doing is called casting. And when you think of casting, think of like a wizard waving a magic wand, converting something from one data type to another. That is happening automatically for us. We don't have to think about it. Now, it's not always going to happen automatically for us, but in this specific case it is, and it's super, super convenient. Don't worry, we're going to talk about casting in depth in another video. Right now, we're still at the fundamentals. And let's play around a little bit. We're going to make a power of, so we're going to say that is the power. So 3 to the power of 2 is 9, and one more just to play around here. Let's do the remainder. I think this is called the modulus operator. And we're going to get this. If you don't know what this is kind of like the opposite. I shouldn't say the opposite. It's kind of like taking division and getting the remainder of what's out of that value. It's kind of weird. So let's take a look here. So 0.5. So what we're doing here is we're starting with x is 3, and we're getting the remainder of 2.5, which is actually 0.5. Very simple, very easy to use. So the fundamental concept we're trying to drive home here is there are some number data types, int, float, and complex, and you can do some basic numerical operations. Python makes those numerical operations very simple because it handles all the complexity under the hood for us, and we don't even have to think about it. Welcome back, everyone. My name is Brian, and we're going to talk about strings. So what is a string? That's a very good question. We have before you a simple diagram. The word hello, H-E-L-L-O, and there's some numbers here and some numbers here. And we're going to explain all this. So really, a string is a list of, you guessed it, characters, and each character translates to a numerical value. So if you look down at your keyboard and look at like the letter H, that letter, depending on whether the shift key is pressed, will be 104. Now when I say depending, because there's a numerical difference between lowercase and uppercase, we're talking about lowercase here. Some people will say, oh, that's ASCII. I've heard about this before. This is actually not ASCII, it's Unicode. Specifically UTF-8, I think is Universal Text Format, 8-bit or version 8, I forget. But basically, Python under the hood sees this as UTF-8. So it doesn't matter if you're typing in English or Korean or Spanish or ancient Greek or some mathematical algorithm, there is a number assigned to each letter. The computer knows what that is and takes care of all of this for you, so you don't have to worry about it. The two major things you should focus on is, well, the letters themselves that form the string, and this down here, which is the position. Everything is in a list, so when you look at it, HELLO, there are 5 letters there, and there are 5 numbers, starting with 0. This is a 0-based index, 0, 1, 2, 3, 4. So if I say, give me the letter at the 3rd position, HEL, this guy, that is actually number 2 because it's 0-based. Gets a little confusing if you're new, but you're going to go, no, wait a minute, that's actually number 3. Remember, it starts with 0, so the first one's always 0. We're thinking in terms of computers. 0, 1, 2 is this guy right here. Once you wrap your head around that, you know more than most people walking around, and honestly, it's not super hard. You just have to understand that everything you see on the screen has some sort of number attached to it, and the computer handles that number. You just need to worry about what letter and what position, and we're going to go into that. Okay, let's flip over into Visual Studio Code here, and we're just going to copy and paste some code here, and this is going to look like absolutely nothing you've seen before. Don't worry about it. Just taking a leap of faith. We're going to cover this in a future video, but really what we're doing is we're saying for X, each letter in the string hello, we're going to print out the letter and its numerical value. And you can see 104, 101, 108, 108, 111. Burn those into memory. 104, 101, 108, 108, 111. If we flip back, it's exactly what I told you it was going to be. So let's dive in here and figure out what's going on. Now, again, we are going to cover loops in a future video. That's not this video. We are hyper-focused on strings. So the first thing we need to do is baby steps. How to make a string. Very, very simple. Simply make a variable and assign it. And let's do that again. Notice how the first name, or the first variable, has double quotes, where the last name, or the second variable, has single quotes. In Python, you can do it either way. And they do this not so much to confuse you, but simply because there are a bunch of little gotchas that you're going to find later on in your life as a programmer. And this is super convenient that you can switch it around however you want. So the first thing you're going to want to try is just simply to, well, merge them into one larger string or print them out. So we're going to print, I'm going to say first plus and last. Now, what do you think is going to happen here? You notice how we're using the plus sign. If you're a math nerd, you're going to say, oh, this is going to kick out some weird number. Actually, no, it's going to say, you guessed it, it's going to, I think the term is called concatenate them. It's going to merge them together into one string in memory. So it's saying the first, Brian, with a space, and last, Karen's. Very, very simple. You can also do something called formatting, which we've done before, and it really does help you avoid errors in the long term. So you can say something like this, printf, and notice how I've got quotes. Doesn't matter if you're doing single or double. And I'm going to say, hello, my name is, and then, let's see here, there we go. I had to look at my keyboard to figure out where that was, and then we just type the variable name. First, and then last. Now, we tend to use formatting to avoid issues. You've seen me do it already, but you probably haven't really realized why, and we're going to cover that a little bit here. So, hello, my name is Brian Cairns. To kind of compound that in your mind, let's make a variable called hers, and we're going to say Heather's. Notice how I'm mixing and matching these. I'm using double quotes, so Python knows, hey, this is the string. But we could also use single quotes, so that gets super confusing. what it's going to do is take the first one it sees and says, oh, you're using double quotes to make the string. So if I were to change this to a single quote, notice how this letter suddenly turned white. Even if I end it in a single quote, it's going to get really, really annoyed with me. See? Boop. Syntax error, invalid syntax. If you ever see a syntax error, really what Python's telling you is you screwed something up, and it'll tell you exactly where. In this file on line 11, and hers, and then there's a little arrow right here under S. It doesn't know what to do with this because it is not in the string. Change that. You put the double quote there, and it magically fixes it. See? Doesn't make a whole lot of sense, so let's change that back. But this is why you can mix and match these. It makes it super, super simple. And we can just print that out, and it works as expected. There's our little single quote right there, and we don't have to worry about any special encoding or formatting or anything like that. Okay, so to solidify this, under the hood, a string is a Unicode series of characters, specifically formatted in UTF-8. If you want something other than UTF-8, you're going to have to go out and Google how to do that. I'm just saying we haven't covered it yet. We may cover it in the future, but if you need something immediately, definitely go out to Google. A string is a sequence of one or more characters, and those characters are numerical values, and that's what we're really going to drive home right now. So let's make a variable. Let's call this S1. And we want this to be a character. Notice how it's looking for an integer. Return a Unicode string of one character with ordinal, and then it gives you some examples there. And I'm going to say, because I have this baked into memory, 72. And then we're going to make another one. And this is character, and we're going to say 105. Now, you don't see it, but I'm sitting here cheating a little bit. I'm looking at the UTF specifications and the character tables, which you can see definitely by visiting these links and other links, and it will give you the numeric values. Now, this is if you wanted to do something like this. You really don't need to. I'm just demonstrating it can be done. So we're going to say S1 plus S2, and let's kick that out, and it spells the word hi. Notice it's a capital H, lowercase I, 72. Now, lowercase h is 104, uppercase H is 72. This is what I mean by there's a fundamental difference between upper and lower. Now, you may be inclined to say, now, what about bold and italic? No, that's actually not part of it. Those are not letters. Those are just simply styling and formatting of what you see on the screen. So really all we're talking about is upper and lower case. It actually goes way, way beyond that. You can do something like this. I say print, and I'm going to say character, and I really have to cheat and look at my notes for this one. 8710, and this goes way beyond ASCII. Let's go ahead and save and run and see what this looks like. Boom, it's this little mathematical symbol right there. That's right, it's got math symbols baked right into it. You can do some really cool things with just simple characters. You may have heard the term escape characters. Now, what is an escape character? It's not something out of a novel, although it could be. But basically, instead of memorizing all these weird numbers, they have it built right into the language, and actually most languages, and even operating systems, and they're called escape characters. What it means is you can escape a string and print a special character. And let's take a look at how this works here. So I'm going to say print, and we're going to even format this just to show you how this works. I'm going to say hello, and then world. And notice I've got that kind of jumbled together. Now, you can do something like this. You can say, okay, I looked it up, and it's, character 13 for a hard return, plus I want to do like a character 10 for a line feed, and that will put this on 2 different lines. And I had to go out and look up these numbers because I didn't memorize them, but it does work. Hello world. Or you can just simply do something like this. And we're going to grab it, get rid of all that nonsense, /R for return, /N for line feed, save, run. and it does the exact same thing. So under the hood, this little guy here, /r, notice an escape character starts with a backslash here. We're saying /r for return or n for new line. Does the exact same thing. You'll see that out in the real world both ways, where some programmers will demand you use the character and some programmers will demand you use the escape character. It gets a little confusing until you get used to it, but it's super simple, and you can do things like this. And really all we're going to do is we're going to print out hello world with a tab between them, /t for tab. When in doubt, you can go up to Google and you can type out what is an escape character, and it will give you a complete list of them. There's tons and tons of them, but they're very simple and easy to work with. Here's hello world with a tab in between. You may be wondering, why even use escape characters? I mean, it seems a little rudimentary. Now, let's go back, way back, to this problem. We want to put that in there, and it works fine if we do it in double quotes, but the minute we change it to single quotes, remember, we're going to have some sort of issue. It's not going to know to do with X, and it's going to say, you guessed it, invalid syntax. Well, instead of going through and rechanging all our strings, we can just simply put / in front of it, and most of the time that will work. It'll escape it right out. Go ahead and save to clear that error out. Let's actually clear this out just to show you it will work. No more syntax error, and we can print this bad boy out. So escaping actually becomes a very convenient way of, well, breaking out of the constraint of which quote you should use. I know I'm going to get that question constantly of, should I use single or double? And really, it does not matter. Just pick one and roll with it. And if you need to switch them around, you can always escape out of them. It's not super hard. You can also do things like this. And this is something I get a lot of questions about, not just with Python, but pretty much every language. So I'm going to say quote equal. You see what we're doing here? You can have multiple escapes. It doesn't really matter. Basically, what we're saying here is once you do this /, the computer will try to figure out what you're doing and it will roll with it. If it can't figure it out, it will give you an error message, at which point you're going to have to probably do something like this. Or you're simply using the wrong escape character. And when in doubt, go Google it. It's usually pretty easy to work with here. So we're going to go print. Then he said, quote unquote, hello to me. Now you may be wondering, what's the deal with formatting? When you read books or watch videos on Python, they go really in depth into formatting and why it's important. Really, you format to avoid errors, especially with strings. And let me give you a very simple demonstration here. Say, name is Brian, age is 46, and boy, I feel 46 today. I was raking leaves all day yesterday, so wow, yeah, that sucks. All right, so we're going to print these out. I'm going to say name plus, and we want the age. Oh, this will work, and it'll work beautifully, right? Well, guess what? No, it does not. There's a reason for it. It's not very intelligent when you first look at it. So we're going to say line 36 in this module, print, and it doesn't put the little arrow, but it does tell us must be str, not int. So what it's really talking about is this thing. What you're trying to do is take all of this and treat it like a giant number and then add these together. We're trying to do basic numerical operations, which we already covered. And Python's not going to let us do that. So let's get that out. And let's just put a note here. And let's show the correct way of getting around this. Now, there's a few different ways. We can do the way we've been doing, which is we just put an F in front of the string, and then we're saying we're now formatting it. Not very hard, we've done this before, but if you want a little bit more control, there are other ways of doing it. We're not going to dive into every single possible way. I'm just showing you the two that I use the most, and this is the next one. We're just going to print, and I want to say let's do double quotes. Why not? My name is, and here, what we're going to do is we're going to say we want %s. And what we're doing here is we're making our own special custom string with formatting baked right in. I am, and then I want a %i for integer. From here, though, now we need to do a % and tell it, hey, we're going to feed you some values. Those values are going to be name and age. Now, I typically don't like doing this because you have to read this whole thing, skip over to this %, and then look at this little guy here and figure out what we're sending it. Okay, so name is the first string. Okay, and then age is the first integer. All right, so let's run that, see what that looks like. And it says, my name is Brian, I'm 46 years old. Let's play around with this. Let's put I and S just to see if we can easily break this. And sure enough, we've broken it with very minimal effort. Type error. So really, I tend to favor just this simple formatting because we don't have to mess around with any of this or worry about screwing this up. But if you need special formatting, it is super, super simple to put it right in there. When in doubt, Google is your friend, and there are honestly thousands and thousands of tutorials on how to really learn that in depth. We're not going to spend a lot of time on it, though. Welcome back, everyone. This is Brian. We're going to continue our journey on Python 3, and we're going to continue with basic string operations. Now, when I said strings are complex data types, I was not joking, and there's no way we can cover everything in these little 2 videos, especially because we haven't even covered the fundamental logic of programming, so we have to stick with the basics for now. Don't worry, later on in this series, we are going to revisit some of the more advanced things we can do, but right now, you have to learn to crawl before you can walk. So let's start crawling. I'm going to say variable str is going to be hello world, this is a string. Very, very simple, and we're going to start off with here. So what we're going to do in this video is we're going to do things like getting the length of the string, repeating the string, replacing characters and things of that nature, and even slicing them and getting the specific indexes or positions within the string. Let's dive into the basic operations. So first things first, let's say we want to get the length. I'm going to say print. We're going to call it the len function, which is not limited to just strings, but it is super, super handy for strings. And we are going to, you guessed it, just print out a comment here. Get the length. When we run this, we can see this is 30 characters long. Now, you might be inclined to say, no, wait a minute, it's a zero-based index, so it's actually 29. No, it actually gets the length, not the position. That's fundamentally different, as you're going to see later on. So now that we've got the length, we can do other things as well. Well, let's say we want to repeat a string, and this is going to hurt your brain just a little bit here. We've talked about how you cannot do mathematical operations with a string. Remember, we were trying to add an integer and a string together. Well, you can do what's called string math, and this is what I mean by it's going to hurt your brain. We're going to say str times 3. Now, I know what you're thinking. You're thinking you're going to get some sort of weird thing because you're trying to multiply, but actually what you're telling Python to do is take the string and, you guessed it, multiply it by 3 and return a giant string. Let's demonstrate. Hello world, hello world, hello world. So it did exactly what we thought it would do here. Yes, the first time I did that, I kind of sat back in my chair and went, wait, what? Is that right? But it is actually a thing with Python. If you're coming from another language, you're probably sitting there just staring at your screen going, what witchcraft is this? But it's actually super handy if you need to repeat a string. Now, let's go ahead and let's look at replacing. And if you're coming from another language, well, this is exactly what you think it is. It is just dead simple. So in Python, strings are a data type, but they're also a first-class object, meaning they have functions built right into them. We haven't really covered functions yet, but just know you can say your variable name dot and then call some code, and we're going to call the replace function. And what this is going to do, it's going to take the string and replace a section of it. So let's say I want to replace hello with hola. So if you're from Mexico or Spain or any Spanish-speaking country, that would be the correct way of saying hello is hola. I'm probably mispronouncing that, but you get the point. You can simply replace it. So, hola world, this is a string. Makes it super simple to do that. You don't have to figure out where things are. You can also do something like split a string. So if you're coming, again, from another language, you've done this before, and I'm going to say str, I want to split. And notice how it's looking for a separator here. So let's go ahead and split this on that comma. If you're not coming from another language, you're like, wait, slow down. What is splitting? So we're going to take this string and turn it into two strings. And we're looking for a separator value, in this case, this comma right here. So it's going to say hello world, and then this is a string. And it's going to give us two strings back. Here we go. Hello world, and this is a string. Now you may be going, now wait a minute, this comma's here. Look at these little brackets. You got this end bracket, this beginning bracket. What it's done is it's created a data type we haven't talked about yet, but we will in the next few videos. And it's put two strings into that data type and then handed it to us. Very convenient way of saying, hey, split those up. As you go on programming, you're going to actually use that quite a bit. Now, let's say we want to know if this starts with something. So I'm going to say str, and I want to say starts with. Does it start with the letter H? I'm almost embarrassed to type that comment starts with because it's pretty self-explanatory what it's doing, but just in case, it's going to return a bool and it's going to tell us, hey, yes, it does. If we switch this to like J, does it start with a J? False. Very simple, handy way of determining what's going on. We can, through the magic copy and paste, switch this to ends with. And let's say we want to make sure this ends with an exclamation. True, true. There we go. And let's go ahead and look at uppercase, lowercase, and capitalization. We're just going to say print. And we want upper. And it's going to give us hello world. This is a string all in uppercase. You notice how it's got these brackets here, and that's because it is a function. If we omit those, we're going to get a built-in upper of string object and then this number. You ever see something like this? Basically, what you're trying to do is call a function without these brackets, and you need those. If you're wondering what this number is, that's a location in memory. So an object is simply something that exists in memory, and that's its location. So admittedly, this message is not super helpful for beginners, but I just wanted to explain what that was. I'm gonna round this out. Let's say lower, and I want to capitalize. So now we have all uppercase, all lowercase, and capitalized the way it should be. Let's take a look at slicing. And when I first heard this term, I actually had like this vision of whipping out a lightsaber and slicing something in half. And it's actually not far off from what we're talking about. We're talking about getting a substring. Now, when I say a substring, remember, this string is just a series of characters, and each one is at a position. So the 0 would be here, and then 1, and so on, and so on, and so on, and so on. So what we want to do is get a substring, or a slice. Think of it like you have a pie in front of you, and you're going to get a slice of pie. You're not taking the whole thing, just a part. So for example, I could say I want the word world, or I want just th out of the word this, or this specific space. Or I wanted to get everything in the end up to that point. You can do things like that very, very rapidly in Python. And this, if you're coming from another language, I'm going to tell you, is extremely cool once you wrap your head around it. So we're going to say print. And we're going to take our variable. Now we're going to put those brackets there. That indicates we're getting a slice. The format here is very simple. We want the start, a colon, and an end position. So the start position in this case, we're going to say the 0, or the starting position, and we're going to end in 5. And what this is going to do is it's going to get the first 5. This is a 0-based index. Let's print this out and see what happens here. 1, 2, 3, 4, 5. Hello is 5 letters. There we go. So it did exactly what we're trying to do here. Like I said, it looks a little confusing at first, but once you start wrapping your head around it, it's not super hard. Now I want to start at the 6th position, and I'm going to omit the ending. And what we're doing here is we're saying we want to get from the 6th position all the way to the end. So when you omit something, it automatically defaults to the beginning or the end, depending on which one you omit. So the 6th position would be, you guessed it, world all the way over here. Ta-da, works as expected. Let's go ahead and grab this and let's try something a little bit different. We're going to start at -7. Now you may be going, wait, what? Negative? How can we have a -7? Well, when you have a negative, you actually start from the end. So because we're starting with a negative, it's going to start back here and count backwards. Actually pretty cool how that works. So let's run this. And the last 7 is string exclamation. Pretty cool. Try doing that with some other languages, and some are going to be very cool. Some are just going to completely infuriate you depending on the language. And now let's get a substring. We're going to say from 6 to 11. And we want to get 6 to 11 just for our notes here. See what that looks like. And it is the word world. Very cool, very simple, very easy. Now, if you're coming from another language, you're probably still stuck on this right here. Don't worry, whenever you see that negative symbol, just think you're starting from the end and working backwards. Now, slicing is cool and all, but it's not super helpful unless you can actually automate the way of getting the number, because no one wants to sit here and count things, right? So let's look at how to get the index or the position of something. What I'm going to do is I'm going to say L equals, and we're going to look for the comma. Now, if we look at our original string, we've got this comma right here, but we don't know the position it's at. So I'm going to hide that off the screen, and we just want to know, hey, we want to look for this. We're going to do it 2 different ways. We're going to say C equals str find. This is what I love about Python. It's very, very intuitive. Find does exactly what you think it would. It finds something. It's going to tell us what we're looking for is the L. It's going to tell us where it's at. Or if it doesn't find it, I'm going to say -1 if not found. Let's go ahead and say print. And I want to say find return C. Let's run this, see what it does. So, whoops, actually misspelled find there. Easy fix. So find return C, so it is at the 11th position. We didn't have to sit here and go 1, 2, 3, 4, and we'd be here all day doing that. Instead, we want the computer to do the work for us. So we know this at the 11th position. Now, if we change this to just something, let's just do a single T. You see find return -1. So in this case, when you see -1, you can say it's just simply not there. It's not going to return a 0 because remember 0 is the starting position. So find is really, really cool, but if you're coming from another language, you're probably looking for index of, which is something totally different. So I'm going to say I equal str index. We're going to give it the same thing, the L. And now we want to this, and we're going to say find return I. And let's see what this does. Now remember, we have this T in here. Where is T in here? It's, well, right there, but it's a lowercase, not an uppercase. So it should return a -1, or will it? Actually, no, it does not. Instead, it gives you what's called a value error, substring not found. This is a convenient way of saying, hey, that must exist or throw an error, something we're going to cover in future videos. Just know that find will not return an error and index will return an error. So most of the time you're going to want find. But if you're coming from another language, you think you want index and you really want find. Oh, super confusing sometimes. Will throw an error. Just want to make sure we put that in there just in case. And let's switch this back. And you can see they both return 11 because we're looking for that comma. Remember, index will throw an error, find will just simply return a -1. Wrapping this up, let's go ahead and say we want to create a new string from the substring. How do we do that? So we want to say x equals str, and we're going to slice that string. We're going to omit the starting position because we want to go from the beginning, and we only want to go to the position of this comma. If that seems super confusing, let's slow way down. So we have a string, and it says, hello world, comma, this is a string, exclamation. So we're looking for this guy right here, which we found at the 11th position. And we're saying, okay, so from the very start, hello world, actually just going to copy this whole thing right down here. Copy this, put it right here as a comment. There we go. So we're going to say, so from the very beginning, right here, all the way up to the position we find, we want to create a string and call it x. Now we want to take that and just simply print it out. Hello world. Super, super simple. So quick recap. Strings are first-class objects in Python. They are Unicode by default. They are UTF-8, although you can specify some other way of doing it. Google's your friend if you need to do that immediately. And you can do some really cool things like get the length, repeat it, replace it, split it, make sure it starts with, ends with, upper, lower, capitalization. You can slice it, dice it, do whatever you want to do, and you can search for or find things within the string. And if you need to throw an error if it doesn't exist, you can use index, which I do not recommend because it's not really a good idea to throw an error in your code most of the time, and you can create your own strings from substrings very simply, very easily. Welcome back, everyone. My name is Brian, and in this video, we're going to cover lists. A list is a complex data type. Compared to what we've been talking about, it's very complex. So far, we've covered bools, numbers, and strings, but the list is, well, vastly more complex, as we're about to see. So first off, what is a list? Well, it's an ordered list or collection of data. And what do I mean by that? Imagine we add an item. That item is going to be at position 0, meaning the first item you add is always 0. And as we add items, you guessed it, that index will increment. Let's go ahead and add an item here. So 0, 1, 2, and these items, they can be the same, they can be different, they can be something totally crazy, whatever we want to do. This is the beauty of Python. So the list doesn't have to be what's called typed, meaning you don't have to have the same data type. That's how a lot of lists work in a lot of different programming languages. You can intermix strings with numbers and custom data types. The main takeaway before we dive in here is that this is an ordered, zero-based index, meaning it will be added in the order you add them, and the first item is always 0. From 0, it goes to 1 and 2, and so on and so on. Okay, let's go ahead and create a list. First thing you'll notice in our notes here is I have these square brackets right here. What that denotes is that it is a list. It's important that you remember that because we're going to talk about other data types that are very similar to a list, but they are different and they use a different style. So first things first, let's create our list. Remember the square brackets. I'm going to say x equals square brackets. And anything we put inside these square brackets becomes part of the list. For example, I'm going to say Brian, and we're going to add another item by pressing comma and then whatever we want to put in here. So we have two strings in there. Now, really hurt your brain if you're coming from another language, I'm going to add a number. That's right. This is not a typed list. You might be used to something like C++ where, well, you have to have a specific type. It can only have strings or only have numbers. Python is not like that at all. It makes it very flexible, very easy. So let's go ahead and put a note in here. We can mix data types. And let's go ahead and print this out. And I want to say list. Going to print our list out. Good old copy and paste. Let's put this down here. And let's get the length. So you can see right off the bat, our list is this right here, and it's inside those square brackets. Always remember, square brackets are lists, and we can have two strings and a number. We can add whatever we want, and there are 3 items in there. If you're coming from another language, this may actually hurt your brain because you're going to go, wait a minute, you can't have multiple types, but with Python you can. It makes it super convenient, super easy to create your own data structures on the fly. Let's make a special note here about indexing and positioning. So this really confuses a lot of people. We think like, well, humans, the first item is always 1. Well, computers don't think that way. The first item is always 0 because you're starting with nothing. So when we talk about lists, this is 0 based. Let's go ahead and let's grab our friend print here. And let's say we want 0. So to grab the first item in that list, simply say square brackets and the index. Now note, we are not creating a list. We're saying inside of that list, get that index. In this case, it's the 0 or the first item. I'm going to put that in all caps for you newbies out there. The first item is 0. Remember, humans think the first item is 1. Computers think the first item is 0 because you're starting with nothing. Now, if you watched the previous video on strings, and I hope you did, you understand what slicing is. But just in case you skipped it, a slice is a lot like making a slice of bread. You have a nice big loaf of bread in front of you, and you don't want the whole loaf. You just want a slice of it, or a slice of pie is probably a better example. So we're going to print this out, and we're going to slice this. So I'm going to say I want X, and then we're going to, you guessed it. Now notice those are square brackets as well. We didn't cover this in the last video, but yes, when you see that square bracket, that means we want a piece of this list, or in this case, a slice of it. I'm just going to put some quotes here, or some quotes, some comments. Slice the list. So what this is going to do is it's going to say X, and we have a starting position and an ending position. We're going to go from the first to the second. Now remember, the first is not the first item, it's position 1. Remember, that gets super confusing as far as 0-based indexes. To illustrate that, 1 to 2 position is actually Karen's. So what we're doing is we're taking this list here, ta-da, and we're saying 0, 1 to 2, so it's going to stop. If we omit this second position, we're going to get the remainder of this. We're going to say we want that whole slice right there. So let's demonstrate that. Ta-da! Works as expected. Slicing is a very convenient way of getting a sub-item. You may be thinking, lists are great, but now that I've created the list, how do I add items to it? That's a common question. So that's what we're going to cover in this little section here, is how to add the items. You can either append or insert. And both of them do, well, exactly what they sound like they do. For example, X append, we are going to say append pizza. And let's go ahead and X dot append I'm doing this twice for a reason, and you'll see why here in just a second. We're going to add beer, because everybody likes pizza and beer, right? Now we want to insert. So append will put things at the end in the order you put them. Notice we did two appends, pizza and beer. So it's going to add pizza, then it's going to add beer, and it's going to do both of those at the end. Now insert allows you to say, I want to put this at a specific position. So because we're talking about a specific, I need to give it a number. And in this case, 1. You notice it wants an index, an integer of where you're going to put this in the list. So I'm simply going to say 1, and let's add cats. So following along, what we're doing here is we're adding pizza to the end of this list. Then we're adding beer. Then we're going to go to the 1 position, not the beginning. The beginning would be 0, remember. We're going to go to the 1 position and add cats. Let's go ahead and add a few notes here. That way anybody who downloads this code off GitHub will just have the notes and be able to easily follow along. Now let's go ahead and do a print. And I want to see this list in its entirety. And let's see what this looks like. Okay, down here you can see we have our list and we have Brian, and then cats got inserted in the first position. And then my name Karen's 46, and then it did pizza and beer. Very important you understand that append will do it in the order you append it. So it put pizza at the end of the list, then it put beer at the end of the list. Very simple once you wrap your head around that. It just trips up a lot of newbies. Just bear that in mind when you're adding things. If you want a specific index, you need to do insert. If you want to slap it at the end, you do append. Okay, now that we've added items, let's talk about how we get rid of items. We're talking about removing. Let's remove, pop, and delete. And these do things very differently, even though at first glance they may seem very, very similar. So I'm going to say x.remove. And I want to remove cats. I'm not a big fan of removing cats because I happen to love cats, but you know what I mean. Sometimes you just got to get the cats out. So what remove is going to do is go through and remove the first item here. Let's grab our print statement, slap that down here, and let's run this. All right, so you can see Brian, cats, Karen's. Now it's Brian, Karen's. We removed cats, so it just removed that first item there. Now let's talk about pop. Now, don't get excited. Pop is not like Coke or Pepsi or anything like that, but what we want to do is we want to remove an item, but at the same time return it, meaning we want to be able to work with it here. So I'm going to say I equals, and we're going to do x.index because we want to find something here. We want to find pizza. Now this will raise an error if it's not found in there. So if you just look for something crazy, it's not going to return -1. And there really isn't a find. Remember we talked about find in the last video where it returned a -1? This is just going to say, hey, there's an error, and it's going to crash your program. That sounds really bad until we get into more advanced discussions where we talk about how to get around that and why it even exists in the first place. So just big leap of faith at the moment. We know that pizza's in there because we appended it. We're going to get that index because nobody wants to sit here and count and figure out what position this is actually at. We're going to say food. And we're going to pop. Now, when you think pop, think of it like popping the top off of an ice cold soda or beer, whatever your favorite beverage is. You now have that cap in your hand after you've popped it off. That's at least how I learned pop. So when you pop off the cap, you still have that cap. In this case, it is the item at index of whatever pizza's at. Sounds super confusing. It really, really does. But it's really simple once you see it in action. So what we're going to do here is I'm going to clear this list just to avoid any confusion. And we're going to run this. Boom. So what's going on here? we have our list, and see, there's pizza in there. And we're going to pop, meaning we're going to pop the cap off that thing that's in our hand, and we now have that bottle cap. And that bottle cap is pizza. So we can now use that. But once we've popped it, it's no longer in the list. See how it removed it? Very convenient if you want to remove the item, but at the same time use the item. Seems a little confusing, but bear with me. That is actually used quite a bit when you get into a little bit more advanced programming. All right, next up, we're going to talk about deleting. So I want to say I equals, say X index, and let's get the index of beer. Because again, no one wants to sit here and go 0, 1, 2, 3. No one wants to do that. We just want the computer to figure out where it's actually at for us. So once we get that index, and I should put a special note here, this will raise an error if not found. But once we get that, we want to actually just delete it. So we're going to say del x, and then whatever that position was. Now this will delete the item without returning it. And I'm going to copy and paste some notes in here. So delete a specific item without returning it, where pop will remove and return the item. Fundamental difference there. Which one would you use and why? Well, pop is if you want to actually use it. Delete is if you want it gone. Now, when you delete this, it's gone. You cannot use it. It doesn't even exist in memory anymore. And that's why it's called delete, because you're literally deleting that out of memory. If you're coming from like C or C++ or any other language that does memory management, yes, you are actually deleting that out of memory. Now, under the hood, what's really happening is Python's flagging that for garbage collection and all this other fancy stuff that newbies don't really understand. But if you're more of an advanced person, that's what's going on, is Python saying, get rid of it out of the Python internal list. We're just going to let the garbage collection wipe it out later on. Save run. This is what's going on here. So we found the index of beer and we deleted it. Pretty cool, pretty easy to understand. So major takeaway from removing items. If remove will remove the first one. Pop will remove it, but let you play with it. You can do whatever you want. And delete will, well, actually delete it and get rid of it. Let's talk about extending or adding elements from another list. And this will be a little bit confusing, but bear with me here. So there's a reason why you would extend rather than just add a list. And it's because Python, you can actually add lists into lists, which we're going to cover at the very end of this video, but it gets super confusing. So let's look at this. So we're going to say, we're going to make another list. And let's call this cats, comma, dogs, comma, birds. And in case somebody out there is like, well, how would you actually add a comma? You wouldn't add a comma directly. You'd add it as a string like that. But we're just going to add in cats, dogs, and birds into our list called Y. Now, the list we've been working with is called X. So we want to take the contents of Y and put it inside of X. So we're going to say x.extend. Sometimes IntelliSense helps us out, sometimes it doesn't. And we're going to extend with the Y list. Let's go ahead and print this out. Notice we're printing X. What do you think, pop quiz, what do you think this is going to look like when we run this? Well, if you said it's going to have the contents of both lists, you're absolutely correct. Now notice how what it's done is it's taken our X and added the elements of Y to it. So these are now true items inside of X. Very cool how that works. So let's talk about sorting. And when I say sorting, we mean sorting and reverse sorting, meaning doing the exact opposite of like an alphabetical. So let's go ahead and say sort and reverse. Now think of this as like sort ascending, sort descending. Now our list is a mixture right now. And what do I mean by a mixture? So if we just take this, print this out, run it, you can see how we got string, string, int, string, string, string. we're going to have problems with this integer, and we're going to have to take that out. And I'll demonstrate this really, really quickly. So I'm going to say x.sort. And this is where a lot of newbies get tripped up. And it goes, not supported between instances of int and string. And it's exactly that. So it's saying it knows how to sort strings, and it knows how to sort numbers, but it doesn't know how to sort a string to a number. So think about that. Let's say you have a table in front of you, and I come in and I dump a bunch of potatoes and a bunch of apples, and I say, sort these. Well, how do you want them sorted? Do you want the potatoes and the apples sorted, or do you want them sorted by color, but they're all different colors? And this is what I mean. Python gets really confused, and it just says, you know what? I'm not even going to try and figure this out. I'm just going to drop an error and let you just figure it out on your own. The easiest way to get rid of this at this point is to simply remove it. So I'm going to say x.remove. We're going to just remove that int, and then we're going to sort. So now it's alphabetical because we've removed that. It knows exactly how to sort these strings. Birds, Brian, Karen's, cats, dogs. Very, very simple. The polar opposite, of course, is reverse. And we're just going to grab this for the sake of time. Pretty self-explanatory what's going on there. This would be like sort ascending, sort descending. I almost wish they didn't call it reverse, but called it like sort descend or something like that, or, you know, had a parameter inside of sort. We'll talk about parameters later on, but it can be a little bit confusing. But just think of sort as you're going to sort alphabetical, and reverse is the polar opposite of that. You notice how when we sorted, we had to remove that int, simply because sort will throw some sort of error if there's a mixed type. Now, what if you wanted to do that, but you didn't want to really modify the original list? Well, what we're going to do now is called a copy, and some people call this cloning. This is a very shallow clone, but basically we're just making a copy here. So we're going to say y equals x dot copy. Does exactly what you think it does. It actually makes a new list and copies the elements into it. So we're going to say copies the elements into a new list. Now we can simply say y.reverse. And we could add items, remove items, do whatever we wanted to do. So I could say y.append. Let's go ahead and append apples. We could do any other thing we really wanted to do here. So let's grab this print statement here. So x is the original. New is our y. Let's see what these look like here. So our original remains unchanged, where our new now has apples, and it's been reversed. Pretty cool the way that works. And then if you were done with y and you didn't want it anymore, you just simply delete it, which is what we're going to talk about next. Okay, so deleting. Delete the whole thing is really what I'm going to put here. Why would you want to delete something? Well, in the previous little segment here, we said we're going to make y, and y is a copy of x. Now that we're done with y, we don't need it anymore. We can do one of two things. We can either let Python garbage collect it, meaning it's going to figure out when it's not needed anymore, or we can specifically say delete the whole list. And yes, that deletes the whole thing. So if I try to say something like print y, it's going to have a bad time here, and it's going to say name y is not defined. And you remember from a previous video, whenever you see is not defined, it means it simply does not exist. Meaning we have now destroyed y, and everything in it has been destroyed as well. So all that memory, for you computer nerds out there, is now freed up and gone. We can use it for other things. This really becomes important when you start talking about embedded systems and things of that nature, where memory might be a little bit more constrained than, say, your desktop or your laptop. You got to understand that when you delete something, it is gone. And I mean gone, gone. Is not defined means you would have to rebuild this entire data structure from scratch. There's simply no way to recover it. Deleting can be a little bit drastic. As we saw, name y is not defined is, well, kind of a problem. I mean, what if you didn't want to delete the entire variable? You just want to delete part of it or clear the whole thing off. That's what we're going to talk about in this little segment here. So we're talking about clearing. Think of your list like a big table and you got plates and dishes and all sorts of stuff on there. You don't want to throw the whole table out. You just want to clear it off. And that's exactly what clear does. So it's going to clear all of those elements out of the list, but the list itself will still exist. It will just be blank. Go ahead and demonstrate that. So let's type cleared. So most of the time in programming land, you don't actually want to delete. You just want to clear it out. So our list exists, you can see by these brackets, there's just no elements in there. And we can actually test that. Let's go ahead and get the length of x. So it exists, but there's no items in there. Most of the time, if you're confused, just think of it this way. Delete is throwing the entire thing out. You're throwing the whole kitchen table out, where clear is you're just clearing the dishes off the table. Usually you want clear, not delete, but delete exists in case you need to free up that memory. You want to do something a little crazy. A list can contain other lists, and if you look at this, it looks kind of weird. But just think you have a start bracket and an end bracket, followed by start and end, start and end, and start and end. So that's right, a list can contain other lists. If you're coming from another language, think of this like an array of arrays. It's kind of advanced and it's not something a newbie really understands, but in case you're curious, this is how you would do it. So we're going to say x equals, and we're going to turn x into a blank list with nothing in it. Y equals, and we're going to create another list. And we're going to say 1, 2, 3. And let's go ahead and make another list called z. And in here, I'm going to say my name. You go ahead and put your name, or cats, dogs, birds, whatever you want to put in there. So now we have 3 different lists. What we want to do is we want to take the contents of z and y and put them in x. So I'm going to say x.append. Let's go ahead and append y. Now, what I've done is I've taken all of these numbers and put them inside of x. Let's go ahead and print this out. Now I'm saying merged, but that's not really what we're doing here. We're actually merging all these into one giant data structure. You notice how we've got these double brackets here? So what we're saying is this item, this individual element, is its own unique list. So I'm going to say lists in lists. All right, now what we want to do is we want to take the contents of z and put them in x, but we want to put them before all the other stuff that we put in there. Say x insert. And let's go ahead and put this at the 0 index, and we're going to put all of z in there. Let's go ahead and run this. And you see now our list actually is made up of 2 smaller lists. Newbies may look at this and go, well, there's 5 items in here. There's really not. Let's go ahead and test this out here. So we're going to say, grab this and let's call this our list. And let's go len. And we're going to get the number of items in here. There's only 2 items in there. Very simple, very easy to understand. Now, let's say we want to grab the first item. We want to say 0, and we want to go 0. And let's go ahead and grab that second item. So our first item is this list here, which is its own little list, and second item is this list here. And in case you're wondering, yes, you can get kind of nuts here. What we're doing now is we're diving into those lists. So in our first list, right here, we're going to grab the first item, which is Brian. In our second list, we're going to grab the second item. Notice that's at the 1 position, which is 2. Seems super confusing, but just think of it this way. Think of it like a stair step. Every time you see these brackets, you're going deeper down a step into the basement. So for example, we could switch this around here. And we can grab the very first item, which was 1. We could switch this around again and say we want the second item, which is 3. Seems super confusing if you're a newbie, but trust me, once you get into more advanced stuff, this is a huge, huge time saver, is just simply putting lists in lists. And when you start working with things like web services, you're going to find that quite a bit, where the data they're going to hand you is basically a list of lists, and you just simply have to navigate through it. Okay, a little bit of bonus material here. I know I'm going to get the question, so I thought I would just add it. How do you change an item? Remember, it's positional. So for example, let's say x equals, and let's just make some numbers here. 1, 2, 3, 4, 5. We want to actually change this. When I say change this, we don't want to change the whole list, just one specific item. So what I'm going to do is I'm going to say x, and then whatever the item number is. So let's say I want to change the item at position 2. And we want to change this to the word test. Remember, this is 0 based, and this trips up a lot of newbies. So we have 0, 1, 2. So this guy right here, we're going to change that. Let's go ahead and print this out. And let's see it in action. There we go. 0, 1, 2, our 2 position is now test, 4, 5. So that is very simple how you change something. A lot of people, especially me, take this for granted because it is so simple and easy to work with. And if you've worked with other languages, you may be looking for like a change element add or swap element or something like that. It's actually very simple. You take the list, you take the position, and then you assign it a value. Welcome back, everyone. My name is Brian, and in this video, we're going to talk about the set. Now, the set is a little bit different than the list. We spent 30 plus minutes in the last video deep diving into the list. If you haven't watched that video, I highly encourage you to go back and watch it because we really do dive into the list. Set, however, is slightly different. That difference, though, means it is profoundly different under the hood. Let's take a look at this. So a set contains unordered, unique, and immutable data types in a hash table. Let's break that down. What does that really mean? Unordered, meaning we cannot control the order. Like in a list, you could add or insert, meaning we could now control the order. Can't do that with a set. The set determines the order. Unique, meaning you cannot have multiples. So if you try to add 2 cats or 2 dogs, it's just not going to do it. And immutable data types. What does that mean? It means that once we add them, we cannot change them. We can only remove them or add them. We cannot change individual items. And it's in a hash table. Hash table, well, that gets a little bit complex in computer theory, but really, when you hear the term hash table, think blistering fast read access. The set determines the order so that it knows exactly where things are in memory, and it makes it very fast. So if you want very, very quick lookups, a set is what you need. Now that we understand what a set is, let's go ahead and let's create one. So first things first, we'll say s equals, and then we want these little curly brackets. Remember, if you do the square brackets, that's a list, completely different data type. You want the curly brackets. And in here, I'm going to just say 1, 1, comma 2, comma 2, comma 2, comma 3, 4, and 5. You may be going, now wait a minute, I thought it had to be unique. Well, this is one thing I absolutely love about Python. It automatically strips all that out for you, so you don't have to worry about it. See? 1, 2, 3, 4, 5. Even though we tried adding multiple 2s in here, it's smart enough to realize it already exists and says, nope, can't do it. And it doesn't raise an error or anything like that, so we don't have to worry about it exploding on us here. We can also, in case you're wondering, convert a list into a set. And let's show how to do that. I'm going to say, here's our list. And I'm just going to have my name and my age. And now we're going to say s equals, and we're going to use the set function. And what this does is take any sort of iterable data type like the list, which we've talked about, and convert that. Does it automatically. We don't even have to think about it. I'm going to grab this. Now, notice the order. I did Brian Cairns 46, and in a list, it's going to be exactly the way we put it. However, in the set, it's actually 46 Brian Cairns. So the set is now determining the position. That's one thing you need to really, really drive into your brain about a set, is the set is unordered, unique, and, as we're going to see later on, immutable data types. Okay, let's see how we would add items to a set. It's actually very, very simple. So I'm going to say s.add, and you can add pretty much any element type you want. I'm just going to add the word hello. There is another way, though, and it's called update. And it looks a little bit challenging when we look at this. It says *s:* iterable t none. What does all this mean? Well, when you see this term right here, basically we're talking about something like a list. I shouldn't say a list, but like a list. Something that you can go through or navigate through, like a list or a set or a tuple, which we haven't talked about yet. You just need some sort of data container that contains multiple items that you can iterate through. So in this case, we're going to say, we want to do this in a list. Say 1, 2, 3, and I'm going to go ahead and add in hello. Notice I've got hello twice, but we're working with a set, which is unique items. So what's going to happen under the hood? If you're going to guess that the set is going to automatically strip out the second hello, you'd be absolutely correct. Let's see it in action. See? 1, 2, 3, 46, Cairns hello Brian. Again, unordered and unique items only. Now that we've added items, let's look at how we would go ahead and remove items. And it's just as simple. Say s discard. And discard does, well, exactly what you think it would. It just takes it and throws it right in the trash. However, there's a subtle difference between discard and remove. Pop quiz, does anybody know what the difference really is here? Well, one will throw an error and one will not. So discard will not throw an error, where remove will throw an error. And what do we mean by that? If we run it in its current form, everything is, well, just going to work. Let's go ahead and modify this a little bit and demonstrate this error. So in our set, we have 1, 2, 3, Cairns 46, Brian, and hello. Let's go ahead and say some number that we know is not in there, 78. Run this, and uh-oh, we have a key error 78, which means it knows 78 is not in there. In future videos, we're going to talk about how to get around that. You're going to use the keyword in to determine whether or not it's actually in there. But just for our beginner's perspective, discard will not throw an error and remove will. Be very mindful of that as you're moving forward. Another thing we can really do here is we can pop. Now, pop for a set really isn't abundantly useful. I'm just going to say it. You may be inclined to say, hey, I want to get like the first item or the second item or the last. You can't do that. It's just going to return an arbitrary item. You don't control what item it gives you. It's just going to give you an item. That gets a little frustrating. But if you're just using the set as a container and you want to just get each item and remove it, pop is actually pretty useful. But this is going to be pretty random as far as you're concerned, and you're going to have zero control over it. Now that you've popped it, you could do whatever you wanted with V because it still exists in memory. However, it's no longer in our set. One question I'm often asked, especially by newbies, is, well, I have a set and I want to modify it. Well, unfortunately, you can't. Not only can you not modify it, you can't access items based on their index because the set has no concept of this. Let's go ahead and demonstrate. So I'm going to say S and 0, and we're going to change this to A. Go ahead and run this, see what happens. And object does not support item assignment. Oh, that is super frustrating. This is actually by design. Once you put it in the set, it will not change because under the hood, it's a hash table. It's making a mathematical computation to determine where in memory it needs to go so it can do a fast lookup. Okay, not a huge super deal, but I just want to print one item out. Let's just try to print that first item out and see what happens here. Uh-oh. Set object does not support indexing. Oh my goodness, that is so frustrating. You may be thinking, well, this is stupid. Why even use this? Let's just use a list and get it over with. Well, you can. However, a set is designed for a specific reason. That is fast lookup. Think of a set like you would have settings. Like, for example, all of your computer settings. There's probably thousands and thousands of computer settings. If you put that in a list, it's going to be hard to really navigate. So you would use something like a loop or use the keyword in, things that we haven't covered yet and we will cover in future videos. But what we're going to talk about is some down and dirty ways you can modify a set. So, for example, let's say, let's run our code here and see what we got. So we've got 3, 46, Karens, and Brian. Let's go ahead and say 3 in S. Let's go ahead and print this out just to see if this is in there. True. So we know that 3 is in S. Let's go ahead and say s.remove, and we want to remove that 3. Now, we want to go ahead and turn around and add 12. So basically what we're doing is we're saying, take this set, remove this 3, and change it to a 12. Unfortunately, we cannot control where it's going to put it in the set. Let's go ahead and print that out, probably be a little more helpful. There we go. Ta-da! So now it's 12, 46, Karens, and Brian. Honestly, dumb luck that it's in the same position. Don't count on that because the set is unordered. Now we can do some crazy things here, and this is going to really hurt your brain. So let's go x equals, and we're going to make a set. And let's say A, B, C, D. And I'm quite literally just freestyling this, so expect me to make some typing errors here. And we're going to say C, D, E, F, G. So we've got 2 sets. Now we want to do some mathematical computations on these. And this is kind of the standard way of doing any sort of set modification. We're going to do what's called a union. So I'm going to say S equals, and we want X dot union Y. And what this is going to do is it's going to, and I'm going to see if I got some notes off the screen here, all the elements that are in either set. And I'm going to do a little print statement here. So our union is now all the elements that are in either set. Very rapid modification of that set. You don't have to go and remove and add and check and see if it's in there. I'm going to just grab this whole thing. And let's go ahead and do an intersection. Now an intersection is a little bit different. it's going to get all the elements that are in both sets. Go ahead and demonstrate that. And what's in both is D and C. See? Pretty simple, pretty easy to wrap your head around. Now let's get a little bit crazy here. So we're going to grab this. And we want the difference. You ever have somebody say that to you? Let's, split the difference. So the difference are all the elements that are in X, but not in Y. Which in this case is B and A. And one more that we're going to cover here. And this is the, maybe if I get my mouse to work, the symmetric difference. Now this is going to be a little bit different than what you're thinking. So this is all the elements that are in one of the sets. What does that mean exactly? Save and run. All of the elements that are in one of the sets. So it's going to take both of them and basically make a third set in memory and say, okay, make sure what we're giving back is a unique order of items that exists in at least one of the sets that we've given it. And it gets way more complex than that, but that's basically what's going on under the hood. You can see we have F, E, B, A, G. So the main takeaway from here is all the way up at the top, sets contain unordered, unique, immutable data types in a blistering fast hash table. What is the fundamental difference between a set and a list? Well, the set is, a little bit more challenging to work with, and you cannot modify it as easily as you can with a list, but it is much, much faster, which you're really not going to understand how fast that is until you get into more advanced programming. Right now, we're learning the fundamental data types, and we just covered the set in depth. Welcome back, everyone. This is Brian. Let's continue our journey into Python 3 with the tuple. Kind of a funny name, but this is really, really cool. So a tuple is a fast list that cannot be modified. It's read-only. Once you create it, you can make 0 changes to it. This thing exists solely to exchange data, and it's typically used between classes, between objects, between frameworks, and between devices. For example, let's say somebody made a package that was going to give you the CPU and RAM and hardware and all this cool information about your device. They don't want you to be able to modify that. So it may seem kind of plain and boring on the surface, but you can do some really cool tricks as we're about to see. First thing we're going to do is create a tuple. Go ahead and make a variable named t, and let's give this an assignment. Notice how it's got these little curved brackets here. When you see these curved brackets, think of it like a shield defending it. Because it's read-only, you cannot change this. We're just going to give it some information. We don't really care what we put in there because we're just testing it out. Say print and t. You guessed it, it's got these curved brackets, and that is what denotes it's a tuple. The major takeaway here is the different style bracket denotes what it's going to be, whether it's a tuple, a set, or a list, or a dictionary, which we haven't covered yet. Now that we have a tuple, let's look at how to access the elements inside of that tuple. It's dead simple. We've done this before. Let's go ahead and say print f, and we're going to access via the index. Give it our index position. Remember, this is a 0-based index, so 0 is actually the first position, and then 1, 2, and so on and so on. Run works exactly the way you would expect it to. Let's go ahead and do a slice, because slicing is pretty easy and fun. And we're going to grab this and say, I want to go from 2 to the end of the tuple there. Works as expected. Go ahead and clear this out. And let's look at a bool operation. What we want to do now is we want to look for something specific inside of that tuple. I want to say is 3 in t. What this is going to do is tell Python, hey, take this value and inside of this tuple, and it could be a list or a set or a dictionary. We haven't covered dictionaries yet. And it's going to search and see if it's actually in there. It's going to return a bool saying yes or no. In this case, true, because 3 is right there. This is extremely easy to work with, and it's blistering fast. Okay, bonus material. Let's talk about assignment. When I say assignment, what are we really talking about? I mean, tuples are kind of boring. You create them and you can access elements. Other than that, you're done. Well, you can do some really cool things, not just with tuples, with lists and sets, but tuples make it really simple to understand. So we're going to make a tuple, and we're going to put some variables. These are not values, these are variables. Remember, a variable is something that'll change. X, comma, Y, comma, Z. Now, I'm going to make another tuple, and we're going to give it values. 1, 2, 3. What are we doing here? Well, we're saying take these variables and give them these values. And Python under the hood is going to figure out which one needs to be which. Go ahead and print X. Let's print Y. And let's go ahead and print Z. See this in action? Ta-da! 1, 2, 3. Beautiful. Now let's talk about the range function. And this is something that a lot of people don't really talk about too much. You just see it and you expect that it'll just magically work. So let's grab this. There we go. So we've got X, Y, Z, and we're going to get rid of this right here. And we're going to say we want Python to do all that work. We don't want to sit here and type out values all day long. So I'm going to say range. And let's give it a 1, see what happens here. If you're expecting an error, you got an error. Not enough values to unpack. Expected 3, got 1. Well, let's just test this theory and say we want 6. We're going to give it more than it needs. And, of course, another error. Too many values to unpack. Expected 3. So it's telling you, I demand 3. Where's it getting 3? From right here. Under the hood, Python is making a tuple of variables. And we can assign to those variables using the range function. Now, range itself is not returning a tuple. We can test this out by just simply grabbing this and print this out. We're going to actually print range 3. Notice how we got 0, 1, 2, so there is our range, but then we're printing range 3, and it's saying range 0 to 3. So what we're really expanding upon here is that the range itself is telling Python, go through a loop, something we're going to talk about in a future video. But you have a start and an end. We haven't really given it a start and end. We just said, hey, make 3 values. It's going to start at 0, go 3 times. What if we don't want to start at 0? We want to start at 1. Well, we give it a start, and now we have to give it an end position here. 4. Why 4? Because we need a starting position plus a length of how many we need to unpack, which is 4. 1 plus 3 equals 4. Ta-da! Now it just works exactly the way you think it would. Hello again, everyone. This is Brian, and in this video, we're going to cover the dictionary in Python 3. So, what is a dictionary? It's a key value pair. More appropriately, it is a list that's indexed by keys. If you want to be really specific, you notice the brackets. This is actually a set indexed by keys, which can be any immutable type. What does that mean, any immutable type? It means unchangeable. So let's take a look and let's see what it takes to create and work with a dictionary. Let's take a look and see what it really takes to create a dictionary. We're going to do this 2 different ways. We're going to do it the hard way and the easy way. First, let's do it the hard way. I'm going to say v equals, we've got our brackets. We need a key value pair. So let's create the key. Key is going to be the string pet, colon, and now we need a value. Let's say dog. That's it. That's really all there is to it. Now, if we want to make another one, we just separate it by a comma. Now we need a key. Well, let's call this age. Value is going to be 5. Let's go ahead and make another one. Let's call it name. And its value is going to be Spot. I'm always bad at picking pet names. Go ahead and print out the dictionary in all of its glory. There it is. Pet dog, age 5, name Spot. Ta-da! Now let's do it the easy way. I'm going to say d equals, and we're going to call the dict function. Funny name, say that real loud in class and watch everybody just kind of look at you. But we're going to say pet equals dog, age equals 5, and name equals Spot. So what's really going on here is it's doing all this formatting for you. That's why I call it the easy way. The end result, however, is exactly the same. They are exactly the same. Doesn't matter which way you create it. Just under the hood, know that you have to have a key value pair. For example, pet dog, age 5, name Spot. Let's take a look at the keys and values and how we get at them. There's a third type really, and it's called items. We're going to work with that one first. So we're going to say print, and we'll go f items. And we're going to call the dictionary items function. Save run. And this is going to return a dict underscore items, which you guessed it. Look at this thing. This is insane. So we have a tuple containing a list containing tuples. But what it's really done is it's packaged it into individual items. So you can very distinctly see the key value pairs. Not abundantly useful for us. What we really worry about are, well, the keys and the items. So let's go ahead and look at those real quick. I'm going to just say keys and values. Did I say items earlier? I did. All right, so we want to look at the keys and the values. Save and run, and voila. So we're returning 3 different things. Dict underscore items, dict underscore keys, dict underscore values. But what we've got is all of the information in this dictionary right here in these 3 functions. See, items returns pretty much everything nice and packaged. The keys is going to tell us what keys are available, because remember, everything's a key value pair. So when we go to look something up, we can't do it by index. We have to do it by key, which is why these keys exist. You could easily make these keys integers or numbers of some kind, but we've done it as a string. We can also get the values dog, 5, and Spot, which are abundantly unuseful without the keys. So in the next section here, we're going to take a look at how you would actually get those. Let's go ahead and take a look at how we would get a value from a key, because these are key value pairs. It's called the key because it unlocks the door to the value. And let's take a look at what I mean here. So I want to format this, and I'm going to say name. So let's capitalize that. And we're going to say D, and you inclined to do something like this, D0. Let's run this, and key error. What does that mean, key error? It means the key was simply not found. We don't have a key named 0. We do, however, have a key named name. We also have one called pet and age. So you have to use the key to get the value. Let's demonstrate that. See, the name is Spot. Now, you notice how I have different quotes. I have single quote and double quote. There is a very interesting little issue here where if we do a single quote within a single quote, bad things happen very quickly. We get an invalid syntax. And you're looking at this going, now wait a minute. It should treat everything in these brackets as a separate entity, but it really doesn't. So you do have the quote issue that we've talked about in a previous video. All right, so now that we've wrapped our head around that, let's take a look at the key error in depth. And let's call this test. And let's just say blah. Some key we know doesn't exist. Really what's going on here is it's going out and it's trying to find any key of that value. And if it doesn't find it, it throws a key error. At the very end of this, we're going to show you a little trick using some simple logic, which we haven't covered yet, to get around that to determine if the key even exists in the first place. But just right now, know that you have to have the key, otherwise it will throw an error. So just put a quick note there, will throw an error if the key is not found. Let's go ahead and take a look at how hard is it to add an item to a dictionary. Well, it's not. It's ridiculously simple. You just simply do something like this. There you go. It's that simple. You just simply say dictionary and then some key that's not in use equals a value, and it will add it automatically. It's very cool how it does that. Now, you should note, and we're just going to copy and paste this, what happens if the key already exists? So here we're adding, and here, what's going to happen? Let's run and find out. It's just simply changed it. This is what I mean by the key is immutable. We cannot change this key. We could delete it and re-add it, but once that key's in there, all we can do is update the value or delete it. The key itself cannot change. And let's take a look at what it takes to remove an item. Our good old buddy, the delete statement. So we're going to delete, you guessed it, the trick. Now, this is what I mean by this is a key value pair. When we run this and we delete a key, the value associated with that key is also removed. You see right here. Trick, roll over, we've deleted it, and now it's just simply gone. It's not in there. Very simple to do that, but just understand that once you delete the key, the value is gone. However, if you were to try to delete the value, the key will be there, but you'll have a null value, and that could lead to some issues down the road. That's a more complex topic we're going to cover in a future video. I just want you to be aware of that. I've been getting a lot of really good feedback about this video series, and some people have said, hey dude, you're going a little too slow. I realize these are for beginners, but I want more now. So we're gonna give you a little preview of what to come. So we're gonna test for existence, and we're going to do something called a loop. And both of these may be a little challenging, especially for newbie programmers, but if you're an experienced programmer and you just wanna learn it now, let's just go over it and get it out of the way. So we're gonna say if, and this is basic logic. I say name in d colon and hit enter. What we've done here is an if statement. This is a logic. If this key is in the dictionary, do something. Now, Python has this little guy right here, this colon at the end saying, hey, it's not the end of the statement, expect more. And then you have to have, it's either spaces or a tab, it doesn't really matter, but it has to be the same amount. If you're from another language, you're expecting something like this. And you may be going, why do you need tabs? Well, if you think about it, your code is here. And if you get rid of the tabs, it looks like this. So it just makes sense. But a lot of people, when they're first starting Python, can't wrap their head around the tabs or the white spaces, and it just infuriates them. So this is what I was saying earlier about we're going to test to see if that key exists before we try to access it. Now, if the key was not in the dictionary, it would throw a key error, but we're saying if. So only if this exists in the dictionary are we going to run this code. We're going to go over all of this in more detail in a future video, but I've had a lot of people saying, hey, they want more now. So there's one. Now let's go over loops. this is the other thing that really trips people up, especially in newbie land, is because they're new. They don't understand this stuff. Nobody's explained it to them. What is a loop? Well, have you ever like gotten in trouble as a child and like your mom or dad says, go do this until I tell you to stop? That's basically what you're telling the computer to do. You're going to say for a key in D keys, and this may look really confusing if you're a complete newbie. Again, gotta have that white space. We're gonna go ahead and print. And let's go ahead and format this. And I am gonna explain this, but at the moment, just take a huge leap of faith with me here. So we got our key, and then we're gonna say dictionary, and then the specific key. This looks ugly if you're a newbie, but let's run it. It works. So it's saying pet dog, age 5, name Spot. That's what we're doing right there. So what's going on here is we're saying for every key in, there's that in keyword again, the dictionary keys. Remember we talked about this way up here. For every key in the dictionary keys, go ahead and print out the key and the dictionary value that correlates with that key. Again, you have to have that tab there. We're going to cover looping also in a future video, but this is just because people have been saying, we want more and we want more now. So if you're having trouble wrapping your head around these two right here, don't worry. I'm going to make a future video that's going to cover those in depth, and we're going to talk about them. And I do mean in depth. But if you are a seasoned programmer, that's very simply how you do it. If you're having trouble wrapping your head around these tabs, just think of it like this. You have some code, and then normally you would do something like this. And Python's trying to help me out here. But you would have something like that. Strip this out, replace it with that. And of course you'd have something here. Sad code. Why not? Let's say sad code here. But then you strip these out and it becomes that. And that's why Python is so much smaller than other languages compared to something like Java, JavaScript, because it takes all those special characters out of there. Welcome back, everyone. My name is Brian. Let's continue our journey with Python 3. So in this video, we're going to talk about if, else, and elif. What are these three things? Well, it is simple flow control. And when we talk about flow, we're talking about the flow of an application. And this is the basic building blocks for that flow control. Before we dive in, we need to talk about some basic theory. Don't worry, I'm going to keep it super short. We have a variable. Let's call it x, and x is true. A very simple bool. We can turn it on, we can turn it off. Now we're talking about flow control. Think of flow control like when you were a child and your parent looked at you and said, if you do this, then this is going to happen. That's essentially what we're talking about. It's a decision. It's not super hard to wrap your head around, but it does take some explanation. So x equals true. We've got our if statement, and if is going to function on some sort of condition. A condition, most of the time, will evaluate to true or false. So we're going to say if x equals true, then do something. We'll have some code that'll run if it's true, and we'll have some code that'll run if it's false. Now, this is not always the case. What I mean by that is sometimes this over here simply doesn't exist. You're only going to evaluate for true, but you can do things like say, if it's true, do this, else do that. And it can read like a book. You can literally say, if Bob equals happy, then do something. If Bob is not happy, do something else. It's really that simple. However, you need to understand this is the fundamental building block of almost all applications. This is called flow control. You are controlling the flow of the application's logic. All right, enough theory. Let's dive right in. We're going to look at if conditions. So we're going to create a variable called x, and we're going to say it is true. This is just simply a bool. We've seen this before. Now I'm going to say if. And you notice how in VS Code it gives us these little templates. We're just going to do normal if. We're going to say if x colon, and now we want to print something out. Let's go ahead and run this and see what happens. And it says yes. So our programming logic is x is true, and if x, notice how I just said if x. We could have said if x equals true, then it's going to print this out. But it knows it's smart enough to know you don't really need that. Also notice this indent. We've talked about this a little bit before, and this colon. So if you're coming from another programming language, this is really what it looks like under the hood. You have these brackets, as everybody loves in, C++, C#, JavaScript, all the C-style languages, and the code's pretty much indented. Well, Python does away with that. So all of this gets converted into that, and it's much shorter, much easier to read. You don't have all these weird squiggly lines you got to worry about. Now, you can continue to execute as long as it's on the same indent. For example, x is true, if x, print yes and again. See? Yes and again. Now we are going to say else, and this is where we pop back. Need that right there to tell Python that we've got more coming. And we're going to just simply print O. What's going to happen when we run this? Well, x is true, so if x, and then it's going to run this. Else, it will run that. Else is funny because else says, hey, if this didn't happen, then instead run this code here. Whenever you see these indents, think of this as a block of code. It's actually called scope. So this would be a scope, and this would be a scope. It's a much more complex topic that we'll cover in a future video, but I want you to be aware that exists. Let's go ahead and run. You see yes and again. It never printed no. I'm going to say help. I mean, just to make sure this really stands out on the screen. Run it again. We never see it. Why? Because this is true. If x, then print this out. It never jumps to else. So let's change this to false. And you'll get a feeling for how programming logic takes place. X is now false. It's going to say if x, print these, else print that. So what's going to happen here is it's going to get to x and say, nope, x is not true, so ignore this block of code and instead jump down to else and run this block of code. See? Help. Works as expected. So what we've really been talking about is condition evaluations, and they're pretty much going to be true or false, meaning true, run it, or false, don't run it, or just do something completely different. Let's take a look at some condition evaluations here. So I'm going to say x equals 100, y equals 25. So I'm just creating two little variables here, and I'll say if, and we're going to say y equals x. We want to tell Python there's more coming, and we're going to print this out. Notice I'm doing this all on one line. You don't necessarily need to do these tab indents. You can do everything on one line if you want to. So we're saying if y is equal to x, notice there's two equal signs. If you do this, you're saying make y the value of x, and we don't want that. We want to test for equality here. We're going to say equal to, and we can just, through the magic of copy and paste, speed this up just a little bit here. And we're going to look at our condition evaluators here. So I'm going to say if y is not equal to, and then we can say less than. So if y is less than x, and I want to say greater than. So if y is greater than, what we're really getting at here is you can do some really complex decision making based off values. And they're very simple, very easy to understand. All you need to do is understand the symbols. For example, This guy right here looks super confusing, but we're saying if y is less than or equal to. Notice how you have this compound here. So now this gets really complex and you've got it all on one line. But it is super convenient to do that. And you can do the exact opposite. You can say greater than or equal to. Let's go ahead and test this out here. So we're going to run this, and you can see it doesn't print everything. It says not equal to, less than, and less than or equal to. So what's going on here? We're evaluating y versus x. So we're saying, is y equal to x? Well, it's not. They're two different values. So it's not going to run this code. This is what I mean by the condition evaluations will go to true, run it, or false, not run it. There are other ways of doing it, but we're keeping things super simple. And then we're saying if y is not equal to x, which is going to evaluate to true because those two are not equal, then print this out. And sure enough, we see not equal to. I'm not going to go through each line, but you can kind of view and see which one of these evaluate to true. For example, is y greater than x? Well, of course it's not. 25 is less than 100, so this will never run, and we don't see it down here. Now, if we change this value, you'll notice the output changes as well. Now it's not equal, but it's greater than and greater than or equal to. This is extremely cool, and it's extremely flexible. Now you start to understand how computers make decisions. It's based off simple if logic. If this statement or this condition evaluates to true, then run some specific code. All right, all of this seems pretty cool, but look at this. It's kind of a jumbled mess. It's just this big wall of if statements. It's very hard to read. There's no indentation, and you got to kind of read through every single one to find the one you're looking for. Let's talk about elif, which is really a switching solution. Now, when I say switching, other languages have a concept called a switch, which is just like, think of a big panel of light switches. You can turn them on and off. Python doesn't really have that concept. There's ways around it, but it doesn't really have that specific concept. So let's look at a way of getting around this. So I'm going to say x is 10. Now we want a bank of switches. We want to be able to turn code on and off at will. So I'm going to say if x equals 25, then we're just going to print out x equals 25. Now we want to take this and kind of smash it into something without doing a completely new if statement. We want this to stay all in one line because, believe it or not, these are two different statements and they'll execute separately. So what we're going to do here is elif x equals 50. So really now it's going to read this as one giant line. So it's going to say if x is 25, execute this, else if x is 50, execute this, and we can just take this concept and keep expanding on it. Go ahead and say if x is 75, and let's go ahead and say 100. We can end this and say, you know what? If we didn't find any of these switches using the elif statement, we can simply say else and then make what's called a catch-all. Which is going to execute if none of these fired off. So it's at 10. Let's see what's going to happen here. It triggered our catch-all. See? So it went through and evaluated and says, is x 25? No. Is it 50? Is it 75? Is it 100? Else, fired off. Let's switch this to 75. See what happens. You can see now it just says x is 75. So what's going on here is it says, evaluate this, evaluate this, evaluate this, turn to true, run this code, now we're done. So it'll jump all the way out. Very simple, very easy logic, and it looks much better than just this giant wall of text. Super easy to follow. As you dive deeper and deeper into programming, you're going to find there's always another way of doing it. If you didn't like elif, there is another way. and it's called nested or nestled statements. And this is basically a statement and a statement and a statement and a statement. And you can go on forever and ever and ever. Let's go ahead and take a look. So I'm going to say x equals, and let's just pick a number at random, 82. And we're going to say if x is greater than 50, print, and let's say over 50, but wrap that in some quotes here. And because it's over 50, we want to keep going. So I want to say if x is, well, greater than 60, then, and we can use the same logic over and over and over. And this now becomes a very repetitious pattern. So for example, I can just say this, and we can just grab this and keep going. Notice how the indents get bigger and bigger and bigger. You have to do this, otherwise Python considers that a new statement. So for example, this would actually create a problem here. It's not going to execute the way we want it to. So what we need to do is indent, indent, and this is what I love about VS Code, is it puts these lines where the indent is. So now you can see this is a statement, this is a statement, and so on and so on. And it gets very, very cool very quickly. Now, sometimes pasting betrays you and you just simply got to tab it over. Again, the lines will be your guide and literally tell you where you need to go. So let's say if it's over 90, and I don't want to take this too ridiculous, let's go ahead and say if x is greater than or equal to 100, we're just going to end it here. Print complete. Let's just say that x stood for some sort of progress. Now, we've got some issues here right off the bat. You notice how this little squiggly line here, it's saying unexpected indent. So we've got to back this out here and fix our indentations. Uh-oh, didn't like that. So we can just grab this whole thing and indent it. Should fix it. There it goes. Save and run. Uh-oh, we have another indentation error. Let's see what's going on here. So this is the part of Python that will drive you absolutely bonkers. If you don't have your indentation right, it will let you know, and you'll get an indentation error. Now that all my indentations are fine, it should run as expected. So which one would you use? Well, it depends. So for example, in this scenario, we have what's called fall through, meaning x is 82. So it's going to evaluate true, jump to the next one true, jump to the next one true, and jump to the next one true, and then it's suddenly false. So it stops executing here, even though there's more of the statement. And you have these lovely little indents, love them or hate them, that you have to contend with. Remember, the indentations tell Python where you are in the programming logic. So some people like elif, some people like fall through, expect to see both of those out in other people's source code. Choose the solution that works right for you. My personal preference is for elif. Welcome back, everyone. My name is Brian. Let's continue our journey into Python 3. We're going to talk about the while loop. This is basic flow control, and it's going to prove a point. Your computer is very stupid. And yes, I said what I said. Your computer is just very dumb, and we're going to prove that. So a loop is just simply completing code over and over and over again until you tell it to stop, because the computer isn't smart enough to know when to quit. Let's take a look. Okay, a little bit of theory here before we move on. We have the entrance of our program, and we're going to jump down into some sort of loop. Let's call this our loop here, and it's going to evaluate this and run some type of code. Now, it doesn't really matter what type of code it runs. Let's get rid of that little guy. Usually what you're doing is some sort of incremental function. For example, count something, increase a number, look for data on a socket or something like that. So it's going to say, okay, start the loop. Don't want to connect there. There we go. and do something. If you don't exit this loop, it just literally goes right back into the loop, and your program ends up looking something like this. We call this an infinite loop, where you will enter the program, go into a loop, and then you just loop this code over and over and over again until you tell it to, well, stop and do something else. You may be asking yourself, why do you even need a loop? Well, think about it. You enter your program, you come down into your loop, and let's say you want to do something 100 times. You need to now increment some sort of counter. Once you've hit that counter, you jump out of this loop and you stop your code. There are some loops out there that are intentionally infinite. And what I mean is they look like this. The program starts, you enter your loop, and then it just loops forever. For example, when you do graphic user interface programming, you have what's called the user interface loop or the event loop, which is basically the program will run forever waiting for the user to like click a mouse or move something around. That loop just happens forever and ever until the program closes. All right, now that we understand what a loop is, let's take a look at it in practice. So I'm going to say x equals 0, and we're going to create our while loop. And this is going to look very similar to an if statement because it's going to evaluate it just like an if statement would. Meaning this loop will execute as long as the condition we're about to give it is true. So I'm going to say x is less than 10, then do something. And this is going to be a great example of how computers are dumb. They do what you tell them to as you tell them to do it. Little bit of bonus. Anybody see a problem with this statement? Well, what we're saying is x is 0, while x is less than 10, print this, but we're never incrementing x. It's always going to be 0, so this will always be true, and it will just run forever. That's the infinite loop I was telling you about. See how it just says 0? And it's going to run forever and ever, and that console is just going crazy, so I'm going to kill it. It will just keep going forever and ever until I turn the program off or until I shut the computer down. So we need to actually increment x. Once we do that, we have now incremented our counter. Eventually, x will be 10 or greater, and this will exit out. See? 1 through 10. Works as expected now. So loops can be very powerful and very easy to use, but you can very much screw up your application just by creating an infinite loop on accident. Now, in case you're wondering, let's go ahead and print this out here. And we're going to say, test 1 is done. We want to know when this loop is done executing, and we use, you guessed it, the indentations. This determines our scope or our block of code. So while this condition is true, execute this scope or this block of code. Then when we're done looping, we're going to jump right back up here. Let's see that in action. I'm going to clear that out. Sure enough, 1 through 10, and then test 1 is done. So it works exactly the way you think it would. Let's take a quick detour and talk about pass. You're going to see this quite a bit in Python land, and a lot of people don't really explain it. So let's just say while, and let's just take this little template here, and it's going to say while expression pass. But this is a valid Python expression. Go ahead and say 0, and let's just give it the same logic here. Notice how this will run. Now what's going on under the hood is this is still functioning. Or is it? Let's find out here. I'm going to kill this terminal just in case. We'll say test 2 is done. So x0, while x is less than, notice how we never increment it like we did in this guy. We're going to pass, and then eventually print out test 2 is done. Save run. Notice how it says test 1 is done from up here, but it never gets down to test 2. So what's going on under the hood? This script is still running. It's just doing an infinite loop right here. So whenever you see pass inside of a loop, Be very careful because you're creating some sort of infinite loop. Pass is a special keyword in Python that tells Python, take no action and just continue with what you would normally do. So be very careful with pass. We just covered that pass is, well, pretty dangerous in a loop, simply because you can loop forever on accident. Well, it's not that simple under the hood, but we're going to try and make it simple, and we're going to talk about continuing and breaking. So we're going to say x equals 0, and let's go ahead and do something really, really terrible. We're going to say, while true, do something. If you're paying attention, you know that while is going to evaluate this much in the way an if statement would, and it's going to say, if this is true, do the loop, and keep doing it over and over until this is no longer true. However, we've used the Python true keyword, so this will now loop forever. And you will actually see this out in code because sometimes people just want to loop until some arbitrary condition is met. It could be input from the keyboard, it could be some network connection, it could be anything, but you're going to see this a lot. So you'll need to know when to break out of the loop or how to handle certain conditions. So let's talk about continue first. We're going to say x plus equals 1. And if x is less than 5, we want to, well, just kind of skip over this. And we don't really want to do anything. So I'm just going to say x is less than 5, whatever the number is. And then we're going to continue. And what continue does is say, go back to the beginning, just continue along your merry way and do what you were going to normally do. And then we're going to add in some sort of logic. So if x was greater than 10, we would do something. Print that x out. And we're going to put a print statement at the very, very end of this. And notice this is on the same line as while. So this will not print out until this loop is complete. And one thing I love about VS Code in most editors, you can actually collapse. So it actually looks like this. So once this loop is done, it'll print complete. Let's go ahead and clear this out. See this in action here. Uh-oh, you notice how it's working exactly as we expect it would, because the computer, while very fast, is very dumb. So what's going on here is it's going and saying, if x is less than 5, print it out and then just go back to the beginning. So we're still in continual loop land. We need to fix that. So our programming logic, we want to basically say, if it's less than 5, just go back to the beginning of the loop and keep incrementing that counter. If it's greater than 5, do something, but we also want to stop when we hit 10. So I'm going to say if x is 10, print and then x equals, just so we can see that x is actually at that value. Now we're going to use the break keyword. Now, don't worry, we're not breaking anything. Break is like, kind of think of the while loop, this guy, as a little jail cell. And we're going to break out of jail and just jump right to the next line. So it's going to pick up code execution right here, and then it's going to run this statement. Let's go ahead and see this in action. Okay, sure enough, we've got x is less than 5. We've got 1, 2, 3, 4, and then do something 6, 7, 8, 9, 10. And then when we hit 10, we're going to exit and we are complete. So that is looping in a nutshell. Some major takeaways from this video is, well, loops are very, very powerful, but you need to have some sort of condition to evaluate. Otherwise, you're going to create an infinite loop. An easy way to create an infinite loop is just simply pass, and it will loop forever. And you can say while true, which will also create an infinite loop, but you can use continue to, well, continue to use the flow inside of the loop, or break to break out of that flow and use the programming logic. Welcome back, everyone. This is Brian. In this video, we're going to talk about the for loop and the range function. The difference from the for loop compared to the while loop, which we talked about in the previous video, is the for loop has a beginning and an end, and the range function helps us create that beginning and end. Really helps us to just avoid that nasty business of infinite loops. Let's dive in and take a look. All right, first things first, let's go ahead and look at the for loop on list tuples and sets. This is super ridiculously simple. And I'm just going to make a simple list. And we're going to say for I in. Notice what we're doing here, though. We're saying for, and then we're creating a variable. And this variable is named I. You could name it X, Z, zebra, whatever you wanted to name it. I'm just going to say for I in, and now we have to give it some sort of container. I'm going to say X, and then the colon. This reads just like the while loop, but we are now creating the variable in the statement itself. What we can do now is just simply say print, and let's say I, and we're going to print out the value of I. Go ahead and run this. You see I is 1, 2, 3, 4, and it stops. We don't have to tell it to break or to return or to do anything like that. And we don't have to increment some sort of counter. It does it for us under the hood based off the, you guessed it, the length of this list. So it's taking this iterable container and it's saying each one of these is now a separate variable and we're going to treat it independently. And you can do this ridiculously fast, and you can do it across different types of things here. So for example, I think I made one too many. We're going to say list, tuple, and a set. And we're just going to say this is L, this is T, and this is S. So we've got a bunch of different things here, and let's actually, one of the little nuances of this is you got to have it in the right style bracket here, or this case is the parentheses, and the set has the little weird squiggly thing. There we go. And we can just switch this out. So we're going to do the list. Works as expected. Let's switch this out to the tuple. Works as expected. And I know you're already probably rolling your eyes going, we know, the set's going to work just fine. And it does. Everything works as advertised. This makes it just ridiculously easy to loop through a container. Let's take a look at the for loop in regards to dictionaries. We're going to treat this a little bit differently here. So I'm going to make a dictionary, and I'm going to say dict, and let's just go ahead and build this out. Brian, I'm going to say my age is 46. Say Tammy. Don't tell her I put this in the video. She'll get very mad, but she's 48. And then Heather, let's go ahead and say Heather is 28. And Chris, let's just say Chris is 30. We could add more if we really wanted to. So we have our beautiful dictionary here. Go ahead and print this out just so we can see what it looks like. And it creates a dictionary for us. Now we're going to work with this in regards to the looping. When I say the looping, there's a couple different ways we can do this. So the first way, we're going to say for k in x dot keys. Now you got to be a little careful here. If you forget to call it as a function, and we haven't really covered functions yet, but trust me on this. If you just do this, you're going to have a bad time. And let's actually see it fail, just to prove that, hey, it is going to fail. And we're going to say keys k equals, and then we're going to fill that out later. But let's just watch this thing fail. See? Built-in function or method object is not iterable. What is going on here? What does this mean? Plain English, built-in function or method. Well, we haven't really covered these yet, but basically it's a chunk of code that we can call. And to do that, you need these parentheses. So if you forget those, you're going to have a bad time. And it says object is not iterable. What does that mean? Well, it needs to be a container of some kind. For example, a list, tuple, set, or a dictionary. So simply by saying, hey, use those parameters, it's now going to return some sort of data that is iterable, which we can go through and work with. All right, let's continue on. We're going to say X, and we want to get that specific key. And I'm going to just assume you watched the previous videos, but just in case you skipped them, let's slow this down just a smidge here. First things first, we need to fix our little error there. So what's going on here is we are creating our dictionary. The dictionary is just a key value pair. Key value, key value, key value. And you can see that in the dictionary right here, where it's created those key value pairs. Now we're going to say for each K, or each key in our dictionary's keys, it's going to return back some sort of list. We're going to say for each one of those, get the value. So we're saying XK. So really what we're saying here is X is a dictionary, K is the key. So we're saying for whatever key, for example, if it was Tammy, it's going to say print out Tammy, because that's the key, and then print out the actual value here, which is that right there. So each key is going to correlate to a value. So what I'm trying to really drive home here, maybe I explained that badly. So keys, and then you got your key value, key value, key value. There is another way of doing it. And I wanted to bring this up simply because you're going to see people do it both ways. So we're going to say for K, comma, V, this is going to blow your mind if you're coming from another language. We're going to say two different variables here, key and value, in, we want to switch this out to items. And again, we're calling a function, so we need those parentheses there. If we forget those, we're going to have a bad time. And because we are now pulling these or unpacking those, we don't have to do this little bit here. We can just simply swap that out with our variable. So what items is doing is, well, it's actually pulling each key value pair out and returning it. So now it can unpack the key and the value. So you have two different variables. Let's see that in action here. Let's save and run. And actually, let's call this items so we don't get that confused with the keys. And sure enough, items, and it has unpacked them correctly. Brian 46, Tammy 48, Heather 28, Chris 30. So which way's better? Well, it depends on what you want to do. Personally, I tend to do this method right here. That way I don't have to mess around with all these little brackets remembering what does what. But each way is perfectly fine. Let's talk about range, and we've touched on it briefly, but let's really look at range. So let's kind of quick review here. We're going to say X equals, and we want a range of 5. And if we print this out, this is where you're going to get really confused really fast. So let's go ahead and run this. And here's our X right here, range 0 to 5. Wait, what? You're thinking this is going to return a list or something like that. Actually, it's going to return a function call. So there's range 0 to 5. What is this 0 to 5? Where did this come from? We said 5. Well, we're going to look at that in the next little segment here. But just understand what we're really doing is we're saying X is really going to equal a call to that function. We're going to cover functions in depth in other videos. It's actually a large topic, so we're going to split it into multiple videos. But just understand what's going on here. You're not actually getting some sort of iterable container that you can go through. But what we can do here now is something like this. For I in X, notice how I don't have these parentheses because we are not calling a function directly, we're calling a variable. If you try to do something like this, you're going to have a very bad time. Just understand the difference between those. And then from here, it just becomes really ridiculously simple. This is what I love about Python. Everything just becomes very simple to the point I'm almost embarrassed to just even talk about it. Because to me, because I'm an old programmer, it seems like just common sense. And there we go. Range 0 through 4. So what's happening under the hood here is it's saying for I, so we're creating a variable in X, and this variable is actually pointing to a function. So it's making this function call, getting that value back, and then it's going through each item. Now, if that last little bit hurt your brain, fasten your seatbelt. Range can get a little complex here. So we have a start, a stop, and a step. What does this really mean? Let's go ahead and do this. Let's say x equals range, and I'm just going to leave it here for now so we can read this and see what's going on. We have stop int, so that's the default, but there's different ways of calling this. You can do a start, which means the number you're going to start at, a stop, which means the number you're going to stop at, and a step, meaning how many numbers in between those two you want to jump. Let's take a look at this and see what it really looks like under the hood. So let's say we want to start at 5, we want to stop when we hit 20, and we want to take 3 steps at a time. All right, pop quiz, what is this going to look like? Let's go ahead and print this out. If you thought it was going to say range 5, 23, you were absolutely right, because beginning to understand here that this is pointing to a function, not some sort of value, but we can actually work with it now that we've assigned it to a variable called x. Go ahead and say for I in x. Remember, we're calling a variable, not a function. Go ahead and print okay, bonus round. Who knows what this is going to print out here? Let's see. Starts at 5, and then it goes to 8, 11, 14, 17, and it stops at 20. Notice how it didn't fire off at 20. If we said 21, let's see what happens. Now suddenly it includes that. So that's the major takeaway from here, is it's not going to include that stop. It's going to stop when it gets to there. Remember, under the hood, this is using some sort of loop. It's saying probably something that we've seen before, like this. While, and then x is less than 20. So when it gets to this 20, it's just going to break out of that loop and stop doing it. Once you understand how this works, it makes life ridiculously simple. Something like this would require a little bit of math in other languages, but Python, as usual, makes it nice and easy. Welcome back, everyone. This is Brian. We're going to create a simple application using everything that we've learned to this point. If you're just now tuning in, there are 13 other videos in this playlist you need to go back and watch if you don't know Python. But we're going to make a paint calculator. So we're going to determine how much paint is actually needed to paint a room. When we run this, the user is going to be presented with something like this. Paint calculator, enter a wall size as width, height in feet, or press enter to stop. For the example would be 12,8, no spaces or anything like that. And they can enter as many walls as they want. And at the end, this is going to magically tell them how many cans or how many gallons of paint they need to go buy. Let's take a look. First thing we need to do is, well, set up some variables. So we're going to make a list called walls. And this list is going to exist just to hold the measurements. Second thing we're going to add is gallons. This is going to be, well, how many gallons of paint per square feet? And I'm not an expert, but I did go out and look this up on Google. And according to Google, 1 gallon of paint covers 350 square feet. I question that because every time I have bought paint, I have never bought enough and I've had to go back to the store and get it. Maybe this application will help us. And then total is going to be the total number of gallons of paint we need to go buy. We're going to use this later. Total gallons to buy. So far, our application does absolutely nothing, but that's about to change. We are going to get the user's input, and we haven't talked about this yet, but we're going to make a while loop, and we're going to say while true, and you may be going, oh, whoa, 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 you're making an infinite loop. That's true. We're going to break out of this, and I'm going to show you how. So we're going to get a variable, and we're going to use the built-in input functions. There's different ways of doing this, but we're going to use input, and I'm going to say enter wall size. Then we're going to break out of this if they don't really enter any data. So I'm going to say len of s is 0. Then we want to just call break. If you're kind of questioning what any of this is, go back and watch the previous 13 videos that I've done on this. So let's go ahead and test this out. We're going to run this, and it says inner wall size. You notice how our program's just stopped and waiting for us. Well, I'll just enter some garbage. I'm going to say cats. And it wants another. Dogs. And another. Fish. And then I'm just going to hit enter. And sure enough, it exits out. So that is the correct way of using an infinite loop to gather user input and to test when we need to break out of this loop. Now that we can get the user input, we need to actually do something with it. And before we try to do anything with it, the first thing we should do is, well, verify that what the user gave us is actually what we're hoping for, or we could have a very bad time. Remember, this whole thing started with the example of 12,8. Well, I entered cats, dogs, fish. I'm not sure how you would calculate the square footage of a cat, but I'm sure it would be interesting and probably involve a trip to the vets. But anyway, so we're going to say sqft equals, and we're going to say s.split, because the s is our variable we got from the input function right up here, and it's going to be a string. So we can treat this as a string and say s_split, and we want to split this on the comma. Again, if you have not a clue what I'm doing here, watch the previous 13 videos. But anyways, string has a built-in function called split, which you can return multiple values based off a character or a sequence of character. So our square footage is going to be the return value from that split function. So first thing we're going to do is make sure we actually have two values in there. And if it's less than 2, well, we want to tell the user something bad happened. Print, let's go ahead and just say invalid format. And then we're going to break out of here. Now remember, break doesn't really care where it is. It's going to break out of this loop. Let's go ahead and test this out here. So we're going to run this, and it's going to say inner wall size, and I'm going to say, okay, 2, 6. It's working, good. 5, 7. And let's enter some garbage, cats. Invalid format, and it stops the loop and exits the program. So it is actually testing to make sure there are 2 items that is split on a comma. All right, we're not done yet. We need to, now that we've gotten the user input, convert it. Because remember, we're working with strings and we want to work with numbers. Specifically, we want to convert from a string to an integer. And this could lead to a bad time. And we're going to demonstrate that. So I'm going to say w equals, we're going to call int, and we're going to do something called casting. And I'm going to do a whole video on this later, but when I say casting, just think of a wizard with a magic wand who's going to cast a spell and turn something into something else. So what we're saying is we want to cast a spell called int, which is going to convert whatever we give it into an integer. And in this case, we are going to get that first value out of square footage. Go ahead and grab this. Give it the old copy paste. Whoa, a little too much copy paste. And let's get the other dimension. So now we have the width and the height from square foot 0 and square foot 1. Interesting bit, if we try to do this and it's not actually a number, we're going to have a bad time. It's going to actually error out and our program's going to stop and die a horrible death. And I'm going to cover how to handle all that in another video. The whole point of this program is to do a program with what we've learned so far in the 13 videos. Now I'm going to say item, and I want to make a list with the width and the height. And we're going to add that to our walls. If in case you're wondering where I got walls from, remember it's way, way, way up here in our variables. It's just an empty list. So we're going to say walls, append. Let's go ahead and add that item in here. So now we have a list holding the wall dimensions for every single wall that they add. Let's go ahead and just print that out just to verify, hey, we did something. So adding wall. Go ahead, save, run, and let's test this out. So inner wall size, all right, 3 by 6, that's a very small wall. And it says adding wall, all right, great. So 8 by 8, let's go ahead and say 9 by 12. Now let's test out this conversion right here and watch it die a horrible death. So I'm gonna say 2 by cats. Uh-oh, invalid literal for int with base 10 cats. And this looks very ugly, and it is. It's a value error. We're going to talk about errors in a future video. I just want you to understand if you get a value error, what's going on is we're basically saying we cannot convert this to a number, or specifically to an int. Remember, think of a wizard with a magic wand, and we are casting a spell called int, which is going to convert whatever we cast it on to an int. Once we've gotten to this point, the only thing that's left is to really just crunch the numbers and tell them how much paint they need. So what I like to do is just tell them what they entered. So we're going to say if you entered. That way, if there's any discrepancy, I can say, send me a screenshot of the app, and I can show, oh, no, you screwed up. You entered the wrong value here. And then we're going to say for m is going to be for measurements in walls. We're going to say the width is going to be m0. Remember, it's a zero-based index, and inside of our walls, we have created another list here. So we're getting this guy, the width. And we can say h1, remember, zero-based index, that always trips newbies up. Now we're going to get the square footage. So I'm going to make another variable called s. I'm going to say that's simply the width times the height. Now I want to get some sort of value, so I'm going to say this is the S, or the square footage, times the gallons. In case you're wondering where gallons magically appeared from, remember it's all the way up here in our global variables that we created. I did Google it. 1 gallon should cover 350 square feet. So this value right here is 1 divided by 350. Not a clue if that's accurate. I highly doubt it, even though I do trust Google. And then we're going to grab our other global variable, total. I'm going to say plus equals v. So we're just incrementing that. In case you're wondering, plus equal, we did cover this in a previous video. It's basically, we're saying total equals total plus the value. But we're just shorthanding it. Now we're going to drop down and go inward. We're going to dent in. So we're dropping out of this code block right here. And we're going back to the main. And we're going to say print, and we're just going to tell them you need to go buy some paint, and this is how much paint you need to go buy. You need to buy, let's go ahead, and if we just say total, it's going to give us some crazy number. So what I like to do is make it a little pretty, and I'm going to say round, and we're going to round the total by 2 decimal places. We're going to tell them you need to go buy however many gallons of paint rounded to 2 decimal places. Let's go ahead and test this thing out and see if it works. So I'm going to say 12 by 8. And let's make another one 15 by 9. Actually, let's make it by 8. That'd be weird if the ceiling was different height. And let's go ahead and say we have an 8 by 8 and a 4 by 8. Just kind of a weird shaped room. And then I don't want to enter anymore, so I'm just going to hit enter. And you need to buy 1 gallon of paint. Basically, it's going to use less than a gallon. I should have some left over. I don't know how accurate that is, and honestly, I'm kind of looking at my little office here going, I think it's going to take more than a gallon to do this. So when in doubt, blame Google. But the major takeaway from this video is, even though we're only 13 videos in and we've really just scratched the surface of what Python can do, you can make some pretty interesting programming logic. We just did a simple application, which is a paint calculator telling us how much paint we need to buy. We're letting the user enter any number of walls they want. We are verifying that user input, and then we're converting that input into the correct data type, and then we're calculating how much they need and giving it back to the end user. Welcome back, everyone. This is Brian. We're going to continue our journey into Python 3 with an introduction to functions. So first off, what is a function? It's a block of code which only runs when it is called. So far, all the code we've written runs immediately. I mean, as soon as Python reads it, it runs it. This is going to change that. We're going to write some code, and we are going to decide when it runs. This is another fundamental building block of programming, and there's a lot of theory attached to it, and there's a lot of names and terminology. So we are going to split this into multiple videos. Some key takeaways from this video, though, is that you can pass data known as a parameter or an argument into a function. You're going to hear these two used interchangeably. It gets really confusing. So down here, I put some notes. The difference between a parameter and an argument. A function parameter is the names listed in the function's definition, where an argument is the real value. That's just confusing. Why don't they just call it like a name or a value, but instead they've got to call it parameter argument, and everyone, even myself, gets these mixed up. You'll hear some videos where I'll call it a parameter and some videos where I'll call it an argument, and I've heard people with vastly more programming experience than me switch these around as well. It's just that confusing. Another major takeaway is that a function can return data as a result. Return is actually a keyword, and we're going to cover that. Diving into theory land just for a moment here, so far we've worked with statements. And what do I mean by statements? We've done something like this so far. We have a statement, a statement, a statement, and Python just reads it from the top down. For example, we would like print something, maybe do a while loop. Inside that while loop, we could have like an if statement, and it's just kind of read like a book straight from the top down. But now what we're going to do is introduce a function, which is a separate block of code. It's not going to run unless we specifically tell Python, go run this code. And a function can call other functions, and so on and so on. The end result now is that we can fundamentally decide how we want our program to run and how we want it to behave. We can do some pretty complex programming logic using this. Another key takeaway here is we are subtly introducing the concept of scope. Everything that we've done so far has been on what's called the global scope, and each function, each block of code, has its own scope. Scope is something we're going to dive into detail in a future video, but just understand we are subtly introducing this. So let's test this. Let's go ahead and define a function. We're going to say def, which is shorthand for define or definition. And we're going to give it a name. And then we have those little parentheses. If we forget those, we're going to have a bad time. We need the parentheses, and then in there we would define any parameters. We're going to keep this first one very basic, and there'll be no parameters, but we still need the parentheses in there. And then colon, and hit enter. And notice how most IDEs will do this automatically, where they will drop you down a line and indentate you automatically. Then we can just fill in our code. We can have pretty much anything we want in here. I'm just going to put a print statement just for testing. And we're just going to say this is a function. Now we can work with this thing as needed. Okay, this last one was a little bit simplistic. Let's ramp up the difficulty here. So we're going to define a function with parameters and return a value. In the last video, we made a paint calculator, which calculated based off the square footage how much paint we needed. We could have very easily used functions in that, and most programs would have. So we're going to make a function called SQFT, which is shorthand for square footage, parentheses, and let's define some parameters. I'm going to say W for width and H for height. Now we can add our programming logic in here. So the value we're going to return is going to be simply the width times the height. Now we're going to use the return keyword to return that value. Notice how these are both very simple, but they're fundamentally very different. This first one basically has no parameters and runs some code, and once it's done, it just jumps right back out of here. This one, however, we have to give it 2 parameters, and there's going to be some logic, and it's going to return a value. It's up to us to decide if we want to actually work with the value that's returned. It's not actually mandatory. We can just ignore it if we wanted to. But this is what I mean by functions can get very complex very, very quickly. We have 2 very small functions that act completely differently. Let's take a look at how this actually works. How would we call a function? Now, what do we mean by call a function? Remember, this code is not going to execute until we specifically tell Python to run it. Let's go ahead and run our program as is and see what happens. Absolutely nothing. So what it's doing is it's reading from the top down. It's saying define test, define SQFT, and it has this queued up in memory ready to go, but it's not actually going to use it until we tell it to. So let's tell it to run it. Most editors are going to be smart enough to tell you, hey, this is an actual function. And in VS Code, this little block means it's a function. And notice the block because it's a block of code. Now, if I just hit OK or enter or click on it, it does nothing. This actually will not run. We have to add those parentheses. Now, suddenly see how it says def test, and it knows we're trying to call that function. Let's go ahead and run. And ta-da, this is a function. So Python is reading this from the top down, defining test, defining SQFT, getting here and saying, oh, it wants to actually call this. There are no parameters, so we don't have to supply any arguments. You may be wondering what the big deal here is. Why would we even mess around with functions? I mean, we could have just printed this out. Well, let's take a look at a specific situation. Let's say we wanted to call that function multiple times. We're going to say for x in range, and we're going to say range 4. So we want to call that multiple times. Now, we could just write this out like this 4 times. We could do something like this. And you'll see people do that. However, that's not the best way. What if your boss comes and says, well, I want you to do that 20,000 times? Okay. You're going to have a very big file calling that out. There's a much simpler way. You would say for x in range, and then you would call this. So what we've done now is we've created a loop, and we have a lower boundary and an upper boundary, and it's going to call it. So we have not created an infinite loop. It will call our function. Let's see this in action, and ta-da! There it goes, right there. So that's the power of a function. You can define a block of code and then decide when and how it runs. Now, in typical fashion with these videos, I do like to ramp the difficulty up here. So we're going to call a function with parameters. And this is what I mean by this is going to get confusing fast. Remember our little buddy, the SQFT function, which we defined, which we haven't really worked with yet. Let's go ahead and say x equals SQFT. Now, we have some parameters, and it's smart enough to know that it's a param. So we have to feed it some information now. I'm going to say 12 by 8. Bonus question here. These numbers, are these parameters or are these arguments? Well, they're arguments. So these up here are the parameters. They're in the function definition. The values we're feeding it are arguments. And you're going to get people that will, no pun intended, argue this all day long because people get it so confused. All right, let's go ahead and print out the square footage. So the square footage is 96. Now you see just how powerful this is. You can define some sort of logic and then call it on demand when you need it and get the value back from it and use it accordingly. Just a quick recap. What we've talked about in this video is, well, functions are amazing. They're also very complex. It reads from the top down. You have to use the DEF or the def keyword to define a function. Functions can have 0 or more parameters. Those parameters have to be fed arguments. Hello again, everyone. This is Brian. Let's continue our journey into Python 3 with functions and scope. This is a theory-heavy video, but we're going to try and make it very simple. So we're talking about lexical scoping, sometimes known as static scoping, which is a convention many programming languages use that sets the scope or the range of functionality of a variable so that it is only called from within the block of code from which it was defined. However, scopes can be nested inside of each other. So you ever have like a box and a box and a box and a box? That's kind of what we're talking about. And that's why this really will hurt your brain if you're not paying attention. So let's dive in and take a look. So let's take a look at lexical scoping. And I'm going to just put a square out here. I'm going to make it nice and big. And let's go ahead and give it a color. Let's say this is going to be some sort of green. Doesn't really matter what it is. So that would be a block of code. And actually, you've been working in this whole time. This has been called the global scope. Everything we've done so far has been in one giant scope called the global scope. There's other names for it as well, but that's basically what we're talking about. Now, we can actually take another one. Let's go ahead and bring this all the way to the front, and let's set this as a different color. Let's say blue. And this is a different scope. Think of this like a function. Doesn't necessarily have to be a function. It could be like a while statement or an if statement, something like that. So what we're getting at here is you have this big overarching global scope, but then you have these subscopes. Now, to make things a little bit more complex, let's say we have this scope here that's inside the global scope. Let's call this a function, for example. We're going to go ahead and make another one. And let's give this a different color. This is what we're talking about. So you can have a scope with a scope in a scope, like a box and a box and a box. And it gets very, very confusing. Now, this guy here, let's just actually move all of this down here and make it graphically easier to understand. You have your global scope, you have your function scope, and then you have another little, like a statement in here. You can define something in the global and use it all the way down through here, even down into this statement. You cannot, however, do the reverse. You can't define something in the statement and use it backwards up in the global scope. So this is why it gets very, very confusing. And I think graphically, this is probably one of the better ways of really defining this. Just understand that you can have a scope with a scope inside of it and another scope inside of it. You can define something, and as you get more granular, you can use whatever you defined. However, you can't define something at the very granular level and use it higher up. All this talk about scope is, well, confusing. So let's just dive in and look. First thing we're going to talk about is the global scope. This is probably the easiest concept to understand because we've been using it this entire time. That's right. So if I say name and then just whatever your name is, we have now created a variable on the global scope, meaning anything in this application can now use this. This is extremely cool and it's extremely easy. So let's demonstrate this global scope. Functions can access the global scope. So let's go ahead and define a function. Let's just call this test1. Very descriptive name, I know. And we are going to use this variable, which we created in the global scope, in this function. And remember, this function has its own scope that we're now defining. Say print. And to test this, let's go ahead and let's call this function. My name is, and then the name from the global scope. Makes it super, super convenient. However, what we're going to show in this video is that This convenience comes with a cost of complexity, and there's some issues you can definitely run into. Let's do the reverse and show some problems we can run into. So for example, the global scope cannot access a function scope. Seems absurd. We define the function in the global scope. We should be able to access it, but it doesn't work that way. We're going to say x equals 10. Let's go ahead and define a function. Let's call this test2, very super descriptive name. And we're going to say x equals 50. Now you may be going, wait a minute, there's two x's, so it's the same x, but it's really not. Let's go ahead and take a look here. And we're going to say function scope, and then we're just going to print out that value of x. Go ahead and go down here. Let's call this function, just so it's going to print that out. And then we're going to say global scope. All right, so pop quiz, x equals 10, x equals 50. What is this going to print out? It's going to say function scope x, global scope x. Let's take a look. So if you thought both of these would be 50, you are wrong. This is what's going on here. We have x in the global scope. We are now creating a new variable in the function scope and assigning it a value of 50. These are two different variables, so it's treating them differently, even though they have the same name. Oh, this is confusing, but it exists for a reason. It's called name collision. If you have a variable with the same name, you don't want to overwrite that. Let's say this was some magic number, like a password or something, and then we went and kind of goofed it up in a function somewhere. We don't want to break the functionality of the application. So this actually exists to protect us from ourselves. Okay, let's dive deeper and deeper still. So we're going to talk about global scope, function scope, and statement scope all in one. And this is going to really, really tax your brain here. So we're going to make a global variable. We'll say x equals 15. And let's go ahead and just put a print statement, print global x, just so we can see what's going on here. There it is, 15. Now we're going to define a function. So I'm going to say def s3. Ever descriptive name, I know. And I'm going to make x 0. What have we done here? Well, we've created two different variables. We've talked about that a little bit here. And we're saying this variable is 15 and this variable is 0. So I'm going to, through the magic of copy and paste, I have some notes off the screen here just to save a smidge of time. We're going to print these out. Let's go ahead and call this just so we can see what's going on. And sure enough, global's 15, function is 0. Things are working the way we'd expect them to, even though it's a little bit confusing. This exists to keep us from hurting ourselves because you have a concept called name collision. If this were a password or something crazy like that, we wouldn't want to overwrite that and then screw something up somewhere else in the code. Okay, now let's take this a bit further. And we're going to say for I in range, and we're going to really make some people mad here because we're going to do some things we really should not be doing. We're going to say x plus equals 1. Now we're going to say y equals x times I. So far, everything's good, but now this x. You notice how we're 3 layers down. Which x is this really? Well, this is the confusing bit. So this x is actually borrowing from our definition. It's going a bit higher. So think of any time you see the def keyword, we're actually putting some sort of wall or a shield here. Let's actually just draw a line. So it's like we're setting a boundary right there saying you will not pass if I've already named that. Now let's go ahead and do something we probably should not be doing. We have statement X, statement Y. This is perfectly fine. Let's go ahead and run this and see what this looks like. Sure enough, it's working as expected. We can see that statement Y is actually multiplying. Everything's working good. Now let's do something very, very horrible. We're going to grab these and we're going to go backwards through the scope. VS Code adds these beautiful little lines to tell us where in the scope we are. You can actually see it's like a bubble here. So we're at the global, we're at the function, we're at the statement. Now we're dropping back to the function scope. Let's run this and see what happens. You notice how it does work, and it's because we're in this little boundary here, and it thinks it's a safe little playground for us to work at. However, you can definitely break some things and you can cause some issues. I would strongly advise against this. Future versions of Python and even current versions of Python, you can run into some issues, some name collisions, and you can break your code. Now, let's go ahead and take this same concept here and try to go backwards still. And let's go back up to the global scope. So we want to see X and Y. We've defined Y here, and we're able to go backwards into the function scope. Let's see if we can go backwards up to the global scope. And sure enough, we cannot. Name error, Y is not defined. Why are we getting this? What's going on here? This definition is a block of code. It's its own individual little scope. And I've got these arrows here. Global goes to function, function goes to statement. You should not go backwards. However, we've seen you can violate that principle and go backwards, even though we really shouldn't be able to. Or I should say you don't want to, because you can cause some problems. Because if you take that logic and try to go backwards all the way up to the global, you're going to get a name error. Y simply does not exist out on the global namespace. You need to be a little bit careful when you're working with scope and really wrap your brain around this. That will cause problems time and time again. I see people constantly doing this going, well, I defined Y, why can't I use it? And then you have to explain scope to them. Let's run that again, and everything runs beautifully because we've commented this code out. Now, all this talk about scope and functions and all that can get a little bit confusing. So one thing you need to really understand is that functions do not share scope with each other. Let's go ahead and test this out. So I'm going to say def cats, better name, I like cats. So I'm going to make a variable called z, and I'm going to make this 1. Now, what you need to understand, I mean, really pound into your brain, is this only exists in this function. Let's grab literally that function, make another one, and let's call it dogs. Now, z is 3. What have we done here? You see two different functions with two different z's. These are individuals. They are not the same variable, and they cannot talk to each other. So, for example, if I do something like this, what's going to happen? Well, we're going to call cats, we're going to call dogs, and then we're going to get some sort of undefined error. And Visual Studio Code is already smart enough to know it's not defined because these only exist up here. Now, to kind of pound that in here, let's grab this. Let's get rid of these guys. Now we've commented this out. Let's save that. What's going to happen if we call dogs right now? Let's go ahead and say, notice how it's already going, uh-oh, you're going to have an undefined variable. And let's test that. So sure enough, print z, name z not defined. Remember, when you see not defined, it means it simply doesn't exist. Even if we were to call cats, see, ta-da, does not exist. So they do not share scope with each other. If you're ever confused about this, just simply take your IDE and you can collapse the code down if your IDE allows it, and that's what we're talking about. These are individual islands. They don't talk to each other at all. Now, to wrap this up, you may be asking yourself, if functions do not share scope, how do you share information between functions? Well, functions can return values, and we've talked about this a little bit here. So let's go ahead and generate some lucky numbers. I'm going to say define a function called numbers. And we want actually a parameter of steps. Let's go ahead and we're going to say L equal range. And then we want to go from 1 to 20 using the steps. There we go. Go ahead and print these out. We're going to say for I in L. And we're going to go ahead and print I. And this is just so we can see on the screen what's going on. Now we're going to drop back down and we're going to say return. And we want to return that little list that we got from this range here. So what's going on under the hood? We're saying define this function who has a parameter of steps. We're going to say L is range 1 to 20 using steps. I to L, so we're just going to print those out, and then we're going to actually return all of this information we generated. Now, a real-world program would have vastly more complex logic. But now we're going to use that function and get the information out of it. So we're going to make the lotto function. Everybody wants to win the lotto. I know I do. And we're going to say z equal, and we're going to call that numbers function with a step of 3. You may be going, now wait a minute. Numbers doesn't exist. We can't use it. If you're ever confused and your IDE allows it, collapse the code down. You can see numbers exist on the global scope. Therefore, we can call it. We're going down, not up. All right, so now that we have this, we can say for x in z. And let's go ahead and print out our lucky numbers. And we're just going to print that out. Now, let's go ahead and call our lotto function. Notice how we're not calling numbers directly. We're calling lotto, and lotto is going to call numbers, run that code, and return the value, get the return value, and then use it. See, there's our lucky numbers. Major takeaway from this, we've talked about scope, and we've talked about it in depth. Scope can be a little bit confusing, but just remember, it's going to go from global to function to statement. You should not go backwards, and if you do, you're probably going to run into some sort of problem. Although you'll see people do this all the time in Python, and it drives me bonkers because they're going to eventually run into a problem if they haven't already. And a function can call a function, and you can get values from those functions and use them locally. Okay, this video, we're going to talk about functions in depth. Specifically, we're talking about arguments and parameters and different ways of doing things. For example, you can have a function inside of a function. That's crazy. So let's dive in and take a look. Okay, let's start off nice and simple. We're talking about no arguments, no parameters. We're just going to do what we've done before, just so we can have a good base to start with. We've done this multiple times by now, so we're going to just print this out. And we're going to say normal function. This is kind of our starting point here. We're going to go on a little bit of a journey. And what we're going to do is we're going to dive into the mouth of madness and just see how crazy this can get. So we're now going to just call this. You notice how I've put this right here. These are escape characters. Return line feed with some dashes and arguments. We're going to break this up because we're going to have a lot of output in this video and we want to be able to see what's happening here. So I'm going to just copy and paste these as we go. We're calling this function and it works as expected. If any of this seems unclear at this point, you need to stop watching this video and go watch the previous 16 videos to really wrap your head around what we're going to be talking about, because we are going to no holds barred, just dive right into the deep end. Let's take the training wheels off. We're going to talk about positional and keyword arguments. Okay, this is where it's going to get really confusing really fast. So we're going to make a function called message. We're going to say name, message, and then we want an age. So we've got a couple different data types we're going to be working with. Pretty clearly, it's going to be like a string, and an int. So we're going to say print. Hello, and then we want the name, followed by the message. You are, and then however many years they tell us. So fundamentally, this doesn't seem like rocket science, but we can start doing some really, really crazy things. So I'm going to just put that out there, positional keyword arguments. So when we run this, we'll see the output broken up. Let's go ahead and say message. And let's call this as you would expect it. Now, what we're doing here is called positional. You notice how there is name, message, and age. Those are the positions. Think of this like a list. It's zero base, so 0, 1, 2. We don't have to give it an index. It's smart enough to know what the index is. But I'm going to say Brian. Let's say good morning. And then let's give it an age. Let's say I'm 22. Boy, I wish I was 22. I'm really not, but. And that's positional. Go ahead and run this and we'll see, sure enough, hello, Brian, good morning. You are 22 years old. So it looks great. Let's grab this and let's play around with it a little bit here. We're going to use positional, but we're going to use the wrong order. Let's go ahead and screw this up. So I'm going to say 22 and good morning. So really what we're doing is we're switching these around here. The output suddenly makes no sense. Hello, Brian, 22. You are good morning years old. That makes absolutely no sense. It's like a serial killer wrote that or something. All right, so what we've done here is positional, and we've screwed up the order. So how do we fix that? We use what's called keywords. So we're going to do the same thing. We're going to say message, and here we're going to say MSG equals. And you can see this in Visual Studio Code. It's got that parentheses and little bitty block there. It's smart enough to know that we are trying to call the parameter message with the argument of good morning. Now you notice right off the bat, we are completely disregarding the order because message is, well, the second one, and we're giving it first. As you're about to see, it really does not matter. Say age equals, say 46, and then name equals Brian. Let's go ahead and run this. And sure enough, it says, hello, Brian, good morning, you are 46 years old. So now it's working as expected. We don't have to give it a specific order. We are working with keywords. And I wish they would have called this parameter arguments or something like that, but basically it's keywords. So what's happening is Python is taking these parameters here and turning them under the hood to keywords, and it has some sort of internal list, and it's saying, hey, if you give me a keyword and pump it in there, it will just magically know how to line those up and what order they need to go into. You can also do both. So let's just grab this guy. Let's grab this. I'm going to say Brian, and then let's go ahead and flip these around. So you can mix and match these as you want. So you can say positional followed by keyword. Let's run that, see it in action. It doesn't matter which way you do it, it just works. Extremely cool, and I absolutely love that about Python. Let's make this ever complex still. We're going to talk about internal or inline functions. And there is a subtle difference between internal and inline. We're talking about an internal function, which is essentially a function inside of a function. So we're going to say counter. And inside of counter, we're going to immediately call another function or create another function called display. We want to say count equals 0. So really all we're doing is we're saying a function in a function. And notice how it's smart enough to drop us down a line so it knows it has its own scope. And we're just going to print this out, and we're going to say internal. That way we know. I was going to do it something else, but let's just say internal so we know where we are. And then print that count out. Under the hood, this is really complex, but it's super simple the way we do it. We just have a function. We've defined another function. That function gets its own little scope. And we can now drop out here and say something like this. For x in range, say 5, nothing too drastic here. Let's go ahead and call our function display, and we're going to call that with x. So we're saying for x in range, so it's going to do that 5 times, and it's going to say call display 1, 2, 3, 4, 5. Interesting how that works. Let's see this in action here. A little bit of copy and paste action for my notes. We're going to talk about internal functions, and we're going to call the counter function. Sure enough, 0, 1, 2, 3, 4. I always forget that's 0 based. Always trips me up. Okay, so what we're doing here is calling a function which has an internal function, which is calling it internally, and it's just kind of going around inside and doing all this madness for us. So let's take this counter, grab this internal function called display, and try to call it. So we're now going up a notch. And let's just see if we can call this. Sure enough, we cannot. We get a name error. Display is not defined. Remember, when you see is not defined, that means Python has no idea what this is because it does not exist in the scope we're working in. So you guessed it, you collapse that down. Display doesn't exist. It's inside of this scope over here. Gets super cool, but it's also super confusing. So if you're going to use this, be very careful about how you try to call it, or you're going to get some sort of error. All right, let's give you a nightmare scenario. Boss walks in, you're a newbie Python programmer, and he says, I want you to make a function, but I'm not going to tell you how many arguments I'm going to give you. I want your function to automatically figure it out. Well, what we're talking about here are star args, and star stands for wildcard. This is a positional variable length argument. All right, so what are we talking about positional? Well, we've talked about this a little bit before up here where you have a position, and that's not so much what we're talking about. We're talking about this right here. We're going to say def, and let's go multiply star args. We could name this whatever we wanted. Now, we're going to feed that a bunch of arguments, and they're going to be based in a position. So let's go z equals 1 for num in args. And let's go ahead and print that out so we can see what's going on. Now we're just going to multiply that. We're going to say z is multiplied by the number. Now let's go ahead and print this out. A little bit of copy and paste action from my notes, just so graphically in the output we can see where we are. Let's go ahead and call this. I'm going to say multiply, or multiple actually, and we're going to say boss gives us 3 numbers here. Number 1, number 2, number 3. This is what I mean by positional. It's going to take the exact order we give it, 1, 2, 3. We could switch this around and say 2, 3, 1. And you'll see the position changes, 2, 3, 1. All right, very, very simple, very easy to wrap your head around. The major takeaway here is we're not constrained. We can take this out to just some ridiculous level. We could do something like this. See? Works as expected. Let's take that same nightmare scenario where our boss is just a complete jerk, and we're going to say, okay, he's going to come in and say, I'm going to give you random information. I'm not going to tell you how much information I'm going to give you, and I'm not going to give it to you in a specific order. Yes, that's a nightmare. So what we're talking about is keyword args, which is basically the same thing, except for instead of positional, we're using a keyword. We've talked about keywords before, way back up here, how we can mix and match and do all this other cool stuff, but we're going to try and dumb this down and make it a little bit simple because yes, this can get complex fast. Major thing to note is there are 2 asterisks here, 2 stars. So let's go ahead and say def profile. This is what the boss is going to do to us. He's going to say, I'm going to give you a person. And the person is just going to be a bunch of data, and you need to figure out what to do with it. So we're going to print out our person. Now let's jump out of there for just a moment here. And I'm going to say, add our little delimiter here so we know we are in our output. And let's go ahead and call this. So I'm going to say profile. Now it's smart enough to know it's using keyword args, so it gives us that double asterisk. And now it's on us to define what information we're going to give. And I'm just going to say name. And if you're wondering where I'm getting name from, I'm literally just randomly grabbing something out of my mind. It doesn't matter what we give it here. So we'll say Brian, and then let's go ahead and say age equals 46. Let's run this and see what happens. We're printing out this person, so notice it's now converting that into a dictionary. That's right. So now we can just use this like a dictionary. It's extremely cool the way this works. All right, let's go ahead and use an internal function. I'm going to say f display. Let's go ahead and display k. Now we're going to do a little bit of test here. We've covered this in our dictionary video here, where we're going to say if k is in the person keys, then we want to print this out. And if that's super confusing, I would highly encourage you to go back in the playlist and watch the video where we cover dictionaries. So now we can just work with this dictionary directly. So we have a function in a function. This internal function display is just going to say if this keyword is in person keys, because remember it's converting it to a dictionary, then go ahead and print out the key and print out the value. Now that we have our little internal function, let's go ahead and call it. So I'm going to say display, and let's give it a keyword name. Now notice how we're actually hard coding this. You can do different things like this. So I'm going to say name, age, and we were in a meeting and they were talking about adding a pet, but they didn't actually do it yet, which is why we're saying if the keyword's in the keys. Because we've done this if, we don't have to worry about not defined. It's going to print out name, age. Okay. Someone in marketing comes back and goes, wouldn't it be really, really cool if they had a pet? So let's go ahead and add that in there. Now you can see Brian 46 and cat, and we have our 2 different calls here. So we have the first one that does not have the pet and the second one which does have the pet. And it just works the way you would expect it to. And we can now test this for other things. So for example, let's say food equals pizza. What have we done here? Well, we've added a keyword that we're not using. It does not crash our application because it's saying if it's in there, and we haven't even called it. So let's do the opposite here. Let's go here and let's say I don't know what that is. We're just goofing around. Doesn't crash because it's not in there. Very cool, very easy the way this works. Super simple to wrap your brain around. But what we're really trying to drive home here is these are keyword arguments, not positional. The position simply does not matter. Okay, let's wrap this up with a brief conversation about Lambda or anonymous functions. You're going to hear them called Lambda functions. They're actually not Lambda functions. They're anonymous functions. We use Lambda to create an anonymous function. So let's go ahead and define this real quick here. So first things first, we're going to make a normal one. Just as a point of reference, so I'm going to say def, and let's call this make SQFT, so we're making the square footage. We're going to say the width, the default, and the height with the default. And we're just going to return the width, the height. So we're just really getting the square footage here. Super simple, super easy to understand. Go ahead and print this out. I'm going to say print. Actually, I'm going to pause for just a second, and we're going to add in our little delimiter here so we can see it in the output. All right, back to what we're working on here. We are going to print out the square footage, and let's go ahead and do this both ways. We can say width equals, trying to think of a good number here, 10. The height, anybody out in the audience, anybody, let's call it 8. Why not? We can also just say print, and then make the square footage, and let's say 15 by 8. We can call it both ways. Go ahead and run that. You can see, ta-da, there's our numbers. Now, let's use the Lambda keyword to create an anonymous function. I intentionally called it a Lambda function, even though they're anonymous functions, because you're going to hear people say, well, I'm going to create a Lambda function. We're actually using the Lambda keyword. SQFT equals. So what are we doing here? We're making a variable. We're going to say lambda. And let's go ahead and define some things. Now, I want to kind of slow way down. I'm going to plop a note in here. There's a certain format we have to do this in. So we have a variable, the lambda keyword, a list of one or more variables, and then some code. So we're saying lambda. Let's go ahead and say width equals, and let's say 0, height equals 0, colon, and now we're going to our code. So if you're looking at this, really what we're doing is we're saying lambda is going to replace all of this. Then we have our information, and I specifically named these the same so you could see them highlighted on the screen. Let's do that again. So now we have our parameters. Now we have our code. Now, if we wanted to, we could just grab these, and through the magic of copy and paste, instead of a function call to make square footage, we're going to just call this variable SQFT, and it functions exactly the same. See, 8120, 8120. This is just witchcraft. I mean, this is like voodoo magic from old school programmers like me. But so what's really going on under the hood is when you call Lambda, Python is basically making this, but it's doing it all in one line. So as a programmer, it makes your life a little bit easier because it's all in one line, and you just have to remember this variable name. And it exists out in the global scope, so we can treat it just like a function. If we mouse over this, you see it's smart enough to know that it is a call to Lambda. So it is making an anonymous function. I personally am not a huge fan of anonymous functions, but they do have their place out in the programming world, especially if you get into like GUI programming and socket programming and things like that. You'll see people use these very heavily. Some people love them, some people hate them. My personal preference is I like to actually define what I'm going to use rather than relying on some crazy witchcraft. But I don't want to steer you away from this. Lambda is very powerful and very useful. Welcome back, everyone. This is Brian. We're going to talk about packing and unpacking data. Now, what are we really talking about here? Well, we have a problem with arg and keyword arg is that we cannot easily use lists, sets, tuples, and dictionaries. Instead, we have to pack and unpack the data. And that's what this video is really going to dive into. Let's take a look. So let's look at packing data. And this sounds like it's going to be super complex, but actually in the spirit of Python, it's super, super easy. So I'm just going to make a function called pack. And we're going to make a parameter here called nums. And this is a star arg right here, which means one or more variables. And in here, we're going to say, go ahead and print this out. Just so we can see what we're actually getting. Now let's go ahead and call this pack, and I want to pack 1, 2, and 3. Let's see what's actually going on here. Sure enough, it has made a tuple. From here, we can very easily say for x in nums, and then do something like this. Get those individual numbers out of there and see exactly what's going on inside the tuple. Super, super simple to wrap your head around. This works as expected. However, there are some issues here, and let's go ahead and take a look at how we would unpack the data. Okay, packing data is, well, simple, and we've done this before. But what if we try to do the opposite and unpack the data? What are we really talking about here, unpacking? So let's go ahead and make an example. Let's say def unpack, and let's give it 3 variables, A, B, and C. From here, I'm just going to print out unpack, that way we can see what's going on, followed by print and we can just grab those directly. Super simple, probably the simplest function we'll ever write. Say BC, and of course line those up to B and C. Just looking at that function, it's pretty straightforward, pretty obvious what's going to happen. But now let's introduce a problem. I'm going to say num equal, and I want to make a list of numbers, 1, 2, 3. If we say unpack and just give it our variable, what do you think is going to happen? Well, IntelliSense is already telling us there's going to be a problem here. No value for argument, and it says, uh-oh. See, missing 2 required positional arguments, B and C. Wait, what? But I gave it a list. There's 3 elements in this list. What's really going on? Well, what's happening is we have to tell Python specifically, take this list and unpack it. And we do that just by adding a star right here. Let's try that again. I'm going to clear this out. And now it magically works. So what we're driving home here is when you see this asterisk, this little star, no matter what context, whether you're using args or keyword args, or you're using it up here as a parameter, or you're using it as an argument, think of this as telling Python, you're going to be packing or unpacking data. And Python, I want you to take care of all the messy details so I don't have to. As with everything programming related, it's not that simple. Let's look at another issue, the dictionary issue. Let's go ahead and make a dictionary. So I'm going to say D equals dictionary, and I'm going to say name equals Brian, age equals 46, and pet equals cat. Feel free to put in whatever values you want. You just need a dictionary with 3 elements. Now let's go ahead and say print, and say packing dictionary. And let's go ahead and try to pack this. So we're going to call our pack function, and we're smart enough to know now that we need to put that asterisk there because we're going to tell Python, you deal with the details, and we're going to put our dictionary there. Go ahead and clear out our results down here and see what happens. Uh-oh, we've got a problem. It's only getting the keys. It did get the keys successfully, but it's only getting the keys. And remember, a dictionary is a key value pair. So Oh, that is frustrating. Let's try the opposite. Let's try to unpack that. And let's go ahead and say unpacking. Handy little function name right there. And run again, unpack, and again, A, B, C. It's only getting the keys. So you're absolutely right. We have to do it a special way for dictionaries. Let's take a look. Looking at the dictionary issue, how it's only getting the keys, we have to treat this special. So we are going to look at an example of how to pack a dictionary. Now, when you say pack a dictionary, I get this image of putting a dictionary in your backpack and going off to school. And that's kind of what we're doing here. So we're going to say define pack a dictionary. And let's go ahead and say we want to do asterisk asterisk nums. Notice the double asterisk. Asterisk stands for wildcard. So we're telling it we're going to get two things. And if this looks eerily familiar, it's because we're talking about, you guessed it, keyword args. A dictionary is nothing more than a key value pair. So this is exactly what we're talking about, keyword args. Let's go ahead and say print. And let's actually print this out. I want to see what we're being fed here from Pythonland. Nums equals, and then let's just print this out. Now let's go ahead and call this, and I want to say, let's go ahead and feed it some arbitrary data. Just make up whatever you want. As long as you got 3 values, it doesn't really care. I'm just going to say name Brian, age equals 46, and pet equal cats. Run this, and sure enough, nums is equal to, see these little squiggly lines, a dictionary object. So it's automatically done this for us. Basically, under the hood, what it's done is it's called the dict function and converted all those keyword arguments into a dictionary for us. From here, it is ridiculously simple to work with. I'm just going to say print f, and let's go ahead and say packed. And we want, actually, we're going to do a for loop instead of pulling these out one at a time. 4K in nums. Last minute change of plans here. So there is our keyword. And then we want to say equals. And give it our key. There we go. Save run. Let's see what this looks like. Sure enough, packed name, age, and pet. Works as expected. As long as you have that double asterisk in there, you now have access to the entire object as a dictionary. Just to wrap this whole thing up, let's do the polar opposite. We are now going to unpack a dictionary. So let's go ahead and say def unpack dict. And boy, that's a funny name. I'm probably going to get some flack in the comments about that one, but name, age, and pet. We're just going to stick with that kind of little paradigm there. And let's go ahead and say print. We're going to unpack a dictionary object here. Let's go ahead and say print. And you guessed it, it is just ridiculously simple to do this. Do the magic copy and paste. I'm going to speed this up just a smidge. All right, now to call this. Well, how would we actually go about calling this? We have a dictionary object out there. So let's go ahead and reuse that dictionary object. In case you're wondering, it's this guy right here. And I'll actually just grab him and bring it right here. Just recreate the wheel. It's already set, but I'm going to set it again just so we can see it on the screen. And we're going to unpack that dictionary object. Because we're using a dictionary, we need the double asterisk telling it, hey, we are working under the hood with keyword args, and watch this thing in action. So it's going to create a dictionary, and then we are going to tell Python unpack this into these. See? Ta-da! Unpacking a dictionary. Name Brian, age 46, pet cats. So this video, well, seemingly simple, we're actually doing a lot of work under the hood. I should say Python's doing all the work for us. We are packing and unpacking data. We've given examples on how to pack and unpack lists, sets, and tuples, and how to pack and unpack dictionary objects, and some of the issues that arise. Okay, functions and arguments. Functions are really cool, but wouldn't it be cooler if you could use a function in a function's argument? What do we mean by that? So let's say we were going to do something like this, def test, and then in here we would do something like def test2 or test1 or whatever we wanted to do. Not exactly how we're going to do it, but yes, we are going to use functions as arguments. Let's dive in and take a look. Let's dive right in here. We're going to look at a function in an argument. It sounds a little squirrely, but let's take a look here. So I'm going to say def test, and we're going to have some parameters here. I'm going to say name, age, and pet. We've seen that kind of before in a previous video. Go ahead and print these out. So I'm going to say print. Do the magic copy and paste. We can speed this process up just a little bit. This is going to be a super, super simple little function here. So we're just going to print out name, age, pet. There was vastly easier ways we could have done that, but I just want to really print that out one line at a time using the information we've learned so far. So from here, we're going to make another function called getData. And this is pretty common, not just in Python, but pretty much every programming language out there, where you'll have one function that returns some type of data and another function that actually does something with the data. So here we're going to return a dictionary using the, well, same kind of data pattern here. So I'm going to say Brian, enter whatever age you want. I won't tell anybody if you enter, something much younger or older, if you're into that. I don't know. So it's just going to return a dictionary of name, age, and pet. Now we have some fundamental problems here. For example, how do we actually use these two together? Well, there's the standard way, as I call it, which you would just call this standalone getData. But now you have to feed it in like this. Test. And you have to do this really long, annoying you got to get the order right and all this other fun stuff, which is really not that fun at all. And you could do that all day long. And of course, if you change one thing, you've got to change everything else, and it becomes just a royal nightmare, but it does work. We did look at an easier way with packing data, or unpacking data, I should say. And we're going to say test. And now we're going to call getData. But there's a fundamental problem here. If we call it like this, and we're actually calling that function, we are returning a dictionary, but now we need to unpack it. Example, if I just run it, it's going to say missing 2 required positional arguments, age and pet. So now let's just go ahead and tell Python to unpack that. Save and run. Ta-da, now it works. And it's very simple, very easy. You can do it all in one line. Super cool the way that works. Okay, so we're going to cover something a little different. It's a function as an argument. We've already covered a function in an argument right here, where we said test, and then we've called getData with these parentheses, and we had to unpack it. And we've got all these special characters in the special order that we got to get just right, or nothing works. We're going to do something a little bit easier. We're going to say def, and I need a good name. Let's call it funky. Why not? I don't know what name to give it. So we're going to call it funky. And we're going to have a variable called data. So far, everything's very abstract. Nothing's really defined. We just have a variable called data. And we're going to make another variable called d, and it's going to be the result of data. Notice how data is being called like a function, even though it's also a variable. Other languages, you would call that like a function pointer, but basically what's going on is we're saying, grab some function and then call it. Doesn't matter what we name it. We could name this kittens. And then D is going to be the result of kittens. The name really doesn't matter. What matters is we are going to call this as a function. And Python is smart enough to know, hey, that variable is a function pointer under the hood. Do something with it. So we're going to go ahead and print out D. Now to do this, I'm going to say funky, and we're going to reuse our getData function from up here, which is just going to return a dictionary object. So here is the important bit. I'm going to just say this. Notice there's no stars, there's no extra parameters. It doesn't look like this. It's just the word getData. And I'm going to actually put a special note right there. Let's go ahead and run this, see what it looks like. So this is the result right here. It is our dictionary. And in case we are just super concerned with that, we can say D equals, and then D, save run, just to verify D equals blah, blah, blah. So what's going on under the hood here is we are saying our function is going to have a variable. And we're going to take that variable and now treat it like a function. And Python's smart enough to go out and say, okay, funky is getting this guy right here. And we're now converting that to an argument for our function. That is extremely cool. As long as everything just works, we can then go ahead and do something like this. Let's say print. And we can do this a number of different ways. I'm going to do it the long way just because why not? And let's go ahead and go D. And we got to worry about those single double quote issues. Again, there are other ways of doing this. Age. In case you're wondering where I'm getting these and typing it horribly, it's actually from our dictionary object up here. So I know we have a name, an age, and then a pet. So let's go ahead and grab the pet too. Could have done this a number of different ways. We could have done a for loop. We could have, tested to see if it was actually in the dictionary keys, grab the item, however we wanted to do it. And ta-da, just works. Main takeaway from here is we can actually use a function as an argument and then use that variable as a function. Very cool the way that works. Welcome back, everyone. My name is Brian. We're going to continue our journey into Python 3 with the global keyword. This is extremely cool, it's extremely easy, and it solves a complex problem. For example, we've seen this code before. X is 1, we have a function x is 6. If we run this, what's going to happen? Well, let's find out. So we have 6 and 1. Basically, x is two different variables, and they're being treated different because it's two different scopes. Remember, whenever you're defining a function, you're actually defining a scope. So what the global keyword allows us to do is actually modify variables at, well, you guessed it, the global scope. Let's dive in and take a look. Okay, in case you skipped that video on scope, what we're really diving into here is, well, blocks of code. We're defining a function which has its own scope. The problem is Python is lexically or statically scoped, which means if we run this, we have two different variables. However, this is frustrating. If you comment this out, it's going to access the global scope. So what we want to do is to be able to access and modify, and that's what the global keyword does. So first things first, now that we understand that basic premise, let's go ahead and test this code. Sure enough, 1, we can access at a higher scope. Let's figure out how to modify. Let's go ahead and make a global variable. Ta-da, that's it. It's really that easy. Just because we put it on this very first line, there's no padding. This is just right at the edge of the file here. That is now considered in the global scope. let's take a look at the scope issues in depth here. So let's say scope issues, and let's make a function called count, which is going to have some type of maximum number that we're going to count to. Now, without the global keyword, Python is going to get very, very confused very, very fast. Now, let's go ahead and demonstrate that. So I'm going to say counter equals, actually, let's do plus equals. We're just going to increment this right off the bat here. And sometimes Python will let you do it, sometimes it's not. Other times it's going to just completely freak out and not have a clue what you're doing. But before we even run this, you can see right now it's saying undefined variable counter. And this is perplexing because it's literally right here. So remember our conversation, we're accessing it, but now it's suddenly saying, whoa, it's not defined. Oh, that is frustrating. Let's go ahead and try and run that. So let's say count, and let's just try to count to 1 just to see what happens here. Uh-oh. Unbound local variable counter referenced before assignment. Referenced before assignment really is our clue as to what's going on here. What it's saying is it is now making a new variable and then trying to increment it before we've actually assigned it. So remember, Python types are a little bit, well, a mystery. We don't know if that's a string, a bool. Actually, as soon as it's created, it's an undefined. So if you take undefined and you try to add 1 to it, what is the expected behavior? Remember, undefined is not 0. It's just simply there's nothing, literally nothing. It has no idea what type it is. So Python's going to get super confused super, super fast. And let's just continue on with typing away here just to see how bad this can get. We're going to say counter is greater than or equal to the max. Then let's just go ahead and return false. Otherwise, we're just going to return true. See, same problem. So right here, it thinks it's just fine. It actually knows it's an integer, but right here, it's saying it's undefined. This is what I mean by Python gets very confused very, very quickly. Oh, that is frustrating. So we're going to fix this problem by saying global counter. And notice it's got the exact same name. So really what we're doing is we're saying use the global variable called counter and give it this same name here. Save that, and as soon as you save it, you notice IntelliSense is smart enough to know that, hey, this is actually defined now and we can start working with it. And it knows it's an integer. Let's go ahead and just see the global keyword in action here. I'm going to make a variable called limit. It's going to be 5. And I want to increment our counter using that. So I'm going to say for x in range, and we're going to use our limit. Go ahead and get a variable from that function using that limit. Let's go ahead and print it out. We're going to print out our counter. And just for giggles, let's go ahead and print out just done, so we can see it actually worked. Go ahead and run. Sure enough, boom, done. So it's working as expected now, and it's all because of this simple little keyword right here. Now, standard practice, I tend to avoid modifying global variables inside of a function for this very reason. For example, let's just say I were to grab this and make an entire new function out of it. And I go, I don't need that global. I just want a variable called counter. Now I don't need that. Now suddenly, you guessed it, we are right back to the exact same issue. So now it gets very confusing about which counter we're talking about and in which function. You can very easily fix it by just doing this, but then of course now you're going back to modifying a global variable, which is not really a good programming practice. When in doubt, we're going to have a conversation about encapsulation later, but you want to encapsulate or use pretty much everything internal to your scope without going out and modifying other scopes. Welcome back, everyone. In this video, we're going to talk about the walrus operator. The what? That's right, the walrus operator. It's a funny name, and it gets it from the syntax. It's colon equal. And if you look at it, like if you like cock your head sideways, it kind of looks like a walrus. It's got the little eyes and the tusk and everything. But that's where it gets its name. This is a little bit confusing, and this might hurt your brain a little bit. And to make it even more complex, you have to have the right version. This isn't available in Python until Python 3.8 or higher. But what the walrus operator allows us to do is assign a variable from an expression, meaning we're going to take some chunk of code and turn the end result of that code into a variable without having to do a whole lot of complex stuff. In case you're wondering about versioning, remember if you pull up a terminal, and there's different ways of doing this, you can see down in the corner I'm using Python 3.6.9. There are different versions installed. So for example, if I type Python, that's 2.7. If I type Python 3, my system's at 3.6.9. So that's not going to work. I would have to do 3.8. I have 3.86. Just use whatever you have. If you don't have 3.8 or higher installed, this will not work, and you'll have to go out to Python's website and download and install and configure Python 3.8 or higher. Follow the instructions for your operating system. Google's your best friend if you have a problem, or you can visit me in the Void Realms Facebook group. There's details at the end of this video. For our purposes here, we're just going to go down here and we're going to select Python 3 and then select the correct workspace, which should be Python 3.8 or higher. And suddenly everything starts popping up and saying, do you want to install this? Do you want to install that? I'm not going to do any of that for this video. I'm going to apologize if it keeps popping up though. Let's dive in. Let's look at some common issues. And I put the parentheses here for a reason, because that's going to be your biggest issue when working with the walrus operator. For example, if I say y and then walrus, I'm just going to say walrus, len of hello. What do you think we're doing here? Well, let's try and print y out. Uh-oh, I get no graphical error in the IDE because, well, there's really no PyLinter installed. I can install Kite or something else like that, but I just wanted to switch versions and see this thing work, and it's saying syntax error, invalid syntax. What do you mean invalid syntax? I'm using the walrus operator, and I've got the right version of Python. This is what I'm talking about. Let's just grab this guy right here, and let's just put that same thing inside of parentheses here. And I'm going to put some notes at the end here, just for anybody who downloads the code so they know what's going on. And let's comment this bad boy out. Put that at the end there, didn't I? There we go. And let's rerun this. Now suddenly we get the output, len5. It's valid, but according to Python's website, it's not recommended. Why? Because it's just confusing to look at. What is going on here? It's almost like we're calling a function. Remember, in programming and in math, anything inside of the parentheses is pretty much done first. So what we're really telling Python is, as you're reading this, stop what you're doing, crunch all this stuff between these parentheses, and then replace all that parentheses with the value, which is 5. So it's just going to really make a variable called 5. Seems confusing, and it is. 9 times out of 10, that's going to be your biggest issue, is just you forget to put something in the parentheses. So let's go ahead and look at another real world example here. I'm going to say people equals, and we're going to make a list of people. So me, my wife, and the family dog. Big old stinky dumb dog. He's probably down there wanting a treat right now, but he's not getting one because I'm up here making a video. Poor dog. So I'm going to say if n walrus len, and we're going to just get the length of that variable right there. And I want to just say it's less than or equal to 3. Then go ahead and print it out. And we're going to print out n. A little confusing, but what's going on here? I'm saying n is walrus or equal to this expression, the length of people, which in this case should be 3 because I have 3 elements. We're saying if it's less than or equal to 3, go ahead and print it out. But when we run this, we have been betrayed. It actually says 2. What? Come on. Why is it true? Why? Because we forgot the parentheses. Let's just take the same thing and let's just go ahead and wrap it in parentheses here. Rerun it, and sure enough, we get 3. So 9 times out of 10, if you have a problem with the walrus operator, it's because you're missing your parentheses. I am not a fan of introducing new concepts without some sort of example. So let's make this super short, but super confusing because the walrus operator is confusing. All right, so I'm gonna say lines equals, and we're just gonna make a list. And we're going to use a function called canAdd with a maximum of 5, that's the default, which is going to determine whether or not we can add to that list. And we're gonna say, global lines. I don't like doing this because what we're saying is now we can modify this, but I want to make sure Python knows we want this list. We're not creating some new variable. That gets a little bit cumbersome. Not a fan of doing that. When in doubt, you should actually send it as a parameter / argument. Let's work with the walrus operator. Let's unleash our inner walrus. I'm going to say allowed equals, and notice how allowed's not defined. So what we're doing is we're letting the walrus operator define this variable. So if you're worried you're going to get an undefined error, don't worry, it's not going to happen. But whenever you see walrus, think the walrus needs to open his mouth. You should see these parentheses. If you don't, you're going to have a bad time. Let's go ahead and say this is going to be the count. And again, walrus operator, so we need some sort of parentheses. But we're going to use a function, len. We're just going to get the length of those lines. Now we're going to say we want the max. And that looks really crazy and confusing. But what are we doing here? We're creating 1, 2 variables, and we're saying allowed is going to be this code expression here. Oops, if my mouse ever wants to cooperate. This code expression here, and count is going to be this code expression here. Whenever you see these parentheses, you are working with some sort of expression or scope, but usually both. Let's go ahead and print. And we're going to say F, you can enter, and we want the max minus the count more. So we want to tell the user in real time how many more they can actually enter. We're going to drop back down and say return, and we're going to just return whether or not this was even allowed. That looks super confusing, but the whole point of the walrus operator is we've reduced code. We now have a variable that got assigned an expression. We didn't have to say something like allowed equals something, 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 and then put the allowed in the if. It just automatically does all of it for us. To further make this confusing, let's do something that I see people doing all the time. We're going to say while, and then a function is going to return a bool, and we're just going to loop until that function says we can't do it anymore. Say lines, go ahead and append that. And we're going to make another variable called L, and we're going to get the input from the user. Whoa, that's crazy. All right, so we are making yet a third variable here. And let's go ahead and just print out that we're done. Okay, highlight the walrus operator. You can see just in our little example here, we are creating 1, 2, 3 variables. Whenever you see walrus, think immediately to the left is what we're creating. Immediately to the right, whatever's in the walrus's mouth, is what we're using to create it. Kind of crazy. So if allowed and the count less the max, then we're going to go ahead and get the max minus the count, and blah, blah, blah. That gets super confusing. We're going to return a bool. We're going to use that bool, and then we're going to get this value from the input all in one line. Really, really reduces our code, but it also makes it a little bit harder to read. So I'm going to say We're just going to enter some stuff. One, we can enter 4 more, 3 more, 2 more, 1 more, and boom. You entered, and it gives us our nice, neat little list. Major takeaway here. Walrus operator is super convenient, but can be super, super confusing. Whenever you see the walrus operator, think immediately under the tusk, you need the mouth, which are these parentheses, and then whatever's in the parentheses is going to get assigned to the variable, because you're really taking an expression and putting it into a variable. You also need Python 3.8 or higher, or you're going to get a whole lot of crazy errors because earlier versions of Python have no idea what you're talking about. That, in a nutshell, is the walrus operator. Welcome back, everyone. This is Brian. We're going to talk about navigating folders in Python 3. Now, before we begin, spoiler alert, there are multiple ways to do something. And this is true in every programming language on every computer operating system. Basically, as computers evolve, so do the programming languages and platforms that people use to create programs. They get infinitely more complex behind the scenes and infinitely easier to use up front, but they also hide a lot of that complexity, which leads to a lot of confusion, especially newbies, because they say, what's the best way to do something? The short answer is there isn't one. Use what works for you. We're going to cover a few situations, but you're going to see people even in the comments down below say, why are you using that way? Use this other way instead. Again, refer back to the golden rule, use what works for you. Let's dive in and take a look. First things first, what we're going to do is import a module. You may be going, now wait a minute, I thought we were going to work with navigating folders. Well, understand that folders are part of the file system and it can get very, very complex, and a lot of this is baked right into the core of Python, but we need to work with someone else's code. And some of these, the ones we're going to work with, are already baked into Python. We just need to tell Python we want to use them. So we're going to import the OS module. In case you're wondering what a module is, it is a group of code that we can use. Someone else has already written this code. We can just simply use it however we want. So first things first, import OS. So we're importing a module. Once that module is imported, we can start working with it. So I'm going to just make a variable called D, shorthand for directory, and I'm going to say os.get current working directory. In case you're wondering what that is, every single application runs inside of a directory. Every single one of them. They are a file on your system somewhere. That file lives inside of a directory. If you're on like a Linux or Unix or Mac, it's in what's called root, which looks like that. It's just a slash. If you're in Windows land, it's going to look something like that. Now, that is the root of the OS, but chances are you're not actually in the root. You're buried down deep in the OS somewhere. So let's figure out where we're actually at. So I'm going to say print, and let's go ahead and format that, and I'm going to say current. We just want to know where the heck we are in the OS. Sometimes this could be like, navigating the deep blue sea or something. We just don't know where we are. So we're going to get that current working directory, or we could just use our variable, which we've already pulled out. Now I have to put, this is the current directory. Does not mean that every single program runs in this directory. It just means what our program is running in. All the other programs are running in different directories, or even in the same directory. It can be either or. It's super confusing. All right, on my little virtual machine, we are currently in /home/root shell, just the account that I'm on here, /code/python3. So you can see we're not in the root, we are in a subfolder several levels down. So let's say, just for example, we don't really like this folder. We just want to work with a different folder just to see if we can do it. So let's go ahead and change folders. So I'm going to say os.chdir, which stands for change dir, change directory. So get cwd is get the current working directory. We're going to chdir, or change directory. Seems a little confusing to get the terminology down. Now, you can actually hard code this, like let's say we could home, Bob's files, something, or if you're on Windows, it would be like C, whack, whatever you wanted, or you can use what's called a current path, which means you don't have any sort of pathing in there. Again, a little bit advanced. And I'm just going to do ... In case you're wondering what that means, that ... it actually stands for your current directory and its parent. So we're actually going up 2 levels. Sounds a little confusing, but let's take a look here. I'm going to just grab some code here. We're going to print the current and we're going to say os get current working directory. Notice how we're not reusing D, and I'm going to just grab that for future reference here. Let's run this. And we've gone up a notch. So we were in Python 3, now we're in code. So we just simply jumped up to the parent. So when you see ... that's really all we're doing is jumping up a level. Now, we're going to reuse this variable here, and I'm going to say os.chdr, and we're going to jump back to that string representation of that directory. Grab that, paste it, clear this out just for good measure, and run. So we went from Python 3 up to the parent and then back to Python 3. So Python 3 up to the parent and back to Python 3. Navigating the folder structures is very, very simple. If you know the path, it's just ridiculous simple, but you just hand it a string and boom, it just goes. Now that's assuming it actually exists. We're going to cover what to do if it doesn't exist in a future video, but just know that if you try to give it something that doesn't exist, you're going to have a very bad time. Remember when I started this video, I basically said there are multiple ways to do the same thing, and we're going to start looking at some of those. The first one is list dir, and this is probably the easiest way to do it. So we're going to say for f in os, remember that import that we added, and we're going to, anybody, drumroll, list dir, there you go. This is a function, so we have to have our parentheses, and we can specify a directory, we can use the current. Now, if we just print this out, let's just go ahead and print, let's see what this does here. Not a whole lot here. It's just got one file plus this little .vs code. .vs code is this folder right here, which has another file in it. So we're getting folders and files. And if you've got a lot of files in your directory, you're going to see them all. Interesting. So how do we actually determine what each one is? And let's pretty this up a little bit. Notice how this is just Python 3-22, just the name of the script, but we don't get the full path. Let's go ahead and say print. Let's format that. Path, and this is where people in the comments below are going to start arguing with each other. I'm going to say os path, and I want to get the ABS, or the absolute path. This is going to tell us the absolute path of that file. Someone down below is probably going to say, why aren't you using real file or something of that nature? Again, personal preference. This is what I want. Let's go ahead and run that. Uh-oh. Has no, oh. Base sensitivity has come back to bite me. There we go. So now it is working as we expect, path, and it's giving the full path, not just the name of the file. So that's the difference here, is we've got the file name and then we've got the absolute path here. Let's go ahead and make this a little bit more complex. I'm going to say if, and I want os.path. And let's make sure it is a directory. Then we're just going to go ahead and print this out. And we can take this same pattern and just repeat it. So we're going to say if it's a directory, just print dir and then whatever it is. And then if it is a file, just going to go ahead and print file and whatever it is. And let's add one more just for giggles, is link. If you're wondering what a link is, it's a special kind of symbol out there in file land, which basically says, I'm not the right one, go to this other location. It literally just points to another location. You could call them shortcuts or symbolic links. It really depends on your operating system. Notice how this will always return false for Windows prior to 6.0, because Windows before 6.0 did not have symbolic links. And you may be wondering, what's Windows 6? Did we ever get an advertisement for Windows 6? It's just the way Windows does versioning. Microsoft's just kind of dumb sometimes, but Basically, if you got an older version of Windows, that's just not going to ever return true. Let's go ahead and save run. And you can see that our path, it is a file, and then our path, and it is a directory. So it's working as expected, and we can now determine whether it's a file or directory, and we can get the absolute path. So Listdir, along with os.path, is actually pretty complex and does most of what you may actually need it to do. Rewind the video a little bit and you'll remember I said, hey, as computers get more complex, the code gets easier, but details get kind of murky. And this is a perfect example of this. Scandir. This appears in Python 3.5 or higher. We've been using Listdir. And you may be asking yourself, why do we need Scandir? Listdir seems to do just about everything we'd want it to do. Well, Scandir, the big selling point for this is it encapsulated in a class and it is faster. Although I will just say it, unless you're doing some high-end coding, you're really not going to see a massive performance boost, and you may be scratching your head wondering why you're even working with it. But when in doubt, let's just dive in here. And I'm going to say Scandir, and let's go ahead and print this out. Notice how I have E in there. When I run this, you're about to see something magical happen. Ta-da! It says dir entry and then the name. So what does this mean? This is a weird little syntax. Whenever you see something encapsulated in brackets like that, it means that Python is handing us a class. And we're going to talk about classes in a future video, but right now, major leap of faith, a class is just simply a custom data type. It's really a blueprint for an object that someone else has defined. We're going to learn how to build our own classes and blueprints in the near future. But right now, all you really need to understand is we have a custom data type called a dir entry. And when we say data types, we're talking about things like strings, numbers, lists, and things like that. Dir entry is just another data type. Let's go ahead and work with this a little bit here. We're going to say print. And this is what I mean by you get lost in the complexity a little bit here. We're kind of scratching our head figuring out what we would need to print out. So you have to actually go out and read the docs or watch the rest of this video. Let's go ahead and say name. And we're going to say e dot, and we want the name. Go ahead and get the path here. So I'm going to grab this. So the whole purpose of this is to make life a little bit easier, but at the same time, Scandir does work faster than Listdir. And ta-da, it works now. Name path. Let's go ahead and run a little bit of an issue. Now, when I say run a little bit of an issue, we want to get the directory, the file, and the symbolic link, the bools, kind of how we did before. So I'm going to grab this. And this is where it's going to get a little mind-bending here. So if I say e.isdir, is file is symbolic link, you think it's pretty straightforward. You go, okay, let's try this. But what we're doing under the hood is subtly creating an issue. And I'm wondering if anybody out there can really spot this. Let's go ahead and grab this name here. Now that we've done a little bit of surgery, pop quiz, can anybody spot the issue? Raise your hand. So what's going on here? Dir entry .vs code. We said .vs code is actually a directory. See, there it is right there. But it is printing out dir, file, and link. Wait, it can't be all three at once. What's going on here is we're actually calling a function, or at least we should be. I wanted to demonstrate that because somebody out there is going to run into that issue where they forget to put the parentheses and then they have some weird results. Run that again, and you see now it works as expected, but it never actually threw any kind of error. That's the confusing part. So if you ever get some weird kind of results out of Scandir, just make sure you got those parentheses there. Okay, well, let's go ahead and cover glob. And I put glob multiple ways because so far we've covered two other ways to do it. Glob represents a third way, and glob, although it sounds gross, is actually really cool. In short, use what's right for you. We're covering glob because of this, and I put the link here. Typical Stack Overflow question, which is, how do I scan all folders and subfolders, or AKA a recursive scan. And if you kind of wrapping your head around what a recursive scan is, we're in this Python 3 folder. We're going to jump up to the parent here, and I want to know the contents of all of these folders. And if one of these folders has a folder in it, I want to go into that folder and so on and so on. And we're just going to do a recursive scan. Now, in some languages and frameworks, this is not for the faint of heart, but Glob makes it ridiculously simple. So first thing we need to do is we need to import Glob. I don't know why you'd want a glob, but anyways, I wish they'd picked a better name for that. So we're going to change our directory, and we're going to go up to that parent. So we're going to go a directory higher. Now I'm going to say dir, I'm going to make a variable here. This is going to be OS, and we're going to get the current, or say get current working directory. Now we're going to actually work with glob, and I'm going to say for file name in glob. And glob's going to get really confusing, and we're not going to deep dive into all of the parts of glob, but know that you can do a bunch of different things with glob. We're really just scratching the surface. So we're going to say glob. Sounds like you're talking to a drunk person in a bar. Glob. Anyways, so glob, we want to give it a path name. We're going to have IntelliSense help us here. So path name, I'm going to say, is equal to our directory. And we're going to give it some wildcards here. We need to tell glob what to do. I'm going to say anything followed by anything. Whenever you see star, that's our wildcard. And then we want recursive equals true. So we're telling glob, not just this directory, but all the directories inside of it. Go ahead and do your magic. Let's go ahead and print that out with formatted. I want to glob this out. Like stuck in my head now, glob. Anyways, you know, there was probably like a bunch of programmers sitting around a room going, we made this really awesome thing. What do we call it? Let's call it glob. And then they kind of took that seriously. There you go. So glob has gotten a lot of stuff. And you can see I've got other code from other projects in there, including C++ files, make files, text files, other Python scripts that I've worked on, things like that. So glob has gone through and read the contents of all of those. Now, to kind of show that there are multiple ways to do this, let's go ahead and do it yet a different way. So I'm going to say for, let's go current path, folders, and files in OS, our good old buddy os.walk. And basically, we're going to tell OS to go take a walk in our current directory. Now remember, ... is the parent, ... is the current. So we're just going to say OS, walk the current directory, and I'm going to go ahead and say for file in files. This is not so much a recursive scan, but it gives you a little bit of detail here. Let's say go ahead and print. And let's go ahead and work with these. I'm going to say os.path.join. So what we're going to do is we're going to join all of this up. We want to know the current path and the file. And if you're kind of confused about where I got current path and file, it's right up here. So really what OS walk is doing is returning, I believe it's a tuple, and then we're just pulling those elements out of there and then using OS path join to join all that up and make it look something like this. Pretty interesting, pretty easy to understand. So to summarize, there are, well, multiple ways to do virtually the same thing. Each one has its own little pros and cons and little gotchas and different ways of doing it. Use what's right for you. This video covered how to change folders, listdir, scandir, glob, along with OS walk. And you're going to see all of those out in other people's code. And we were talking about recursive, and that has its own set of complexities, which we're also going to cover in future videos. This is the beginner's guide, and we're just scratching the surface of what we can do. Welcome back, everyone. This is Brian. We're going to talk about reading a text file. The main takeaway from this is it is easy. Anybody can do it. So If you're intimidated with the file system, do not worry. This is super ridiculously simple. Let's dive in and take a look. First things first, let's go ahead and get a file name. Now, your operating system's full of files, but we want to read a file and not disrupt any other application. So we're going to read ourselves, meaning this file right here that you see on the screen. Ta-da, we're going to read this. So we have to get the file name to this script. How do we do that? Well, there's a couple different ways. We're going to show how to do a few of them. So we're going to say OS and sys. We're going to import both those modules. You do that just by putting a comma. We could have done it one per line with import module, import module. I'm just going to do it all in one shot. Let's go ahead and say print. And you're going to see this quite a bit out in internet land, where someone is going to say something like this. Whenever you see the double underscore, it's kind of like a built-in little piece of information in Python. It gets a little more complex than that, but just understand that double underscore means built in. And you can see, ta-da, we've got the full path to our script. Now, there is a problem here. Now, the problem is that may not always exist. Sometimes you're going to get into a situation where this just simply does not work. So again, going back to our previous conversation, there's always multiple ways to do something. So we're going to show you what I believe to be a better way. And we're going to use the arguments. Now, args or arguments are usually not a good thing. Usually you want to avoid getting into an argument, but in this case, we want to dive right into them. So we're going to just print out the sys, and we want the argv. What's going on with this? Well, under the hood, when Python calls your script, this guy, Python da-da-da, it actually sends you a list of arguments. You ever, like, in your file browser, double-click a file and your operating system knows what program to open it up in? Those are arguments. So it will call your script, and there'll be another, it'll be like comma, and then whatever you want to work with. So just know the first argument Python's going to send you is, well, the name of yourself, what you're currently running. Makes it super easy. Now let's go ahead and say, we want to get the full path here just to be sure. You want the OS path. We want the ABS path. Now, a lot of folks in the comments are going to say, why are you using the ABS path or the absolute path? Why don't you use this other one? We're just doing this for demonstration. We haven't really dived into the complexity. I'm going to do an entire video on the different types of paths and what they mean and which one's best and so on and so forth. But right now we're still in newbie land, so we're just going to do the ABS path. And then we're going to print out reading whatever this file is. Let's go ahead and run this. And there it is. So it's just simply handing us back a list of arguments. The first one, or the 0 position, is always the script that's currently running. One thing I really want to demonstrate is, does it exist? Well, if we're running our own file, we know it exists. If we're going to run this and read it, we know it exists because we're currently in there editing it. But just for giggles, I want to cover how to determine if the file exists. I mean, that is the existential question. Does the file exist? Do we exist? Interesting. So anyways, let's say if, and let's go ahead and say not os.path exists. You may be wondering what not is. Not is similar to something like not equals to. It's kind of short version for that. But I'm just going to say if not os path exists, and then I want to give it the name of our file, which we got up here. So if it does not exist, then I want to say, hey, print, and let's go ahead and print that file not found. Because if we try to work with some file that doesn't exist, we are going to get an error message. And what we're going to end up getting is something like this, where it's just going to say, file not found error. which would be covered later on. So if you're just churning away and you give it the wrong file name, you're going to have a bad time. But now that we know the file does not exist, we don't want to go any further. So I'm going to say exit. And I have to give it some sort of exit code. And I'm just going to say 1. In case you're curious, a normal exit is 0. And then you would give it some sort of error message like access denied or whatever. But usually vendors will have different exit codes. So I'm just going to say 1, just so we can tell the end user, hey, something bad happened. But because we're reading our own file, it should work just beautifully. So let's run this. Sure enough, works beautifully. Let's go ahead and take this and let's give it a name I know just simply is not there. Nope.txt. Let's run this again. See, file not found, and then it exits out. Works as expected. Now comes the confusing bit. We're going to actually start working with the file. We're going to start with opening the file. And if you get a file not found error during this, it means you have the wrong file path and you did not follow the directions, or something's going horribly wrong with this. So what we're going to do is we're going to say f equals, and we want to call it open. Sounds ridiculously simple, and it is. Now we're just going to give it a path. Now comes the confusing bit. We have to give it what's called a mode. Now, I'm going to do another video on modes, but this one's just going to cover reading text files. So I'm going to say R. It just stands for read, and we're just going to read plain text. But what this whole thing's going to do is it's going to go out in your operating system, make sure that file's there. If not, you're going to get a file not found error, and then it's going to try to open it for reading, and it's going to put the cursor in the file at the 0 position. It's going to hand you a file object back. So this one little line, there is a lot of complexity going on there. Now that we have the file open, let's go ahead and read a line. And I'm going to say line equals, we're going to take that file variable, and I want to say read, and you notice how we get a whole lot of options. Read, readable, read line, and read lines. We want read lines. So we're just going to read one single line, and let's go ahead and print that out. Save, run, and ta-da! Reading a text file. So it read the first line out of our file. Very, very cool. You also notice how it put this little return down here, because guess what? There's a return right there. At the end of this, there is an invisible /r/n or /n, depending on your operating system. Just know that it's also going to include that. So when we print this out, we're going to have to strip that out. But we have successfully read a line. Now, if reading a line was cool, you're going to really love this. We can actually control this. So I'm going to read a number of letters. So I'm going to say chars equals f not read. And notice how it wants a number. So we're going to read 10. Let's go ahead and print this out. And I'm going to actually format this. Say chars. I'm going to put star star. And then what we're actually reading. So if you look at our file here, it says reading a text file. And now the cursor's right here. So let's run this and see what happens. And you see how it says chars star, and then it's got a return line feed, get a fi, and then star. So we've actually controlled how many characters we've read. I wanted to do it this way to really show the complexity here. Notice we've got this hard return line feed here. We may not actually want that. So if you're using the read function, you're going to get some weirdness like that. And that's why I tend to use read line when I'm working with a text file. Now, somebody very observant is going to notice as we've been reading, things have been moving forward, meaning we read a line, then we read a number of characters, and it said get a fi. It didn't start back over at reading. So what's happening here, as we read, there's an invisible cursor, much like in this text document. You can see that cursor's right there. It always starts off at 0. So invisibly, there's a 0 right there. And it's just like a list or a tuple or anything like that. It's a 0-based index, and it's going to start at 0. And as we read, it will move forward. So as it says read line, well, it's going to move there. And then when we say read 10, it's going to move there. So it's going to actually count. So this invisible cursor is going to keep moving. What I want to do now is just show the position. How do we figure out where we actually are in the file? This is a bit advanced and it may not make a lot of sense to you in beginner land, but as you get into advanced file processing, you're going to need to be able to move back and forth in a file. So I want to introduce this concept fairly early. Let's go ahead and say print, and we are going to format this and say position. And I wish they had named it position, but instead they named it tell. So we're going to call the tell function, which is going to tell us the position. Now I want to say of, because I want to know how big this file actually is. So I'm going to say OS, and we're going to call the statistics. We're going to use our S file variable that we have earlier. And I want to know the st underscore size. And if that's super confusing, sometimes IntelliSense will help you out if you're working with an advanced IntelliSense system like Kite or something like that. But you can dig through the documentation, or you can just, trust me, os.stat, file name, st underscore size. So we're getting back an integer. Now the size is the size of the file in bytes. Let's run this. So we are position 31 of 529. And as we add more and more to this, you'll see this position change. Even though it's a comment, the file's growing in size. Let's run that again. Sure enough, 538. Remove that and 530 because we deleted some stuff. So that is how you would determine where you are and the file size. The major takeaway here is as we're reading, that invisible cursor is moving. Now I want to put it right back at the very beginning. So we're going to call seek. And again, this is more of an advanced function, but I want to introduce it very early. This is always a zero-based. Remember our conversation about lists and tuples and dictionaries. It's always a zero-based index. So I'm going to say our file object.seek, and we're going to seek to 0. Now, if you caught that as I was typing, you see this seekable. Some files are not going to be seekable, so that may break if you're doing some custom work. But for our purpose, it should work just fine. We're just going to tell it where to seek. So seek 0 is going to tell this move all the way back up. So if we were working and we're just reading, a seek 0 is going to say go right back up to this 0 spot. Let's run this, and graphically it has no effect, but if we do another read, you'll see it actually start over again as we're about to demonstrate. So now that we understand this invisible cursor and positioning, and we know how to control where it is, and we've set it back to the 0 position, let's go ahead and read all the lines. I'm putting this big long line here. We're going to print this out just to separate all this out so we can see it in action here. What I'm going to say is for L in F dot read. I want read lines. Notice there's read line, which will do a single, and read lines, which will just keep going and going. And we're going to read this entire file line by line. I want to say print. It's going to hand me back a string, so I want to say L. We want to strip that. Now what strip does, it removes any extra white space. So those hard returns, like right here, how we got these little returns, it's going to strip that out. If we don't do that, we're going to get some really funky results, and I'll demonstrate that. So let's run this. See, stopped it right here. So here's the start of our file, and it went all the way down to where we are. Pretty cool, huh? Now, if we comment this out and just grab this, this is what I mean by you'll get some funky results if you don't strip that out, because print automatically puts in the carriage return line feed. Let's go ahead and clear all of this out. You can see how now it's got this extra space in between each line. So that's why we need to call strip. Let's go ahead and put this right back the way it was. And ta-da, it just works. Okay, Systems Resource 101. Anything you open, you have to close. So we are going to now close that file. Think of a file like a door on a really cold day. You open that door, you're letting all that weather in. Now you want to close it. So what close does is a few different things, but for our purposes, it's very simple. It allows other applications to work with it. If we have opened this and the underlying operating system has locked the file for reading, that means nobody else can make modifications to it. Don't worry, ridiculously simple, F close. Always, 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 when you open a file, close it. You don't want what's called a hanging resource. Now, Python can, and most of the time does, close the file automatically when your script's done, but don't count on that. Sometimes you'll see out there, if you open a file and forget to close it, it just stays open forever. Very, very frustrating. So close, you're not going to see anything graphically change, but it is now closing that door so other people can open it and do what they want to do. Quick recap. This video, we have covered the complexities of the file system for reading a text file. Now, a text file is different than a binary file, which we're going to cover in a future video. So we're talking about just plain text. We talked about importing. We talked about getting the current file, determining if it exists, opening a file, reading some lines and letters and all the lines, moving around in the positions, and how to actually close the file. Welcome back, everyone. My name is Brian, and we're going to continue our journey into Python 3, and we're going to talk about how to write a text file. This is plain text, not binary. We're going to talk about writing binary files in a future video. We're going to take what we've learned in the previous video and overly simplify it using functions. The last video was kind of verbose. I want to make life much, much simpler. Our first goal is to simplify mode usage. Now, what are we talking about here? We're going to cover two different modes. We're going to talk about write and append, and they do two totally different things, but we can use the same code. So let's go ahead and make a function. I'm going to say toFile, and let's go ahead and say file name, mode, data. I hear a lawnmower behind me. I apologize if the microphone's picking that up. It's just kind of COVID-19, nothing you can do about it. My neighbor likes to mow his lawn 100,000 times a day. So I'm going to say open, and we're going to open that file name. And we want the mode. Now remember, in the last video, we opened it with the read text, or the R mode. We're going to work with W and A, but they can work very, very similarly using the same code as we're about to demonstrate. I'm going to say for I in range, and we're going to go ahead and say range. Let's just pick a number 5. And let's go ahead and write this out. And I want to say the string representation of that number. You're going to get some sort of error message if you don't do that. Let's go ahead and put a little colon in there, along with the data. And let's go ahead and add in a carriage return line feed. /r/n. Those are our escape characters. We talked about that when we were in string land. So really all we're going to do is we're going to write out the string representation of the number using str to convert it from an integer to a string. And then we're going to add a colon, whatever data we're in, and then rn. Data is going to come to our function as an argument. Now, there exists this tendency to do something like this, and you're going to see this, flush. I'm going to comment this out, but what does flush do and why do people have it in their code? When you write to a file, you have an invisible buffer in the background, or I should say Python does, and that buffer will fill up because you can add more to it faster than it can write down to the disk, especially if you've got a slow hard disk. Think about like embedded systems, how they get really slow. You don't really need to call flush if you're going to close the file. When you're done with the file, you close it. Python calls this automatically when it's closed. However, if you're doing some sort of like sequential writes or something like that, and you want to just write to the file in chunks, you're going to want to flush it periodically to make sure that data gets flushed down to the disk. I wanted to put that there because I know somebody's going to ask, why didn't you flush the contents? You don't need to, because close calls that automatically. And I hate that name, but at the same time, it makes me chuckle because you're going to flush it. And I always think about looking down, as disgusting as it is, looking at a toilet, and you're just going to drop data into the toilet and then flush it down. But that's literally what that does, is it flushes all of that buffer down into the hard drive. So we're going to cover two modes. And the first one is write. When you hear the word write, write will overwrite, meaning it's going to take the existing file, completely erase it, and start from scratch. And you need to be a little bit careful when you do that. Because if you have something sensitive or something you wanted to save, it's just going to obliterate that data. It's just gone. It will not be in your recycle bin. It will be gone forever. So you need to be a little bit careful here. So we're going to write file. And let's go ahead and say, I need some special variable name like file name. There we go. And we're going to call this toFile function. We have a file name mode, a data. So let's just go ahead and grab this. And we're going to call our function here. So we're going to reuse the variable file name. The mode, we're going to switch this to W for write. And the data, we're going to say hello world. Remember, write will overwrite. It will completely destroy that and start over. The other mode we're going to talk about is append. Now, append will add. So write will overwrite, append will add. Now, what this does is it opens the file, seeks, remember we talked about seeking, moving through that file. It's going to go to the very end of the file, and then it's going to start adding to it. Now, this is what I mean by simplify mode usage. We can literally take this and just paste it. And then simply change this to an A for append. And then let's change this to hello again. So what's going to happen here is we're going to call write. It's going to obliterate the file, start over, and then up to 5, it's going to say hello world. And then we're going to call append, and it's going to add to it. All right, the immediate goal of this was to write and append, but I want to read this file back. So I want to use an import, and I'm going to put it all the way at the top of the file. This is not mandatory, but it's almost like an industry standard, if you will, to put your imports at the very top rather than just adding it right here, which you actually could, but let's put it all the way at the top. That way, anything that we've just kind of flubbed through and we've used OS will get it as well. And if we decide to go back and modify these functions in use, we don't have to accidentally import it multiple times. So in short, always put your imports at the top of a file. We're going to say def, and let's go ahead and read file. And I need some special variable name, something that really stands out, like, I don't know, file name. We could name it fuzzy button kitten or whatever we want. All right, so we're going to say if not, we want OS. And let's go ahead and say path exists. So we're just going to make sure the file we're trying to read actually exists. Otherwise, we're going to get some bad errors. Now, instead of exiting, I just want to return right out of this function, not kill the entire script. Now I want to say, we're going to open this up, and this is how just ridiculously simple working with files in Python can be. Give it a mode. And because we've opened something, let's go ahead and before we do anything else, call close. Now, in between open and close, we can do whatever we want to do. For example, I could say for line in f.readlines, something like this. Or if we wanted to really oversimplify that, we could just read the entire file in one line. And we're just going to call read. Now, spoiler alert, if you do that on a very large file, you're going to have a very bad time because you may run out of memory, your little app may crash. For example, if you have 3 gigs of memory and you try to read a 30 gig file, it's just not going to do it. And it'll sit there for 3 hours before it crashes, but it'll eventually crash. That's why we use things like for line in read lines, because it reads it one line at a time, not the entire thing. Okay, our warning about reading all of it in one function if you had a massive file notwithstanding. We're going to leave it like this just for demonstration purposes because we're going to work with a very small file. We're going to see this in action. I'm going to say my file. We could name this really anything we want. Let's name this hello.txt. First things first, we're going to write this file. Just going to call our function. Now let's go ahead and append the file. And let's go ahead and read the file. There's a reason why we're breaking this up into functions, and it's so we can reuse this code. You're going to hear that term a lot in programming, code reuse. Rather than hard coding the file name and then calling, or I should say rewriting this function for every single file, it's just simpler to use a variable and reuse the code. So let's go ahead and run this. And you can see how it says 0 through 4, hello world, and then there are append kicks in here, hello again. Now let's demonstrate this. So let's get rid of this append, and let's just do write. Notice how we already have a file out there, and we can actually open it up, and this is exactly what it looks like. Let's go ahead and get rid of that append, and let's see what I mean by write file will overwrite. This is why it's so dangerous. Hello world 0 through 4, and if we open our file back up, you can see hello world. All of that hello again is gone because it obliterated that file and rewrote it. Now we can do this, and it goes right back the way we want it. Hello again, and again. Major takeaway from this is writing will overwrite, append will seek to the end and add to it, and we can make reading files ridiculously simple. Welcome back, everyone. This is Brian. This is episode 25, working with binary files. So first things first, what is binary? We've worked with plain text, but what's binary? It sounds kind of crazy, almost like something from the Matrix. The harsh reality is binary is something you're really not going to want to work with directly, and I'll explain why. Go over to the Extensions tab, and let's install a hex editor. Now, spoiler alert, you do not need this specific hex editor. You don't even need this IDE. I'm running VS Code. You can just use any old hex editor out there. Hex is hex. Does not matter. As long as you can view the actual hex representation here. Once that's installed, we're going to flip back over to the files, and we're going to take this file that we're in. We're going to right click, and then from here, we're going to go open with the hex editor we literally just installed. You can see we have the hex encoded bytes along with the decoded text. This is what I'm talking about here, decoded. This is what the computer works with. This is what the machine reads. This over here is what we usually work with, the plain text. So for example, pound is hex 23. Then you have 57, which is a capital W, 6F. I mean, imagine trying to type out just like your name in hex. That would be long and frustrating. So when we're talking about binary, we're talking about the raw data the computer works with. It's not something we want to work with directly. We want to work with a representation of that data. So that's really what we're talking about when we say binaries. We want to give that computer a representation of binary data and let the computer do all the hard work for us. We're not working with plain text. We can work with individual bytes that represent plain text, but we're not working with the plain text itself. All right, we need to leave binary land here, and we're going to go back to plain text land, and this is just the file we've been working with. I'm going to plop in some notes, and it's going to just say install the Microsoft Hex Editor extension. Don't really need it to be the Microsoft one, but then some general instructions on how to work with it in case you're following along with these videos. Now we're going to add some imports, and we need to do this step before we even continue with anything else. So I'm going to import random. And what I mean by random is we're not just randomly importing something. We're importing a module named random, which will help us create random numbers. And we're going to import the operator module. This has a little function here called equals or EQ that we're going to use to compare two lists together, just to make sure that the information we're generating and the information we're saving and loading all matches up and everything works as expected. Let's go ahead and work with that random module, and we are going to create some random bytes here. So let's make a function. Let's call this random bytes. And from here, we're going to just have a parameter called size. Let's go ahead and make a list. Absolutely nothing in that list. Now we're going to say for x in range, and we want a range to equal the size. We're getting that from our argument. Let's go ahead and append our list. So bytes, and now we want to actually say random, and we want a range. So I'm going to say rand range. And if you know anything about a byte, it typically goes from 0 to 255. You can do some crazy things, and we're just going to stick with the norm, 0 to 255 here. Very simple, easy for anybody to understand. We're not talking about some crazy encoding schemes or anything like that. Just 0 to 255. That's all we want. From there, we're going to go ahead and return the bytes. So we're just going to return that list. So random here is going to make a random number within a range between 0 and 255. So we can have up to 256 possible numbers. Now, random, you can do seeds and all this other fancy stuff, and then we're not doing any of that. So what it's going to do is it's going to take the current system time and use that as a random number seed. If you wanted something super secure, you would have to do something different, but we're just going to leave everything as default for now. Now let's go ahead and print that out just to make sure we are getting, well, you guessed it, some sort of random list of numbers. So say def and display bytes. Going ahead and we're going to introduce a few concepts in this video here, some things we really haven't talked about. So I'm going to just make a string. Now I want to multiply this. So we're going to say times 20. That looks a little funny, but what we're going to do is we're going to say take this string and do it 20 times. So we're saying this string times 20. Now we're going to go ahead and print out our little list of bytes here. To do this, we're going to use the enumerate function. So I'm going to say for index, comma, item in enumerate. And what enumerate's going to do is it's going to pull that whole object apart into multiple pieces, things that we can use. And you see where it says right there, enumerate object yields pairs containing a count from start, which defaults to 0. So we're going to tell it to take that bytes list and enumerate it. And we don't want to start at 0. We want to start at 1 because people are not computers. We like to start at 1, not 0. We're just going to make this, human readable. Now we're going to go ahead and format out a print, and let's say index equals, and we want the item. Now we've been working with a hex editor, so I want to show you a simple little trick here. We can just simply say hex, and we want to make a hex representation of this item so that we could later compare it to a hex editor and make sure that everything lines up exactly the way we would expect it to. I'm going to grab that little print function, drop back down, make sure that lines up so we're not doing it every single for loop, but after the for loop is completed. And let's test this. So I'm going to just grab our function random bytes and, whoops, grab too much of that apparently. There we go. And let's just say 10, just for now, nothing too crazy. Now I want to go ahead and display that list. Let's just see what this looks like. So sure enough, we are getting a list. It is 1 through 10, human readable, starting at 1. Under the hood, it's actually 0, but we're using this little start here to increment it. And then we have the decimal and the hex representations of that data. Okay, deleted our little test there, and we are going to now move ahead and we're going to write some bytes here. Now, we have to do this a little bit differently. We've been working with plain text and we're working with binary files. This is not human readable. So we have to tell Python, we don't want humans to work with this. We want computers to do it. So we're going to say def write bytes. We want a file name and the list of bytes. Now that list is just going to be a list of integers. So it's a little misleading where it says bytes. This function is going to convert those integers to bytes and store them in the file. We're going to introduce something a little bit different here. It's going to be the with keyword. So we're going to say with. With is going to take some code function that returns a variable and use the variable. So let's go ahead and demonstrate that. So we're going to say with open. We're going to open the file name. We need to give it a mode, and we want to write binary. If we just did a W, it's going to be plain text. So we want that B in there as file. So what we're really doing here is we're saying with this function, run this function, return a variable, and call it file. So with some function as file. Kind of reads like a book. With this as this variable. Now that we've got that variable, we can just work with it directly. I'm going to say for B in bytes. And we can use that variable we got from our with statement, file write. And we're going to take that individual little number, and I'm going to say 2 underscore bytes. It's a little misleading that it's a B representing bytes. This is actually a list of integers. So I very easily could have said I. Doesn't really matter what we call it. So we're going to convert that to bytes. Now we want to convert it to 1 byte. And if you're a computer expert and you understand this, we're going to give it a big order. So I'm going to say byte order equals big. If you don't know what that is, don't worry about it. We're just going to use this just for demonstration purposes. It really doesn't matter unless you specifically want a big or something else. All right, that's it. We're done. Now you may be going, now wait a minute, we have a file object. Don't we have to close it? Shouldn't we do something like file close? Well, no. That would cause an error, and that would not cause an error, but it's really not needed because with is going to destroy this when it's done with it. And when that variable is destroyed, it's going to call close automatically. So we're actually done. You notice as we get more advanced in Python, even though we're writing more advanced code, the code actually gets shorter and shorter and shorter. This is one of the really cool things about Python. And we could shorten this even more if we wanted to, but we're still in beginner land, so this is about as short as I'm going to make it for this video. Now that we've written the bytes, we want to do the exact opposite. We want to read those bytes back. And I'm going to intentionally make this function a little bit bigger than it needs to be just because we're still in beginner land and I don't want to confuse anybody. So I'm going to say def read bytes. And I'm saying that because you'll see people down in the comments going, well, this is very verbose. Why are you doing this when you could do? And they'll put a little one-liner in there and everyone looking at it's going to just be like, I don't understand what they're talking about. So we're going to say bytes. We're going to make a blank list. We're going to say with open, and we're going to get our file name. Now, this is the trick here. We need to do the opposite. We're going to read bytes, not read plain text. And I call it bytes, but it's read binary as file. Now I'm going to do a loop, and I'm going to say while true. Loops are big and scary for noobs, so don't worry. We're going to tell this when to stop looping, so it's not going to enter some infinite loop. I'm going to say b equal file dot read, and we want to read just 1. Now we're not reading the number 1, we're just reading 1 byte from that file. If not b, and I think we've talked about not before, it's the same thing as like something like that, not equals to, but we're just saying not b, Then we're going to go ahead and break. Break will break right out of that loop. However, if we're still here in loop land, we want to say bytes append. Let's go ahead and take int from bytes. So we're doing the exact opposite here. Instead of 2 bytes, we're saying from bytes. So we're taking a byte and converting it to an integer. And it's pretty simple. We're just going to take our B that we read from the file, and we're going to set the byte order if we really, really want to. So let's just do that. All right, now, once we're in there, we're going to drop back down to this level right here, and we are going to return our finished list. Looks big and scary, but really we're just doing the opposite of write bytes. We're just saying, hey, make a blank list, and then with open, get a file, and then as long as we can read 1 byte, append that to our list of integer and return it. Looks big and scary, but it's actually pretty simple once you wrap your head around it. Now that we've got all the pieces together, let's see it in action. This is what I love about programming. It is a lot like working with Legos. Once you get the pieces together, you can make something bigger and better. So let's see it in action. The first thing we're going to do here is create the random bytes. So I'm going to say out bytes. You can call this whatever you want. It doesn't really have to be out bytes. And this is going to be our random bytes function. And we're going to head and let's just keep it at 10. I don't want anything too crazy because we're going to have to see it on the screen. Let's go ahead and display that just so we can see the out bytes. And I'm going to walk through this step by step here. So let's go ahead and run this. And we've seen this before. I've got this kind of split up here. So every time it displays, it'll have this nice, neat little bracket there. Now we're going to write all that to a file. So I'm going to say file path. And let's call this test.txt. Now this will make some people mad because what we're doing is we're violating some fundamental concepts of the operating system. People expect that a .txt file is a plain text, and I'm doing this for illustrative purposes to show you that the file name and extension have absolutely nothing to do with the data that goes inside them. So now that we've got a file name, I'm going to go ahead and say write bytes. And we can just simply take that file name along with our out bytes and dump that to a file. Let's go ahead and run this again. Uh-oh, file name is not defined. Oh, I've got file path, that's why. Shockingly, the variables have to line up. All right, let's try that again. Clear that, run it. Okay, doesn't look like anything happened on the screen, but over here now we have this little .txt file, and if I open it, I get kind of these crazy characters. Well, what is this? This looks like gibberish. Did we have a corrupt hard drive? No. Let's go here, open with our hex editor, and see what's going on here. So if we kind of scroll up here, you can see how we have 1 equals 84, but then we go into a panic and go, it's 54. What's wrong? Well, the hex version of 84 is 54. And then we have F1, F1, 4, 4. You see what's going on here. Somebody out there is going to ask, well, why does it say 0x? That's kind of like the universal representation that we're working with hex data. So in your mind, just kind of blank out that 0x and just pay attention to everything after x. So we have 54, F1, 4, E1, D3, and you can see it's just working as expected now. This is what I mean by a lot of people kind of get into a panic when you tell them you have to work with binary data because they don't really understand this, and they think that they have some horribly bad screwed up computer or that their program did not work well because they look at it and go, uh-oh, it says 54, but I should have put 84, and they try to figure out what's actually going on. This is what I mean by we're not working with binary directly. We're working with a representation of the binary data. We let the computer figure it out for us. Continuing on here, almost done. Now we're just going to take that file and read it back in. So I'm going to say in bytes equals, and we're going to go ahead and read bytes. And we're going to read that file name. There we go. Once we have that, we're going to go ahead and display it. And now we need to go all the way back to the beginning of this video when we said we're going to use the operator import and we're going to compare them. So I'm going to say print, and let's say match. I just want to know if they're a match. Kind of like, what is that dating site? Match.com. It's a match. All right, so I'm going to say operator dot EQ. And now we need to feed it some lists. So I want to say bytes and in bytes. Again, doesn't really matter what you name these. Now, because we are using a random number generator that the seed is based on time, these numbers will change every time I run this because time is constantly changing. Just wanted you to be aware. So if you're expecting 84, 241, 4, blah, 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 you're in for a very big surprise here. Or maybe not now that I've told you what's going to happen. Let's run this, see what happens here. It says match true. So what happened here, and let me scroll this up. We have our output and our input, and of course they line up. Every single thing works correctly, and the two lists now match. So what we've done, long-winded version of this, scroll all the way up here. We've created a list of random integers. It says random bytes, but it's really integers. Then we can display those, and then we can pump those out to a file and then write them as bytes. Then we can read them back and read those bytes into integers and put them back into a list and return that. And we can actually check to make sure everything matches. So what we wrote and what we read now match. The big question is, how would you modify this information? Well, let's say you wanted to do some sort of work. You would do that to your out bytes before you wrote it to the file, and all of your changes would be written to it. See? Our file is right there, and if we go into open with our hex editor, and we get the nice, beautiful representation of it. Welcome back, everyone. This is Brian, and this is episode 26. We're continuing our journey into Python 3, and we're talking about JSON files. Now, it's a little misleading. It doesn't actually have to be a file. What we're talking about is data. And let me just post some JSON data here. And I've got it in these triple quotes. That way the IDE doesn't get all mad. But really what we're looking at is this bit here. Everything between the brackets. So we have the start and the stop, and then we have key value pairs. Now, JSON can get a lot more complex than that, but I wanted to keep it super simple because we're not really trying to learn the complexities of JSON. We're just trying to learn how to use it with Python. First off, why do you even need JSON? What is this? What do you need it for? Well, it is for app to app communications. Now, when I say communications, this could be anywhere from network to remote calls to just simply writing and reading files. JSON is meant to be a data format. So it's not necessarily a file format. You can do all of this virtually across networks, across memory, however you want to do it. But it's an agreed upon format. So let's say I write a program and you write a program, and you want to be able to read what I'm creating. We have to have an agreed upon format, and that's what JSON really is. As you might have guessed, JSON can get a little bit complex. So before we deep dive in, we need some imports. Actually, we really only need one. We're going to import JSON. Makes it ridiculously simple. I know, it's so complex. But we need to import this module because we don't want to reinvent the wheel. We want to use code that's already written and we know works. Let's also go ahead and make a variable. And I'm going to call this file name. We're going to use this again and again. I'm going to call this JSON.txt. Let's start this off super simple here. So we're going to put some dictionary to a JSON formatted string. Say that 5 times real fast. It's a little confusing, but that's what we're going to be doing here. I'm going to make a variable called outd. You can name it whatever you want, but I just want to know that this is the output dictionary. This is what we're going to convert. So I'm going to say the dict function, and I want to make a dictionary that has key value pairs of name, Brian, age, 46, and pet, say cat. So we're going to take this dictionary here, and we're going to output that to a JSON format. So let's grab this, a little bit of copy action there. I'm going to say s equals, and we want to use the JSON module, and we want to dump s, not just dump. Now, if your IDE may show something a little bit different. You may see both dump and dumps with an s at the end. We want the s, which is short version for a string. So it's going to dump out a string. I'm going to feed it our variable there. I'm going to actually do the magic of copy and paste. Put a little note there, just in case somebody's confused about the difference between dump and dump s. Usually when you get dumped, it's a bad thing, but in this case, it's going to make us very happy. All right, so that was actually poetically sad, but we're going to say the string is going to be our output. Let's just run that and see what it looks like there. So sure enough, string equals, and look, it looks like a dictionary. This is what I love about dictionaries in Python in accord with JSON, is they look virtually identical. It's very easy to see that and see exactly what's going on because we have our key value pairs. Let's go ahead and take that and push it out to a file. Now, remember I said as we get more complex with Python, we actually write less code. And I found that to be very true. It's one of the bizarre things about Python. So I'm going to say with open, and we are going to say file name, our little variable there. And we're going to write that. And we're going to make a variable called f. Now we're going to say JSON dump. Notice how there's two of them. There's dump and dump s. Whenever you see that s, it stands for string. We want to dump this. And what do we want to dump? We want to output our dictionary to the file. And I'm going to put some notes in here just in case anybody gets a little confused as to what's going on there. Very, very simple, very easy to understand. Let's go ahead and run this, and it gives us the same output. Now we have this json.txt, and if we open it up, it has the string, I should say stringified JSON, or our actual dictionary in a JSON format. It may look exactly like a Python dictionary, and that's why people often get this confused. They go, oh, you're passing Python back and forth. Actually, we're passing JSON encoded data. It just looks very strikingly similar to a dictionary object in Python. Now let's do the exact opposite. I want to say from string. So we're going to go back up here, and we're going to take this s variable right here. Remember that JSON did a dump s, or a dump string, to this little guy right here. So let's take him, and I want to do the opposite of a dump, which is a load. I'm going to say nd equal JSON. And in case you're wondering about some of the names like dump, yes, Python developers do tend to have a sense of humor, so bear with me on some of these video. And we're going to load s. Notice it's not load, it's load s for string. And we're going to feed it that string. And I'm going to put some notes in here, just in case anybody gets a little confused. So load the dictionary from a string. I have this named nd. You can name this whatever you want. Doesn't really matter. And I'm going to do the magic copy and paste here. Let's go ahead and run this. And you can see our dictionary is now loaded up. Very cool the way that works, and it looks virtually identical, so yes, it will confuse a lot of people, but rest assured, we're working with JSON. Now, in the spirit of doing things backwards, we are now going to load this from a file. So we're back up here where we said with open file in write text as F, and then we did a dump, and we dumped that dictionary out. We're going to do the exact opposite of that. I'm going to say with open, and I want file name. We're going to just read that as plain text as F. And then let's make a variable we haven't used before, so it's strikingly obvious that this is loading it. So I'm going to say file dictionary, or FD, equals JSON. And we want to load, not load S, because that would be a string. We want load, which is going to tell it load it from a file source. And in case you're really curious, no, variable name does not matter. I could actually name this person or P or Brian, whatever I wanted to do. It does not really matter. So now that we've loaded that, well, now comes the complex part. We just work with it. It's really, really that simple. I'm going to say, when I say complex, I'm joking a little bit. This is so ridiculously simple, it's almost scary. If you're coming from other languages and other frameworks, you're kind of like, what? How is it this simple? It's just mortifying. So I'm going to call the type function here, just so we can see what data type P is. This is one of my little kind of gripes about Python is IDEs are great, but if you just open this up in like a plain text editor and not an IDE, you may be looking at this trying to figure out what is load really doing? What is it returning? So the type function is going to print out, or I should say give us back the data type there so we can print it out. And then let's go ahead and print out the actual variable. Let's run this again. So type class dict. So this is a class dictionary. Remember, classes are something we're going to cover in the near future. A class is a blueprint for an object. So this is a dictionary data type, and it is equal to, you guessed it, the information we just loaded back from the file, which is now a dictionary. Very simple, very easy. The main takeaway from this is JSON is a data format used to exchange data between applications. This is an app-to-app communication data standard. People all over the world, different countries, language barriers, doesn't matter, will say, hey, hand me a JSON file. And it's very easy to work with. When you look at it, it is a string. So it's very simple to just open this up in a notepad or a text editor and just modify it if you need to. But it's also extremely easy to work with at a programming level. Welcome back, everyone. This is Brian, and we're talking about imports in this video. Imports allows our code to be used by other scripts, and it allows us to use other people's scripts. But most importantly, really, what importing allows us to do is simplify things. We can actually now structure our code and then import things as we need them. Now, the import system is actually pretty complex, so in this video, we are just scratching the surface. We're going to talk about some real high-level issues, and I want to show you how to split your code into different files. We're going to have to split this into multiple videos throughout this series, so we're going to continually go back to the import system and add to the complexity over time. Let's dive in. First things first, we want to make a separate file, so I'm going to just plop in some notes. We're going to create a file. And I'm going to leave this comment in there for anybody who just doesn't watch this video and just finds the code out on GitHub. It's just going to say, go ahead and look at mycode.py. And we're going to go over here and we're going to actually make a new file. We're going to give it the name mycode.py. And inside of this file, well, we're just going to add some code here. So I'm going to say name equals whatever your name is. Well, I horribly screwed that up. Can't even spell my own name right. Actually, I spelled it right. I just had it case sensitivity wrong. We're going to make a function called greet. And I'm just really freestyling this. I don't really have anything in mind. We're just going to add a bunch of code and functions here. So I'm just going to make a function called greet. We're just going to print out hello and then whatever the name is. Notice the scope here. Name is actually up in the global scope of this file. I'm going to say def, and let's go ahead and say to file. We've already learned how to work with the file system in a previous video. If you missed it, go ahead and go back in the playlist and watch that video. I'm going to say file name, global name. Really don't need to say global because we're not trying to modify it. We're just trying to read it. Python's pretty lenient about that, but just to be safe, we're going to say global and then open file name. We want to write to that file. Again, if you completely skip that video, I would highly encourage you to go watch it. And we're just going to say f write, and we're just going to write everything out to the file. In this case, we're just simply writing the name. We can take this very simple pattern and just change it around. So now we have from file, and we are going to open that in read mode. And then we're simply going to do the exact opposite here. Quick refresher, when we say with, it's going to remove this when we're done with it. So it's going to automatically close that file for us so we don't have to worry about any of that complexity. Okay, so our file is all done and it's not super hard. It's just got a variable and some functions. Let's go back to our original Python file here. It does absolutely nothing. Actually, let's jump back here and make sure we save that. Now, what we're going to do is use import as, and I think we've touched base on this, but we haven't really dove into what's going on here. So I'm going to say import, and you want my code as, and let's just give it a name, person. Could be anything we want. We could call it ice cream cone, kitten, code, whatever we want. But what's really going on here is import is saying import this module. Now, module is a concept we haven't really covered, and we are going to cover in a future video. But right now, when I say the term module, just think about external code, code that's outside of our file. So import is going to look in, and invisibly, there is a little right there. It's going to look in the current directory for something named my code. And directory structures with imports gets a little confusing. We're going to cover that in a future video. So everything right now is in the same folder at the root of your project. So import this file. There's an invisible.py at the end of this, which is, of course, my code. Now, if you misspelled this, it's simply not going to find it. Now we're saying as person. So what it's doing here is it's importing this entire file, this thing that we've already written, as one variable. So it's now creating a variable called person. And you can see how person is now my code. So that entire file is now sitting in this variable for us to use. It gets way more complex than that, but that's about as simple as I can explain it. Basically, we're taking this entire file and converting it into a variable. Now, at this point, I would highly encourage you to test this. Just simply run it. It should do absolutely nothing, but if you had some sort of misspelling or something, you're going to get something like this: module not found error, and then no module named. Named is your key here. The name is misspelled. So let's go ahead and fix that. Just wanted to demonstrate that. Let's talk about some scope issues. We can run this and see that it's working as expected. Let's go ahead and clear that out. Let's go ahead and use our global. So I'm going to say global name. Not name error. Thank you, IntelliSense. Global name. Go ahead and print this out. What's happening here? Name error. Name is not defined. Wait a minute. What? In our file, we have name and we're using it via the global scope. So what's really going on here, and what we're trying to illustrate, is that a module has its own scope. So the global scope of the module is not the global scope of your script or your application. They are two completely different scopes. So even though we can explicitly try to shove this, even though it's already a global, we can try to shove it into the global. It really doesn't help us. It's still not defined. Now, if I do something like this, comment that out, run this, what happens? Same thing. Name is not defined. So it doesn't really matter which way you try. Oh, that is super, super frustrating if you're a newbie. So how do we get the name out of here? Well, remember, we have taken this entire file and converted it into a variable. We have made pretty much our own data type. So we're going to go ahead and print person, or whatever you name that. And now we want the name attribute. And it automatically knows it's a string, so life is now going to be good. Let's plop a note in here just so anybody out in GitHub land can see easily what's going on. Clear this out and run. Oh, it's because I still got this in there. Sorry about that. Let's try that again. All right, so there we go. Brian Karen. So if you were like me and you forgot to comment that out, you're going to get that nasty error. Very good illustration of scope in terms of imports and modules. Anytime you have a new file, think you have a different scope. There are ways to jump between them, but for realistic purposes, they are two different scopes and you should treat them as such. Last thing we need to do is really just do some testing. So we're going to go ahead and test this code. I'm going to add some spaces there, just get some screen real estate. Let's go ahead and say person dot name equals, and I'm going to switch this to Brian instead of Brian Cairns. And then let's go ahead and do person dot greet, call that function. And let's just do person dot to file. Let's give this a very simple name, test.txt. It's just going to dump that name out to a file. Let's go ahead and say person dot name equals Tammy. Go ahead and do the greet again, just so we can see that we did change that variable. Let's go ahead and load that file. Now, as long as our file name matches up, it's going to load it just fine. Go ahead and greet again, just so we can see that we did actually load that name from the file. Let's go ahead and run this, see what happens. So the original name is Brian Cairns. I switched it to Brian, switched it to Tammy, and then we loaded it from the file. We can see we now have this test.txt out here. So in a nutshell, just to recap, imports is a really, really great way of structuring your code, and it really simplifies things. It does have its complexities, which we're going to cover in future videos, and we've touched upon a little bit here with scoping issues. It gets way more complex than that, because what we're really touching on with imports is the cornerstone or the foundation of modules. And unfortunately, before we can dive deep into modules, we got to learn other things first, like, well, classes, which is coming up very, very soon. Welcome back, everyone. This is Brian. We're going to talk about the main function in Python. Now, in case you're wondering what a main function is, in most programming languages, you'll have something like this. And all this is a function literally called main. And when your application executes, it's going to be the first function or the entry point to run. And without a main function, your application simply won't work. Well, as we've seen with Python, you don't need a main function. This works just fine. So how do you get your code to run automatically? That's really what we're going to be talking about in this video. Let's go ahead and take a look at this. So first thing we need to do is determine how our script is running. If you've been following this series in the playlist on YouTube, you know that you can run your script directly and your script can be imported. So we want to make sure we know exactly how this script is being run. So let's go ahead and go print, and we're going to say F. So we're going to format this out and say name equals. Now we're going to use a special variable, underscore underscore name. Whenever you see that double underscore, this is built into Python. We're going to take this and print this out. Let's go ahead and change this to file. And I stated in a previous video, this may or may not work. So if you have problems with underscore underscore file, you're going to want to watch that previous video where I talked about using the system arguments that are handed to your script. This should just work just fine most of the time. Let's go ahead and run. You can see how our name is underscore underscore main. So remember, double underscore means it's built into Python. And the file is, well, the file name that we're currently running. This, spoiler alert, could change, so don't depend on this. And what I mean by that is if we are calling our code based off an import in a special way, the file name will not actually be the name of the script we're currently in. So you got to be a little bit careful there. But I want to highlight those things. The big takeaway from this is our name is underscore underscore main, which means we know Python is running this file directly. This is the main script file. Now let's go ahead and create some code here. Our script really doesn't do anything, so we want to do something. We're just going to make a test function. I don't really care what it does, just as long as it prints something out on the screen so I can see it's running. Now we're going to make a main function here. Notice the name is main. Go ahead and print this out. And let's just, for giggles, go ahead and call our other function here. So really what we want to do is we want this script to automatically run this main so we know what we're doing, and then call this other function and start some chain of events, do some code processing and things like that. So let's go ahead and let's clear all this out. And let's see what a lot of people who are new to Python make a mistake. They go, oh, I know what I'm doing. And they go ahead and run and nothing happens. Oh, that is a bummer. So yes, in Python, the main function really isn't called automatically. We have to call it specifically. Now you may be thinking, I know what I'll do. I'll just go down here and then call main directly. And it will work. Watch, we'll run it and ta-da, it runs. This is the main function. This is the test function. So we are calling it. The problem comes in with this name right here. We're going to demonstrate right after this section. We're going to show you what happens if we run this from a different script. We don't necessarily want this code to execute, meaning if we take this file and import it as a variable in another file, I don't want this function firing off. So we want this to run automatically, but only if a certain condition is set. Let's go ahead and say main. And we're going to print this code out automatically. This is my IDE. You may have to type this, but we're going to say if underscore underscore name equals main, then, and pass is just going to, well, do nothing. So I'm going to take this, call our main function directly. Go ahead, save and run. And sure enough, it runs our main function. So it's saying the name is equal to main. So we know Python's running this directly, a main. Go ahead and call this. Once you've wrapped your head around the difference between underscore underscore name equals underscore underscore main, and you know that means that Python is running this directly, we can do something a little bit different. We can actually take this code file, let me grab some notes here, and we can run this from a different script just to see the difference here. So we're going to create a file called test.py, and I'm going to make some mistakes just to show you what's going on. I often make mistakes, but legitimately this time I am trying to show you what's going on. So the first thing we're going to do is we're going to import this file here. So let's go back here, and I want to say import Python. And notice how IntelliSense is helping us out as code. Now, from our previous video, you know that what we're doing is we're taking this file in its entirety and converting it into a variable which we can use. Before we go any further, let's run this. Notice how we get an invalid syntax. It's got this little, it's called a caret right here, is pointing up at this bracket. So what it's telling us is it doesn't like this. It's simply our file's naming convention needs to change. So what we can do is let's right click this and call this code file.py. The functionality has not changed. So for example, we'll run code file, which used to be the Python 3-28, and you see it's working as expected. It's just the file name has changed. So the functionality hasn't changed, just the name. We're gonna have to go back in here and change the name. Clear this out. And let's run this test.py. You can see how right off the bat, what's happening here is name, code file, file name, code file. What is going on here? We ran test.py, but it's printing this out. So when we hit import, it's going to go through and start reading our file from the top down, and it's going to actually take some actions. So this is a little bit dangerous here. And just for illustrative purposes, I'm going to grab this, go in here, and let's call this test name and test file, just to separate those out. Clear this and rerun. Now you see they're both firing off. Even though I'm running test.py, import is happening first. So it's saying import code file. It's going over to code file, executing this code. It's not executing our functions. And because the name is different, it's not executing this. See, name is code file. So the name is no longer __ main. The name is, well, simply the short version of the file name, code file. Doesn't have the directory, doesn't have the extension of .py. That's why we need this if name equals __ main. So now in here, we can actually call this directly. Save, run, and see it in action. Sure enough, this is a test function. Main never fired off. This may seem a little bit confusing, so quick recap. You have to be a little careful how you name your files if you're going to use them as an import. Some characters are just simply illegal, like the dash you saw earlier. If you're going to run automatically, you want to check the name is equal to __ main, because if we're running this file as an import, it's going to give us the name of the file with no underscores in front of it. This is not guaranteed to be the name of the file. Python can send us anything we want. The point being, __ main means that Python is running this directly. And just to illustrate that, we're going to run the code file again. And see, name is __ main. Welcome back, everyone. This is Brian. We're going to talk about import madness in this video. And yes, we are going to deep dive into, well, insanity here. So what we're talking about is __ init. What is it and why do we need it? First things first, we need to make a subfolder and add some code to it. So I'm just going to plop some notes in there. We're going to make a folder and let's literally call it sub. So I'm going to go up here. I'm going to say new folder, sub. And inside of our subfolder, you got to make sure you got that highlighted. Your IDE may be different depending on what you're working with. We're going to add 2 files. The first file we're going to add is going to be called, well, very simply, test.py. And we're going to add some code. And just for the sake of time, I'm going to copy and paste just a simple function, do test, which just prints out do something here. Really not award-winning code by any means. Let's also add another file. And this file has to be named __ init __ Remember, whenever you see the double underscores, you're thinking something internal to Python. Now, there's a lot of debates out on some forums on whether or not you actually need this. And legacy versions of Python, you actually do. More modern versions of Python, it's debatable, but I'm putting it in here just so we understand it. I'm going to paste some notes here, and it's quite a bit of notes. This is needed because we are in a subfolder. Whenever you see folder, I want you to think in terms of modules. Remember, we've talked about modules just a little bit, but a module isn't just simply a file. It's an entire folder structure. And the problem with creating some sort of folder structure is that Python needs to understand how to work with that folder structure. So in its simplest case, init.py can just be an empty file, but it can also execute initialization code for the package. That's how complex this can get. So if we're working with something like a socket server or a database or something like that, we can actually initialize some code. We could say like port equals 80, or the username. You'd never do this in production, but like the username would be admin or something like that. You can actually specify all that right in this file. So we are using this very simply because we want to work with this file and we want Python to understand how to work with this file. So we're going to modify it just a little bit here. We're going to say from .test import star. We've seen import before, but we haven't seen this. What is going on here? So what we're doing is saying from .test import star. The from is just basically saying go out and find this. And we have this little period here. If we omit that, we may have some bad things happen. It may not actually know what we're trying to do here. So we have to put that in there in most cases. And then magically it knows this is the directory. If you're ever confused, dot is the current directory, and dot dot is the parent. So basically what we're saying is from the current directory, and then take a file named test. There's no .py at the end of it. Go ahead and import, and then everything. So we're saying take the entire contents of this file and put it right into Python. Let's go ahead and play around with the imports a little bit. So we're going to flip back to our main file here, and we're going to play with imports. So let's go ahead and try and import it a couple different ways that we've tried in the past. We're just going to simply say import sub.test as code. And now code.doTest. We can actually do this. Look at this. Now if we run this, everything works just fine. But we have skipped over this initialization file. An older version of Python's this may not work. You might run into some little bit of trouble here. And if you try saying like from the current directory .sub.test you may, depending on your Python version, run into something like this. Invalid syntax. So how do we import this file? And if we had other files as well, you guessed it, we need this initialization file. And there's a special way we have to do this. So what we're going to do is jump right back here, get rid of all that, and we're going to say from. Now remember, when you see the from keyword, we're saying go find a location. So from sub is the name of the folder. So from this folder, go ahead and import star. So we're saying from this folder, import everything. Now that's big and scary, because what if there's thousands of files out here? That's right, we're going to import thousands of files. And that's where this __init __.py really comes in, or the initialization file, we'll just call it for short, because it's going to instruct Python on what to do. There may be some files we want to import directly, and there may be some files we don't want imported automatically. We may want to set some variables or some settings or some file structure. We would do all of that right here, and we could call functions if we had to. It goes way, way deeper than that. Again, we're still in beginner land. And if we really wanted to, we could get a little funky with this. We could say something like from sub import, and then a specific file. Now remember, that would be test.py, but you don't need the .py, as code. So we're saying from the folder, import a file as this variable. Looks a little verbose and it seems a little confusing until you really wrap your head around it, but it's super, super simple once you get it down. The major takeaway here is if you have a subfolder, you should include this __init __.py, or the initialization file. If you skip this step, older versions of Python will just simply not work, and you may have some weird issues. And if you want to do any sort of initialization at all, this file is pretty much a must. Okay, once we've gotten to this point, really there's only one thing left to do, is actually see it in action. So we're going to call the code here. I'm going to say def main. And if you are with me here and you try to do something, the IntelliSense in your editor may betray you. Got to be a little careful. So I'm going to say main, and for the moment, I'm just going to say pass. Remember, pass in Python means do nothing. And if name, let's go ahead and go down here, equals. Following along from the previous video, we're saying if the name is equal to main, go ahead and run this function automatically. That way, if we were to import this file, it's not going to kick off this code. Let's go ahead and get rid of this, and we're going to say print. This is the main function. And let's call our imports. Now, because we've done from sub import star, meaning import everything, it's going to go in here and it's going to read this initialization file and say from test import star, and it's going to import all of our code. We've got this do stuff out here. So through the magic of old copy and paste, I can grab that, jump back out here and say do test. And we can just call it directly and it just works. See, do something here. And because we've done from sub import test as code, we can take this and we've just basically said do the same thing, but put it inside of a variable. Now I can say code dot do test. Very simple, very easy, works as expected. So which is the correct way? Which one of these should you use? Personally, I tend to lean towards this second line here, simply because importing from everything, what if you have a name collision? What if there's like a test2 file that also has the same do test function? You want to be able to separate those out into two different variables or two different scopes. Remember, each file is kind of a island in itself as far as scope goes. At least that's how you should think about it in your mind. So the major takeaway from this is, well, the initialization file matters. And if you omit that, you may have a bad time in Python land. You really need that to initialize how Python does things. And there are different ways to import, further muddying the waters on import madness.